बैकग्राउंड हटा दें क्या?
आगे वाले को ऑक्यूपाई कर।
ये वाली ऑक्यूपाइड है। पेज पे आना नाम के साथ मैंने देखे रहने। नमस्कार। सड़क रखरखाव के लिए नेटवर्क सर्वेक्षण वाहन के अनुप्रयोग विषय पर एक दिवसीय कार्यशाला में आप सभी का हार्दिक स्वागत है। मैं निदेशक महोदय से आग्रह करूंगी कि वे गणमान्य अतिथियों का अभिनंदन करें। इससे पहले ladies and gentlemen, we are about to commence our event by lighting the lamp of knowledge and wisdom. It's a symbolic moment that signifies the dispelling of darkness and igniting our thoughts. I request our dignitaries to please do the honors.
कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापम् सन्ध्यादीपनमोऽस्तुते ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः ओ दीपब्रह्मरूपस्त्वं
बहुत बहुत धन्यवाद माननीय respected director CSR CRRI Professor Manoranjan Parida, our chief guest Shri Dharmananda Sarangi ji, Director General Road Development and Special Secretary Ministry of Road Transport and Highways Government of India, our guest of honor Professor Praveen Kumar, Head Civil Engineering Department Indian Institute of Technology Roorkee, Dr. Pradeep Kumar, Chief Scientist, CRRI and Workshop Coordinator, Shri Sunil Jain, Head PD Division, delegates, invitees, industry partners, sponsors, media, colleagues, and ACSR students present in the auditorium or joined virtually through live streaming. This is Dr. Neelam J. Gupta, Senior Principal Scientist in CSR CRRI, and it's entirely my pleasure to welcome you all to this one-day workshop on network survey vehicle applications for maintenance of road infrastructure. Network survey vehicle plays a crucial role in the maintenance of road infrastructure by providing detailed and comprehensive data that aids in decision making processes, asset management, performance monitoring, safety improvement, and effective planning and budgeting. We are extremely delighted that today we have with us Sri Dharmananda Sarangi, DGRD and SSMORTH, and Professor Praveen Kumar from IIT Roorkee. Before we begin the program, we would like to welcome them with a token of delight and gratitude. I request our Director CRI to welcome our chief guest for being a significant part of this event by presenting a workshop souvenir. Sure. I again request Director CRI to welcome our guest of honor with the workshop souvenir as a token of love and gratitude. Backdrop. दे दीजिए. Thank you, sir. Now I invite Dr. Pradeep Kumar, Chief Scientist and Workshop Coordinator, for his opening remarks.
Thank you, Dr. Neelam. Respected Chief Guest, Shri Dharmananda Sarangiji, Director General, Road Development and Special Secretary, Ministry of Road Transport and Highways, Government of India. Guest of Honor, Professor Praveen Kumar ji, Head of Civil Engineering Department, Indian Institute of Technology, IIT Roorkee. Professor Manoranjan Parida ji, Director, CSIR CRI. Shri Sunil Jain, Chief Scientist and Head Payment Evaluation Division, CSIR CRI. Other distinguished guests, CRE Chief Scientist, Head of Departments, other colleagues, participants, students, media, ladies and gentlemen, good morning. Namaskar. So on behalf of the organizing committee, it is my great pleasure to extend a warm welcome to our esteemed chief guest, Shri Dharmananda Sarangi ji, Director General of the Ministry of Road Transport and Highways and Special Secretary, and Professor Praveen Kumar, Head Civil Engineering Department, Indian Institute of Technology, Roorkee, and all guests present here and through online to this workshop on network survey vehicle applications for maintenance of road infrastructure. We call it NSV AMRI 2024. We are deeply honored by the presence of our chief guest and guest of honor and other distinguished guests whose leadership and vision have been instrumental in advancing the nation's road infrastructure. I also welcome all the sponsors of the workshop. We have six sponsors: Messrs. Poet Solutions Private Limited, Hyderabad; Messrs. Roadworks Engineering and Consultants Private Limited, Hyderabad; Messrs. Complete Instrument Solutions, Gurgaon; Messrs. IRSM, Hyderabad; Messrs. Khanna Designers and Consultants Private Limited, Gurgaon; Messrs. Blue Ocean Systems, Mumbai. Thank you for sponsoring this event. I'm happy to share that in this workshop, sir, that the first network survey vehicle system was successfully implemented by CSIR CRI to collect road inventory and payment condition data for 40,000 kilometers of national highways with the support of Ministry of Road Transport and Highways during 2006 to 2010. Since then, CRI has been continuously providing technical services and training to the nation on an NSV systems across the country. The purpose of this workshop is not only to highlight the potential of NSV technology, but also to explore how we can effectively utilize the data collected to improve our maintenance strategies. Through a series of presentations and discussions, we aim to develop a deeper understanding of the best practices of NSV application and to consider how these practices can be standardized across the country. So, this is the main aim of this workshop, one day workshop. So, once again, I extend my heartfelt thanks to our chief guest and guest of honor, Director CSIR, CRI, experts, panelists, sponsors, students, and all participants for your presence and support. We look forward to a day of fruitful discussions and valuable exchange of ideas. Thank you very much. Thank you.
Thank you, Dr. Pradeep. Now I invite Director CSRCRRE, Professor Manoranjan Parida, for his welcome address.
गुड मॉर्निंग एवरीवन आप सभी को नमस्कार आई एम रियली हैप्पी that we have such a distinguished gathering for today's workshop. Our respected chief guest, Sri Dharmanand Sarangi, DGRD and Special Secretary, Ministry of Road Transport and Highways, Professor Praveen Kumar, who is the guest of honor, heading Department of Civil Engineering at IIT Roorkee, one of the oldest institute of civil engineering in the country, more than close to 177 years. And he's also MRT's chair professor. Then Dr. Pradeep Kumar, coordinator of the program, Sri Sunil Jain, head payment evaluation division, divisional heads of CRI, my scientist colleagues, technical staff, ACSR students, invitees, sponsors of the program, media, ladies and gentlemen. It's my great honor and privilege to welcome all of you to this workshop on network survey vehicle applications for maintenance of road infrastructure. Dr. Pradeep Kumar has already highlighted the studies which has been done. Currently, we are executing a road maintenance study for the state of Odisha, which involves 23,000 kilometer of state network. And before this, a statewide road management study was completed for the state of Kerala. So, for which network survey vehicle has been very extensively utilized. The network survey vehicle based data collection for the state of Odisha is complete, and we are in the process of developing maintenance recommendations. So the importance of utilizing network survey vehicle is it's very well understood. In fact, other than the two statewide projects, we also utilized network survey vehicle for the Dwarka Expressway before it was open to traffic, and it was opened by Honorable Prime Minister of the country. So just to tell a little bit about the institute, CRI was created 1952. We have 7 decades of existence, and we operate through 7 R&D divisions. So one of the division is Payment Evaluation Division, which is hosting this particular workshop. Other than that, we have Flexible Payment Division, Rigid Payment Division, Geotechnical Engineering Division, Bridge Engineering and Structures, Traffic Engineering and Safety, Transport Planning and Environment, And we are very fortunate to have traveled through the entire highway development of the country, all through post independence. So the basic idea of this workshop is to develop awareness with respect to these particular say deployment of network survey vehicle for all kinds of road network. And we understand that currently we do not have a IRC document with respect to the network survey vehicle. Availability of such a document will help in standardizing the process and more objective utilization of these modern equipment. While we are very fortunate to getting sponsorship patronage of Ministry of Road Transport and Highways with different academic institutes also we have collaboration. As of now, we have more than 22 collaborations with different IITs, NITs, central universities. The basic idea is that our scientists also take up joint project and they also pursue a PhD program with different IITs in this particular pavement evaluation areas, two of there were two PhD programs which were done in association with IIT Roorkee. Professor Praveen Kumar is here. Currently, also we have scientists those who are pursuing PhD at IIT Roorkee. So we are not operating on a standalone mode. We operate in collaboration with academic institutes, with industry partners, because CSR, the I is very important. The industry support has been instrumental not just these particular kind of workshop, but we get a problem statement on which we can work and develop creative solutions, develop various standard codes of practice. So once again, I thank DJRD for sparing his very valuable time. Monday morning and the first hour, this is the golden hour. The visit started with his visit to the expansion joint facility installation process, and because of which we got slightly delayed. And Professor Praveen Kumar also sparing a day for us to be part of this workshop. So thank you all for your interest, support, and active participation in this workshop. Thank you all and Jai Hind. Namaskar.
Thank you very much, sir. So, ladies and gentlemen, we are delighted to welcome our guest of honor, Professor Praveen Kumar, Head Civil Engineering Department in IIT Roorkee. It's my privilege to introduce him. Dr. Praveen Kumar is a distinguished academic and researcher in the field of transportation engineering, currently serving as a professor at IIT Roorkee. With a robust background including roles as head of the civil engineering department at IIT Roorkee, former director of NIT Delhi, and significant contributions to the Central Road Research Institute in past, he has demonstrated exemplary dedication to his field. He holds his degree of B Civil from MR Engineering College Jaipur, ME and PhD from University of Roorkee, it's now IIT Roorkee. His academic achievements are exemplified by his extensive publication records, patents, and numerous prestigious awards such as CSIR National Prize, highest award of Pandit Jawaharlal Nehru Centenary Award by IRC, Best Paper Award by the Institution of Engineers, Best Teacher Award by Air India, Outstanding Teacher Awards by Indian Institute of Technology, Roorkee. He has adjudged as a star performer for overall performance by IIT Roorkee. His expertise in low-cost road development has been recognized by institutions like AICTE by honoring him as Young Teachers Career Award. Dr. Praveen Kumar's impact extends beyond academia as evidenced by his pivotal role in the Pradhan Mantri Gram Sadak Yojana, where he has overseen national level initiatives and trainings. As a mentor, he has guided 17 PhDs and 95 MTech theses and 9 PhDs in progress, showcasing his commitment to nurturing the next generation of scholars. His influence also extends to his involvement in the important nomination roles for various esteemed academic institutions in India. President of India had nominated him as visitors nominee for selection committee of Civil Engineering Department of IIT Delhi, IIT Madras, IIT Jodhpur, IIT Bhubaneswar, IIT Hyderabad, all NITs and Banaras Hindu University. He is also a council nominee in Board of Governors of IIT BHU. Presently, he is holding the professional chair sponsored by MORTH for the term of 3 years. Sir, we are eager to hear you. Please enlighten us with your precious words of wisdom, sir.
Today's chief guest, Shri Dharmanand Sarangi ji, uh, director of CRRI, and my Guru Bhai, Dr. Manoranjan Parida, uh, chief scientist and head of PET division, uh, Shri Sunil Jain, and convener of this workshop, Shri Pradeep Kumar, my old friends, my colleagues of those days when I was in CRRI and present here, other staff of CRRI, my students who have done some degrees from IIT Roorkee, delegates, and uh, Dr. Neelam Jain Gupta. I am delighted to be here at CRRI after a few years. Whenever I come to CRRI, I feel it as Garvapsi. Garvapsi or homecoming, because I started my career from here only. When I joined CRRI in 92, I was having only theoretical knowledge about the roads. But during the tenure of 6 years here, I came to know about everything, how to make the roads, how to judge the roads, how to evaluate the roads. When I go to the memory lane of my last career, though I have completed more than 25 years at IIT Roorkee, but before that, for the 6 years when I was here, it gives me proud that I was here, I was part of this institution. I enjoy the memories of those days, even this hall, where I have organized many functions in the 6 years there in seminar hall, in this hall. So I remember all those days. So today I want to recall only all those days instead of taking other things. I remember I was in soil stabilization and rural roads division, which was later merged to geotechnical division. Now SSR division is not there, but it was there at that time. Shri AFR Murthy was our head. And the first project which I did was utilization of waste material from your Visakhapatnam steel plant. I was part of the team which supervised the construction of two roads, Anakapalli Pulimadaka road. Those who are from Andhra Pradesh, they may be knowing those roads now also. I remember those names. It was because I say it was my first love for the research. So I remember all these days, all these works, all these researches, all these projects. I still, when I teach in my class, give these examples of CRRI, because those projects which we did at CRRI are still uncomparable with the projects which we do now, because as professor we are just supervising, we are not going in detail, but at CRRI what we did, it was with our own hands. So I remember two roads, Anakapalli Pudimadaka road, and other was the Bhimunipatnam Narsipatnam road. We utilized the granulated blast furnace slag coming out from the Visakhapatnam steel plant. It was used in the widening of these two roads. Later, we used Benkelman beam to evaluate the roads. Of course, nowadays you have this new vehicle which is far more superior than those days. But that time it was the only way we use for the functional adequacy. We utilize the dumpy level. For the structural adequacy, we utilize the Benkelman beam. Second project we did for the Bokaro steel plant. In the first Visakhapatnam project, we have used only GBFS, while in the Bokaro Steel Plant project, where we constructed a road within the campus of Bokaro Steel Plant, it was having all type of materials like steel slag, GBFS, and many things. The third project, which was the ultimate project for the steel slag utilization, was for the Rourkela Steel Plant. We did that project, and again I remember the name of that road, that was uh, Jaraikala Bandamunda road. Our chief guest is also from Odisha, Our director is also from Odisha. They may be having some idea about that road. That is Banda Muda Jaraikala road. And there we utilize all the materials which was coming from there. And not only all materials, we utilize it in all the layers also first time in the country. We used the French latier technique, grave latier technique, which was a French technique. In that, the waste material was utilized in all the layers, including the top layer of the bituminous construction. So again, we did the evaluation, we did the design and all these things. Then again, one project came to us that was, all of you are in Delhi, you may be knowing the second Nizamuddin Bridge. Second Nizamuddin Bridge, which was at that time known as the Friendship Bridge, because the bridge was made by the Japanese company Nippon. That is why it was known as the Friendship Bridge at that time. And CRRI was given the task of making the approach road of that bridge using the fly ash. You know, fly ash is a very problematic material. Its optimum moisture content is more than 25%. And when it is dry, it flies. The name is fly ash. That is why it flies when the name is when it is dry. And that is why fly ash is always put in wet form. But the problem is there were many researches in the country where they have mixed fly ash with lime, cement, bitumen, many things. But that was difficult. At that time, in a lighter vein, people used to say that if you collect all the research papers, then length of that string will give more than the actual road construction using fly ash. Everybody was doing research on fly ash, but no road was being constructed with fly ash. Why? Because it was very difficult to mix fly ash with anything. As I said, in the dry form, you cannot store it. In the wet form, you cannot mix it with anything. So CRRI team, I was fortunately part of that team. We were having many persons. And in that, we use the technique of compartment. Compartment means we utilize the fly ash layer, soil layer one by one. It was about 9 meter height embankment was there. On the side, we have 1.25 meter side of it, having the stone pitching also, so that it was flowing along the water of Yamuna river. So if the water enters with the fly ash, it will flow like water. So that is why it was done. It was a very risky project because if it fails, people will say on the one side you are using the Japanese company to make the construction within 1 year. You know, in our country, the bridges were taking time at that time about 10 years in a bridge. Nowadays, of course, MRTH is doing wonders. They are making the bridges in 2 3 years. But at that time, it was taking 10 years. And Japanese company was saying we will make it one or 1.5 years. So you are making the construction of bridge with the Japanese company, and you are making the experimental approach road. If it fails, then it will be criticized by all. But the Ministry of Environment was saying that let us fail it, even if it fails, let us see. But if it is successful, then it will pave the way in the country to utilize the fly ash in the embankment construction. So it was done. It was a success, though there were many challenges. Like once there was a heavy rainfall, the water entered the layers and it went down to the fly ash, and the optimum moisture content of the fly ash layer was increased from 25% to 35%. Then the upper layer was removed again. It was shown to the sunlight, and it was again compacted, and it was a successful experiment. After that, throughout the country, people started using fly ash in the embankment construction. Of course, there were many other uses like making the brick, etc. But still, you will find that the fly ash mission says the best utilization of the fly ash is in the embankment construction because it utilizes people. So that was the story of those works at that time when I was with you in your institute. And again, my name of my institute, my group for the department was soil stabilization and rural roads. So second part was the rural roads. And in the rural roads, again, some project we started. First project we did for the planning of roads in Jaipur district. we started it with Kotputli, that was part of Jaipur district at that time. Now it is, I think, Kotputli is a separate district. Dr. Ashok Kumar was also there at that time here. Later he went to World Bank. Then in that project, we were able to convince the people first time that rural roads are also to be planned. Otherwise, rural roads were the neglected roads where wherever you have some money, dump it in the road, it will be a rural road. These are known as the low volume roads, low cost roads, low traffic roads, etc. etc. Second project we again did in Andhra Pradesh. I was going again and again to Andhra Pradesh at that time. We designed, we planned the roads of Adilabad, Karimnagar, and Warangal district. That was a World Bank project having Mr. Victor from Switzerland. And after the success of that, people realized that now there is a time that we should plan the rural roads also properly. Third project I did was the planning of Ghaziabad district of Uttar Pradesh. And fortunately, my PhD work also was the same. I did the planning of Ghaziabad districts, and uh, that was also successful. After that, fortunately or unfortunately, I left CRRI in 1998 and went to IIT Roorkee. Professor Farida was the instrumental to convince me that I should also move. So he was in IIT at that time, so he convinced me to go there. I went to IIT Roorkee, but during that time, what the work we did on the planning of roads, that started a seed in the minds of the people. When the government of Shri Atal Bihari Vajpayee started, they said that we should connect the villages to the roads. We were having 6 lakh villages in the country, and about half of the villages were not connected. They were having no connection, especially during the rainy season. Villages were isolated. If you see the stories given on the website of PMJSY, you will find that many villages there were there where the boys were not getting married because nobody was ready to give their daughter to that village because no, there is no hospital, no school, etc. So we many meetings were there in CRRI itself, in seminar hall, in your another hall, I think adjacent to director's office. So I came many times for those meetings because my PhD was on this rural roads. So Professor Sikdar was the director at that time. He invited me many times. And finally, that PMJSY was conceived at that time, and that PMJSY is still the best yojana in the country after the independence. We have many new concepts like 5-year guarantee, national quality monitor, state technical agency, 5 years guarantee by the contractor, vertical tender. They are only in PMJSY, and that is why now rural roads are not the low cost. These are sometimes not the even low volume roads. In SP20, you will find that we have designed it or maximum 450 vehicles per day. But at the time of design, you might have thought that there are 20 vehicles per day, it may become 100. But later, when the roads were very good, people were moving over those roads, the number has gone up to the 1,000 vehicles per day also. So that is why that was the best yojana, I say, and I am proud to say that I have contribution to that yojana because of CRRI. Because we did here, and the environment, the atmosphere here was definitely very conducive. People were trying to support each other, and because of that, I got selected in IIT Roorkee also because at that time I was having 35 research papers when I left here, and because of those 35 papers which I wrote here, I got selected there. And finally, regarding this workshop, since I am teaching a subject nowadays, pavement evaluation and management at IIT Roorkee for my students. So when Professor Parida asked me to come and be the part of this workshop, I thought that I should also learn. I am still in a learning mood. Whenever I come to CRRI, I say that I am in a learning mood. I am a student for you, and that is why I happily accepted his invitation to come here. And I am still feeling proud that I am part of you. I was proud of you, and today again I am proud part of you. And we have Shri Dharmanand Sarangiji, who is a great engineer of the country. He has a vast experience of roads, good roads, many things. So he has come many times to our Roorkee also. And it is my honor that I am sharing the dice with him. And I will say I should stop here because I am also eager to listen him. Thank you.
Thank you, sir, for your valuable insight and sharing your civil engineering, traffic engineering, and bridge construction. Starting as a assistant engineer in 1990, he was appointed as chief engineer in 2013 and he held various positions in the Ministry and National Highway Authority of India. Notably, he was promoted to Additional Director General in 2020 and then Director General in January 2024. He is highly proficient in highway engineering, design, construction, management, and maintenance with a focus on traffic congestion avoidance. He has undertaken significant highway development projects in several states, including Odisha, West Bengal, Jharkhand, Chhattisgarh, Maharashtra, Gujarat, and Goa. As a lifetime member of the Indian Road Congress, he has made substantial contributions to the organization. In his role as DGRD and SS, he is dedicated to the policy formulation for the planning, development, construction, operation, maintenance, and management of national highways across the country. Additionally, he oversees all the activities related to national highway entrusted to state PWDs, BROs, etc. So, ladies and gentlemen, let's welcome our chief guest. Please grace us with your insightful words and enlighten us with your wisdom, sir. Please.
Professor Praveen Kumar, Head Civil Engineering Department, Indian Institute of Technology, Roorkee. Professor Manoranjan Parida, Director, CRRI. Mr. Sunil Jain, Chief Scientist, Head Pavement Evaluation Division, CRRI. Dr. Pradeep Kumar, Chief Scientist, CRRI and Workshop Coordinator. Esteemed colleagues, distinguished guests, participants, students, and friends from media. A very good morning to all of you. It is really my privilege and pleasure to be part of this inauguration function for the works of network survey vehicle applications for maintenance of road infrastructure. I extend my heartfelt appreciation to CSIR CRI New Delhi for organizing this timely and relevant workshop. I should say it is a little bit of coincidence, but only few days back we received a research proposal from IIT Kharagpur to establish a national calibration center for network survey vehicle in the country. In fact, as far as network survey vehicle is concerned, the first was done by CRRI, as was mentioned, um, and it was in I think 2006 to 10, somewhere in between. After that, ministry also took up the RAMs almost a decade back, but somehow we could not succeed there. But very recently, RAMs has gained a little momentum, and in that context, this workshop is very relevant. Again, if I come to the next point, ministry has issued a policy circular in 2019 where we have made it mandatory for carrying out NSV survey before commencement of any project, before issuance of the completion certificate, and during the operation maintenance period at every 6 months interval. I think survey is being done. There are number of equipment, but the quality of data that is coming, that's a very highly suspect. My first hand experience, we gave another research project to IIT Kharagpur on life cycle cost analysis. They are developing a tool and they requested, and as a part of our sanction scope, we are supposed to provide them the available NSP data, and some they were supposed to collect on their own. That was part of the sanction project. Now the data comes to ministry. There is a cell in NHI. They are sitting somewhere else. When somebody from IIT Kharagpur came for collecting the data, and that time I was ADG looking after standard and research. It was directly under my jurisdiction. And the data in charge was present, Director CRRI, again a dear colleague of mine. He also supported, but nobody knew what is where and in what condition it is. But somehow, after struggling a lot, we made the data available to IIT Kharagpur. But what they came out after analysis is that bulk of the data is simply garbage. So we are spending a lot, but somehow the focus for somebody who is issuing the completion certificate or thereafter while clearing the maintenance bills, what is the NSV? It is within the limit. Okay. If somebody does not carry out the NSP survey and simply gives a figure that roughness is so much 2000 mm, 2100 mm, then we are all satisfied. This is the problem, that this data has not contributed the way it should have contributed. So in that circumstances, this workshop has a lot of significance. As you all know, we are designing payment for 20 years flexible payment, 30 years rigid payment, and what we expect during the entire design life of the pavement, it should meet the performance standards like rutting, cracking, etc. should be within certain limits. And it is dependent upon, of course, design, of course, quality assurance and quality control during the construction. But after that, once the road is constructed or the pavement is laid, timely intervention of maintenance activities also contribute a lot. And how to determine it, how to prioritize it, that can only be made available from a very, very comprehensive data on the road inventory and condition survey. Fortunately, NSB is a mechanized means of achieving both the objectives. As you know, all that it has the state of the art laser profilometer, laser crack measurement system, transverse profile logger, GPS cameras, and data processing units, and maybe something more. So they can capture the road inventory and condition survey in toto. But many times we hear that even in a NSB that is being running across the national highways and now taking cue from us, many state roads, they are also utilizing NSB for their own evaluation, are not fully equipped with all the equipments. And even if it is there, what is its quality, what is its status of calibration, that's all a point of question. So in that circumstances, if we want to have correct analysis of the data and further usage, calibration of the instruments is a very important thing. And of course, if we succeed, we will have this National Calibration Center, the first of in kind. What I was given to understand that USA and many other developed countries have number of such calibration centers through their length and breadth. But if it succeeds, we can also establish similar kind of centers, maybe in CRRI, maybe in other regions of the country. And while we were examining this, why I told a coincidence while we were just evaluating that proposal from IIT Kharagpur. They did also another good thing. They sent us a set of guidelines, protocol for the NSP. So we are currently examining it, and we are hoping to issue some kind of guidelines. Very recently, we have taken an approach. Some of you might have noticed, because last since I came, we have issued a number of guidelines, and every time we have made a very democratic approach. The draft guideline is always available in ministry's website for at least 2 week time period. And in some cases, we also receive so much of observations that it becomes difficult for us to examine that and come to a view whether we accept something, or if not accepting, we are not accepting. Uh, I feel this workshop will fulfill our requirement of that kind of stakeholder views, and it will definitely enrich the kind of protocol which will make, which should be sacrosanct in nature, and which should be also implementable. Like our field engineers, suppose somebody is a PD executioner, somebody is jurisdiction, the NSV is running. So the guidelines should be understood by him in the sense that he can check whether this NSV is complying to all the requirements or not. I hope with this workshop we will be able to come to such kind of protocol or guidelines that will help the entire industry. Because if we are spending so much money on a equipment, it should give us very, very authentic data. It's not just we are having less manpower, nobody can go to the field in like in good old days, measure cracking, rutting, raveling, stripping, etc. But getting the information readily in few days, hundreds of kilometers. That's a part of the requirement. But the main requirement is correctness of those information. And unless until we have the correctness of the information, and unless and until we have further means of correctly analyzing it and feeding it to whatever system we have, so that we can decide our maintenance interventions based on those data, then this will continue as a ritual, which is the case as of now. So CRRI is a very, very eminent organization, and they are really in the proper place to organize this kind of workshop and give advice to ministry. We have very long association with CRRI much before maybe I joined the service, much before that in good old days, when we were having research schemes R1, R2 like that. I think most of them were with CRRI. So, friends, again, I feel quite honored to be invited for this. I hope the whole day you will be deliberating it, and I will particularly request one thing in the deliberations. I don't know how many people from the field are there or from the consulting fraternity side is there. So, whatever difficulties you face in analyzing data and about ascertaining correctness of the data, please bring it to the forum. Let it be discussed threadbare, and let us get something very, very positive out of it. Wishing all the success for this whole day workshop. I again thank Professor Parida. He is actually, we are from the same college. He was 1 year junior to me. So it was a very nice association, and I again feel quite happy to be here. Thank you. Namaskar. Jai Hind.
So, thank you so much for your golden words, sir. Now it's time to express our gratitude Here we have a special gift as a token of our appreciation. I request our director CRRI to present a memento to our chief guest Sri Dharmananda Sarangi sir. Thank you, sir. I again request our director CRRI to present a memento to our guest of honor, Professor Praveen Kumar, as a token of love and gratitude. Thank you, sir. I request Sri Sunil Jain, Head Payment Evaluation Division CRRI, to propose a vote of thanks.
Respected Chief Guest Shri Dharmananda Sarangi ji, Director General Road Development and Special Secretary, Ministry of Road Transport Highways, Government of India. Guest of Honor Professor Parveen Kumar ji, Head of Civil Engineering Department, Indian Institute of Technology. Professor Manoranjan Preda, Director CSIR CRRI. Dr. Pradeep Kumar, Chief Scientist and Workshop Coordinator. Other distinguished guests, speakers, colleagues, participants, students, members of the media, ladies and gentlemen. Good morning to all. It is my proud privilege to express my deepest gratitude and offer a heartfelt vote of thanks on behalf of CSIR Central Road Research Institute, New Delhi. First and foremost, I would like to extend my sincere appreciation to our esteemed chief guest, Shri Dharmananda Sarangi ji, and guest of honor, Professor Parveen Kumar ji, for gracing us with your presence. Your support and encouragement have been invaluable in making this event a grand success. We are truly honored by your presence and deeply grateful for your valuable contributions. I must also acknowledge the driving force behind this event, Director CSIR CRRI Professor Manoranjan Preda. Sir, your constant guidance and leadership have been instrumental in the success of this event, and we are sincerely thankful for your unwavering support. We would also like to extend our sincere appreciation to all the dignitaries, distinguished guests, scholars, researchers, students, and delegates from various fields who have traveled from different corners of the country to be a part of this gathering. Your presence adds immense value of this event. Furthermore, I would like to acknowledge and express our heartfelt gratitude to our private sponsors of this event. There are total 6 sponsors in this workshop. The first one is Roadworks Engineers Consultant Private Limited, Hyderabad, Coact Solutions Private Limited, Hyderabad, Khanda Designers and Consultant Private Limited, Gurugram, IRSM Hyderabad, Blue Ocean Mumbai, Complete Solutions, Complete Instrumentation Solutions, Gurugram. Your generous support has been instrumental in making this event a reality. Your commitment to innovation and collaboration is truly commendable, and we are deeply grateful for your behalf in your vision. I would like to thank the media is being present in this event, ensuring that every moment will be captured and preserved for the posterity. We are also indebted to our organization committee members who have worked tirelessly to put together this remarkable event. Their dedication, attention in detail, and communication and commitment to excellence have been pivotal in ensuring a smooth and successful start of this event. Last but certainly not least, I would like to express my heartfelt thanks to each and every attendee present here. Their enthusiasm and engagement throughout the inaugural session have been truly inspiring. As a embark of this journey of knowledge exchange and collaboration, we hope that all the sessions will prove to be enlightening, thought provoking, and contribute to the advancement of our respective fields, as well as betterment of the society at large. Once again, thank you all for gracing this occasion with the esteemed presence. We look forward for making this conference a memorable and enriching experience for everyone involved. Thank you and have a wonderful day ahead. Jai Hind.
Thank you, sir. So, ladies and gentlemen, please rise for our national anthem. Now it's time for the inauguration of exhibition followed by the tea break. We request our chief guest to do the honors, please. Dignitaries on the dais and off the dais may please join for the exhibition. The tea is arranged in the council hall for all our eminent speakers, chief scientists and HODs along with the COAO, senior COFA and senior controller of store and purchase. And all our distinguished delegates and CRRI colleagues may please proceed to the cafeteria towards the left side, ground floor. We will resume here back at 11:40 am sharp. Thank you so much. एक्सेस क्लियर कराने के दोबारा से लगाए। पता नहीं कहाँ बिजी होती है वो तो, लेकिन सेशन से पहले ही होना है ना सभी। हाँ, ये जो नेम प्लेट सब तो हट जाएंगी। हाँ, नेम प्लेट हट जाएंगे। इसमें लगा तो है पंच में लगाया से बैठने की सुनील क्या सबका नीचे हो जाएगा। उसमें से कितना ऐसा लगता है। ये
अच्छा, आपको प्रेजेंटेशन लोड करना है?
नहीं, मैं लोड कर दूं या फिर अच्छा इसी में लोड कर दूं?
हाँ, ये चल पेन ड्राइव आप दे दीजिए, मैं
इसमें इंटरनेट होगा क्या?
Hello. A very good morning, one and all. Myself, Dr. Deepa, working as a scientist in Pavement Evaluation Division of this institute. I would welcome you to the first technical session of today's workshop. Shri Sunil Jain, Head of Pavement Evaluation Division, is the chairman of this session, and I am the moderator. Shri Sunil Jain is currently the head of Pavement Evaluation Division, CSIR CRRI. He is also professor in the Academy of Scientific and Innovative Research, CRRI. He obtained his BTech and MTech degree from IIT Roorkee. He has over 32 years of experience in the field of pavement performance evaluation, failure investigation of flexible pavements, construction quality assurance and maintenance of flexible pavements, innovative road construction technologies for flexible pavements and pavement maintenance management system. I welcome you, sir, to this session. The first speaker of this technical session is Dr. Amit Munjal, DGM NHAI. Dr. Munjal earned his MTech in Environment Engineering and PhD from IIT Delhi. After qualifying the Indian Engineering Services examination in 2010, Dr. Amit joined the Ministry of Road Transport and Highways in 2012. During his tenure at MORTH, he handled significant road construction projects in left wing extremism affected areas and later worked as regional officer at Chennai. Currently, he serves as Deputy General Manager Technical in NHAI, where he is responsible for operation and maintenance of national highways, utilizing advanced equipment based surveys like NSV. I welcome you, sir, for the presentation.
Uh, Good morning, everyone. My name is Amit Munjal. Working. Currently, I am working as Deputy General Manager in NHAI. My parent cadre is Ministry of Road Transport and Highways. From last 1 year, I am deputed in NHAI and looking after NSV related works. So, uh, when I joined, the earlier system was in place, in which the data collection part and the processing of data and submission of reports was being done by the field units of NHAI and the agencies. But some issues were identified in the previous system. So it was felt that some revamping of this NSV wonderful technology is required. So we have done some exercise. Today I am sharing that experiences with you. And before going into the detail, I would like to congratulate CRRI for holding this event at this point of time when this is a high time when everybody is talking about uh, the maintenance, best maintenance practices in India. Even uh, the, even government is taking now review meetings on operation and maintenance aspect of national highways, which was not the case earlier. Uh, and recently minister RTH also emphasized the need of better roads during a public meeting, I think last week. So so the first question is, why do we need equipment based condition monitoring? uh, and the answer is simple that despite of regular inspections by the field units manually, there are maintenance issues, persistent maintenance issues. There are roughness issues, cracking, rutting, raveling, and potholes in the roads. So uh, if we talk about the numbers, during last 3 months, ministry has received more than 1,000 maintenance related complaints, from different platforms. The most effective is social media, and judiciary is also now taking very tough stand on these issues. Recently, High Court in Madhya Pradesh has refused to quash a FIR filed against NHAI officials for poor maintenance of roads. So it's a high time that we focus on the maintenance aspect. We are now moving slowly towards the asset manage as a asset manage organization. NHAI is now becoming. Citizens' expectations have also been increased during the last couple of years. It's not uh, that citizens are ready to accept uh, poor quality of roads now. The social media is helping them to register their complaints, and government is taking cognizance of these complaints. Uh, so, keeping in view the um, limitations of manual methods of inspection, they can do the limited coverage of parameters. The accuracy is not that good, and there is always a scope of manipulation in manual methods. So we have to shift towards the equipment based testing. So accordingly, ministry also realized these aspects and adopted NSV based technologies way back. For the better management of data, ministry also developed RAMs. Its current in use RAMs was developed between 2014 to 17 as a World Bank aided project. This RAMs has been also enhanced during 2018, and O&M of this project is underway, which is ending in coming February. There are basically three aspects in the operation of RAMs. First is data collection, which was given to the field units in NHAI. This data was sent to the uh, NHAI headquarter through cloud-based server, and the validation of this data was happening. For this purpose, a dedicated RAM cell was established on full time in NHAI headquarter. Its contract is also ending in March 25. So after this validation, this data is stored in the RAM's portal. Although this system is running from last many years, but some issues, some challenges were observed. That's those challenges were raised by DG sir also just some time back in this today's session. So, keeping in view these issues, our team at NHI was given this task to revamp this NSV mechanism in India. So we have done some changes in the previous system that I'm going to share. So what are the need for this revamp? The first was that the data availability, this data collection was given to the field units. We could only collect data up to around 60,000 kilometers out of our total network of 1.44 lakh kilometer of national highways in India. So after so many years, after so much hard work, we could reach up to 60,000 kilometer only. So one issue was this data availability. From the field, we were not getting the complete data of the network in spite of all efforts. The other was the quality of data. What TG sir was also mentioning, that this data, when shown to a research organization like IIT Kharagpur, they observed that the quality of data is not good. So it was decided that this data collection part has to be centralized. For this, procurement of NSV agencies shall be done by NHI headquarter, and the same will be de-scoped from the field unit's scope. Second was that there was very limited utility of the NSV data for immediate maintenance improvements of the roads. This data, if you see in the slide, is basically a rating based data. The road is rated on different parameters from very poor to very good, which is actually not the requirement of a contract we are having with our contractors or concessionaires. We need the payment distress numbers instead of rating. So this was also a limitation of the earlier system. So this was also addressed, And some issues were there with the RAM software, that web-based software we were using. That also we have uh, addressed. So the conclusion is that there is a need to revamp the existing system. Accordingly, the issues were identified. This slide shows the salient features of the revamped NSV project now NSI is handling. For this, wide consultations were done in the industry with the research organizations like IIT, CRRI, and almost all the stakeholders. So after all this consultation, it was decided that the data collection and processing part will be undertaken by NHI headquarter now instead of the field units. And the quality of data, to maintain its quality, it was decided that the strict timelines shall be followed. That the raw data, once the end of survey is done at the site, the raw data collected shall be transferred to NHI headquarter within 48 hours, so that there shall not be any, well, very less chance for any kind of manipulation. Further, the processing of this data, this raw data, shall be done at NHI headquarter. So the space to the NSV agencies shall be given by NHI. This all the processing shall not be done at NSV agency's office. It will be done at NHI office. And timeline is also fixed. Maximum 10 working days are allowed to submit this final reports by the NSV agencies. Otherwise, there are some penalties clause are also there in the contract agreement. And this processing also shall be strictly supervised by NHI team. Contrary to the earlier system, when NHI was having a very limited role in NSV, now NHI is including itself more into the NSV aspects. So this all this processing shall be done by the NSV agency with the supervision of NHI team. For this purpose, NHI has also hired a team of NSV advisors. And once these reports are being uh, received, they are reviewed by NHI experts. Within 2-3 days, this data is transported to the GIS platform and shared with all the stakeholders like our field units, PIUs, ROs, contractor, AEIs, for immediate utility of this data. This project was conceptualized in a phased manner. The first phase is under progress now. In this phase, we have identified around 25,000 kilometers of 4 lane and above. That means more than 1 lakh lane kilometer we have identified under phase 1. In this phase, we are not changing any contract conditions between the NHI and the contractor for road construction and maintenance. But in phase 2, it is planned that we will cover all the O&M stretches of NHI and ministry, which are being done through state PWDs or NHI DCL or BRO. So the coverage will be increased in the phase 2, and PCI, pavement condition index based categorization, shall be introduced in phase 2. But I'm glad to share that from this phase 1 data, what we are getting now, NHI team has already uh, able to calculate PCI for the stretches what we are getting. So this introduction part can be now shifted from phase 2 to phase 1. And in the phase 3, this complete NH network of the country shall be included. Before that, we will make necessary changes in the model concession agreements to capture PCI as output in O&M period. This picture is from IRC 82 to 2023, representing the PCI scale. So with this, the phase 1 has been started from as per the recommendation of IRC 82 2023. The survey frequency is been kept as 6 months for each stretch, and as I have already mentioned that around 1 lakh lane kilometer of national highway network is undertaken under this, and we have created 5 zones covering almost 20,000 lane kilometer in each. we have mandated to use the best in class instrumentation. All right, sir. This question came to our mind ki why should we use only 3D based NSV equipment, because 2D is also giving good results. So after detailed deliberation, it was decided that 3D has less human intervention, so we should use the 3D only. So it was kept. Instead of one deliverable as per the previous system, which is mentioned at deliverable number 1 in this slide, we have added two more deliverables. Second is the comparison of measured distresses with the contract condition of that particular project. The upper Excel is showing that deliverable, that the limitation of roughness is 2200 per kilometer, and what we have observed in lane 1, lane 2 respectively, likewise for different distresses, is taken as deliverable number 2. Likewise, we have added one more deliverable, which is GIS, which is for quick understanding of this activity, that the distresses shall be transported to GIS maps with a color coding scheme. This photograph shows how it is working. The photos and changes are also mentioned in this. But when we started this project around a couple of months back, some challenges were faced. So now I'm just quickly going through these challenges. First challenge was that the distress, although distress was mentioned in the contract agreements, that the tracking should not be more than 5%, but its detailed measurement and reporting method was not mentioned in the contract agreement, as well as we could not find any Indian document which gives us a detailed methodology how to measure the tracking. Like uh, so for after this research, we could find a document of ARRB group which gives us a detailed methodology to find and measure and report the cracks. For example, if there is a crack, we have to take the width of the crack as zero 0.5 meters and multiplied with the actual length of the crack. That will be used in our deliverable number 2 now. The next challenge we faced is from our contract documents. These two contract documents conditions, if it is visible, is of the same road. One is package 1, which was awarded on hybrid annuity model HAM. The roughness, if you see, it is mentioned 2750 in a stretch of 1 kilometer. And the continuing road, package 4, which was awarded on EPC, there is no difference in the road, but roughness requirement in that package is 1800. So this non-uniformity in our contract agreements is there, and the measurement method is also, equipment is also not very up to date. So you can see in roughness it is written rough meter slash bump integrator. I think it would be better if we write laser profilometer complying with ASTM relevant. So this non-uniformity in our contract agreements was also observed. Then the next was reporting interval of different payment distresses, which was also not very clear in the contract or IRC also. But IRC 82 give us a hint that for a project level, we can use 100 meters of the section for reporting this. So that we have adopted in our project. So this slide shows our final outcome of deliverable number 2. The lower one already I have shown, discussed, but the table above is the summary of the major parameters we have observed. Like this project has a total lane kilometer of 249 in the scope, and at the this road is failing. 22% of this road is failing as far as roughness is concerned, and as far as rutting is concerned, 15% of this road is failing. Likewise, now we have this summary also with us. This is the deliverable number 3. When these distresses are shown on GIS maps, we have used the color coding scheme like Google Maps is used in navigation. That red is for the unacceptable limit, then orange fair, and blue is which is under the acceptable limit. So the intended goals of this project are to adopt better maintenance practices to improve the condition of roads. For this smooth implementation of this project, the reports what we are getting from the NSV agencies after the acceptance shall be integrated with NHI data lake software, so that and NHI one mobile application, so that uh, the the issue of notices and action taken reports can be automated. And and recently during a meeting in ministry on this project, a suggestion came that once this project is matured, we can adopt machine learning based model to predict the road condition in future. So the way forward for NSV in NHEI is that we are expanding this NSV to all the tolled stretches under all agencies of ministry. We are adopting payment condition index to classified the road condition. And one more interesting aspect we are about to launch is that we shall be rating our contractors or O&M agencies based on the NSV data, and that might be used in bid evaluation in future. And the last but not the least, the engineering improvements can be done through this NSV data. This whole exercise can give the recommendation for standardization of the documents, for updating the guidelines, etc. Or we can, what DG sir was mentioning, we can expect a NSV validation center in India at CRRI or some IIT, so that we should not be dependent on the manufacturer calibration certificate always. So with this, I complete my presentation. Any discussion?
You can take 2 or 3 quick questions from the audience, please.
Uh, Hi, Dr. Mundra. Thank you for the presentation. One suggestion that I had, since you mentioned that moving forward, you would also like to do payment deterioration modeling. So all the documentation that you mentioned that you're trying to clean up and standardize only refers to the dependent variable that you'll be modeling, like distresses and roughness and stuff like that. But to have models with some predictive ability, which can also be localized to different regions, you would also need uh, history of maintenance, e-sales, traffic loading, environmental condition, design. And my sense is that data for that is also all over the place and possibly may have, especially more dynamic variables like environment and traffic loading, if you want to have based on spectra, etc. That also probably would require some standardization and cleaning. And if it can be recorded on a more central level, then NHAI has the scale at which it can do modeling in a more interesting way.
Yeah, that can be done. Yes, sir. Surely.
uh, great presentation and the way it's going. This is the future really required. Just want to know the timelines of the phases which you have mentioned.
Uh, as per the current understanding, 1 year is for phase one, and before this ends, the phase two shall be initiated. Phase two and phase three is the final phase when all the road stretches will be included in this. So this might be the future of condition survey in country. So
Okay. If there is no question, then
I think one question is there.
one more question we will take. Otherwise, you can discuss during the lunch hours, please, because we are shortage of the time. One question, please.
This data collection effort is going on since 2018, I guess. But still, you're not able to collect the, entire road network database. So, what are the challenges? Because in many, even the smaller states could able to collect the data within a year. Let us say, let us take an example of Assam state. They have a network about 50,000 kilometer. They could able to collect the data for within a year, and they have collected this data for multiple times. So if a state can able to do that, why NHA is not able to do that?
We are
Thank you.
also trying to cover this 1 lakh lane kilometer within 1 year, and maybe the second phase will come earlier than this 1 year. Yeah, because that was the learnings from the past, that when we give this work to the field agencies, so we could not complete this whole because one more reason is also there, that NSV as per our circular applies only to the O&M stretches and not the complete network. So which is under construction. A considerable part of this network is under construction. So NSV does not apply on that. So that automatically deletes that part. So that other reasons also. So that's why this whole data collection exercise has been taken at the NHI headquarter level now. Right. Yes, it is difficult. We are doing difficult thing. That's correct.
Okay, okay. Please.
Sir, one more question.
Thank you.
Hello.
Now I invite our second speaker, Dr. Samir Saran, DG NRSC ISRO. Mr. Saran, please complete your presentation within 10 minutes time. Dr. Deepak. Please sit. Mr. Saran, please sit. Please sit. Be seated, please.
Dr. Samir Saran obtained his postgraduate degree in physics in 1995, PhD Geoinformatics in 2003 from Indian Institute of Remote Sensing, ISRO, and advanced research at Wageningen University, the Netherlands. Prior to joining the Regional Remote Sensing Center North as DGM in 2023, he was head Geoinformatics Department, IIRS, Dehradun from 2015 to 23. His major achievements are in the area of national biodiversity database organization, modeling and dissemination of species and spatial database of the entire country. He has been awarded prestigious national and international awards, namely President Appreciation Medals, National Geomatics Award for Excellence, Outstanding Contribution Award by Asian Association of Remote Sensing, International Geospatial Award, and so on. I welcome you, sir, for the next presentation.
Thank you so much. Uh, no PPT. No PPT. Yeah. First of all, good afternoon, everybody, and let me convey my thanks to the organizer, specifically Dr. Pradeep Kumar, for giving me opportunity to interact with you. I don't have any presentations because our technology doesn't directly relate, but indirectly it has got a lot of opportunities. And in fact, if you look at the type of exercise which CRRI is doing, that is the network survey vehicle application for maintenance of road infrastructure. I think it is a Herculean task to do. And if you look at the overall road length, I was just googling the what is the length of the road in the entire country. It is around 66 lakhs, which is I think it is really difficult to do that. But nevertheless, I came to know in the during the inaugural that already 40,000 kilometer road survey has been carried out by CRRI. So I think it's a good beginning, and a lot of agencies are working in order to create this type of database, and it has got a lot of relevance. Reason being is that the entire uh, economy runs on the road in the sense you have the entire the supply chain, any commodities you look at, road is one of the most important components. So this is a need of our, and I could see that there is a vehicle outside which is capturing a lot of information related to road parameters. One of our previous speaker already told that there are so many survey parameters, road survey parameters, which has to be collected by the vehicle, which consist of like longitudinal profiling, transverse profiling, and then there is pavement texture, uh, road geometry, GPS coordinates, as well as video imaging for road as assets and pavement surface distress. Well, there are so many parameters, and if I look at remote sensing, I think we can, to some level, we can have some preliminary information. If you look at the overall technology, geospatial technology is considered to be the epitome of most of the application which Government of India is running. NRSC, National Remote Sensing Center, which is one of the unit of ISRO, primarily dwell with uh, data reception, data pre-processing, data applications, and of course dissemination. So all these different activities are being carried out by NRSC, and the most important part of NRSC is that they are involved in two various projects which relate to geospatial technology. Now if I look at this particular work, I think it has got a lot of potential with respect to the various components where one can explore. The most important component of geospatial technology is remote sensing. I think many of you are aware of that satellite remote sensing provides you a synoptic coverage of the entire area in a most quickest way. That is most simplistic way you can have a satellite image. But is it possible for you to get all that information which you are looking for? It is somewhat next to impossible. Reason being is that you don't have that detailed information. So if you see satellite remote sensing, it has got certain parameters like the spatial resolution, means the what is the size of the object which can be discriminated by a satellite sensor. So we always look for a very high spatial resolution, which we call it the best possible resolution can help us to identify the road in a given area. And this spatial resolution can, if you have a very high spatial resolution, then you can identify the road, and even you can have the road with, or maybe some quality of the road, some level, you can get those estimates. The second part is the spectral resolution, because whenever the satellite, it takes you have a sensor on top of it, like you in a road, the road vehicle, what you have, there is also sensor. Similarly, the sensors are mounted on the satellite, and you can get some level of spectral resolution of that particular data. So when you talk about spectral resolution, and if you have a good spectral resolution, you are able to get the spectral response of that particular road. So if you really want to have the type of the basic level of road type to be identified, spectral resolution can play a very important role. Spectral resolution you can get through multispectral or even a hyperspectral, where the bandwidth of a particular area is very fine, so that you can capture even the finest particle in a given area. So those type of aspects can be looked into, so that you can really work on those areas. The third part is the radiometric resolution, which talks about the quantization level of that data. If you have a very high bit resolution, like I was looking to the data which you are getting from laser profilometer, it is around 16 bit, which is very high quantization level. So if you have that quantization level from the satellite data, I think you can really explore that what type of the minute information which you are looking for, which can be integrated, or which can be, I would say, complement to the spectral resolution as well as spatial resolution. So these are the three important resolutions which one can explore in order to work on the road parameters. The last part is the temporal resolution, where you talk about the repeativity, means the survey what you do at given point of time has to be redone again and again. It's not a one time exercise, rather it needs a lot of monitoring mechanism, and that you can do it by making use of satellite data. So all these four resolutions, I would say, it makes a very important basic information which can be used for all these applications. Now, the second component of geospatial technology is GNSS, that is Global Navigation Satellite System. Now, this GNSS, as you already know, that all these vehicles, they have fitted with GPS coordinates. And these GPS coordinates are providing you the latitude, longitude, as well as the altitude information. Now, if you have good, because when we talk about GPS, it's more of an American constellation. But when you talk about GNSS as a whole, it talks about the constellation from various space agencies. Whether you talk about Baidu is from China, then you have GLONASS, then we have our Indian
IRNSS, Indian Regional Navigation Satellite System. So all these constellations can help you to give you the best possible position which can be used for navigation. So all these positioning, better precise positioning as well as the navigation can provide you a very important information which ultimately has to be used for creating these database. So I think already your survey vehicle is having that the positioning information, and they are providing the best possible accuracy for integrating into the overall database. Now, the third part is called as GIS, Geographical Information System, which my previous speaker also told. It is really good to develop this type of database on a geographical information system. Now, if you have all these data sets which are being collected from the instrument as well as from the satellite, you can integrate them together. The best part of geographical information system is that it can overlay all the data sets. Only thing is what type of data model you are working, whether you are working on raster data or you are working on vector data. If you have all the data, you can integrate together, and you can have a queries. Different type of query systems can be created, whether the query is based on your simple the SQL query can be made, or you can even think of a spatial query, like you want to identify the road which is prone to many type of disasters. So those type of information, if it is already there in the database, then GIS can help you to work on those aspects. Another aspect of GIS is it can do a lot of analysis in the sense the analysis could be based on location, the analysis could be based on condition, the analysis could be based on what if scenarios, everything. Once you have these data sets integrated together, you are able to really get the actual information from these databases. So GIS is also an important component which can be part of the this particular exercise. And anyway, most of the agencies are making use of this information, and they can directly leverage all these data sets together. The last part of the geospatial technology is ICT, that is information and communication technology. Once the data sets are available, it has to be disseminated to the user in the form of portals. I think most of the road information systems have been created by making use of geospatial technology, and these road information system can provide you the dissemination mechanism. Means those data sets, whatever you generate, it can be made in the form of services. That is, it could be a services of OGC, Open Geospatial Consortium, or there could be a service in the form of APIs which can directly be monitored through a portal. So all these four pillars can really make everything possible, and the decision making can be made more and more simpler, as well as one can monitor all these areas. Now, if you look at the new technologies which are coming, there was mention about the mobile app. I think if you have, there are so many mobile apps which have been created by NRSC, ISRO, for geotagging various utilities or various assets. So those geotagging mobile platforms can be developed, and they can directly be linked to the portal. It means it should have a dashboard which can provide you a lot of analytics of those data sets. So this type of information can be put into a data warehouse, and you can do a lot of roll down or drill down operation which can provide you a value added information. So rather, you are not looking for the primary data, but you can even get a lot of secondary information which you cannot think about it, because once you put them into a database, you can analyze them, analyze the multidimensional data, and you can really do a lot of value addition to those. uh, Other part of this particular technology is we talk about feature extraction. I think you might be aware that image segmentation is one of the area which primarily works on object based image analysis, and you have very high resolution data sets available both from the field, or it can be taken from the satellite. So you can apply different type of operation which primarily govern through color as well as the shape of the particular area. So if you combine all these parameters together, you are able to identify some of the areas which you are looking for directly from the satellite, or maybe from the vehicle data which you have. And then there is texture also. Texture is also one of the important parameter which can provide you the cracks information, and so many other areas where you can make use of the contextual classification, or you can even make use of fast Fourier transformation. And there are so many image processing algorithms which can directly be applied to these data sets, and you can do wonders on that. I would like to mention that You can also make use of UAVs, because UAV can help you to take the at least broader level. I'm not telling you that you should go for this anyway. This instrument, the field survey, is the ultimate survey, but you can have a first hand information through satellite or through UAVs, so that you are able to capture some level of information, mount some hyperspectral cameras on those data, mount the lidar data on top of the lidar sensor on top of the UAVs, and take that information. So that can be a first hand information. And if you think that some of the areas, if you really want to do the monitoring, you can make use of this. So there this way you can there could be a short term goal or a long term goal. Long term goal could be to map the entire 66 lakh kilometers for the entire country, but the short term could be that you can make use of satellite data, or you can even make use of UAVs in order to develop all these data sets. I think if you look at the overall this thing, there is a recent development in Indian space reforms, and now we are providing all the data which is up to the resolution of 5 meter is free of cost, because of the policy, which Indian space policy. Now we are providing 5 meter freely available data on a Bhunidhi platform. You can note down, there is a platform developed by NRSC, which is called as Bhunidhi. You can directly browse that through Bhunidhi. Whatever the satellite data which is having a resolution of 5 meter, you can download directly free of cost. There is no money involved in order to purchase the data. So that is one of the good part of the reform. And it is said that because of the lot of the upstream and the downstream application which are coming in space, we are expecting, government of India is expecting that at present we are only providing 2% of the world space economy, and we expect that in coming years it will go to 10% of the space economy. So that is the level of space revolution which is going to happen in the country. And moreover, I would like to here mention that there are so many new upcoming missions which will be launched by ISRO. Of course, planetary mission is one of the most important component of ISRO at this point of time, but there are so many Earth observation satellite. There is one satellite called NISAR, which is along with ISRO and NASA, where we'll be providing the L band as well as S band. And then there are so many other resource sat as well as other satellites where we can provide all these data sets. So I think a lot of opportunities are there in this area. I think this particular area is yet to be explored, and there is a lot of potential which one can harness by making use of space technology as well as other this thing. So with these few words, I just I'm stopping myself, and if there is any query, I'm ready to. Thank you.
Sorry, I am again taking an opportunity. Sir, ISRO have a huge data bank, and they do provide a services as well, geo referencing services. But most of the state or central agencies still they are relay with the agencies like ISRI's maps or the OSM street maps or any Google Maps services they are taking. Including NHA, they have georeferencing services with the ISRI. They are not using Indian agencies' data or the services. So why it is not enforcing? Maybe NHA can respond to this
No, no,
query.
I will respond. NHA, I will respond.
Thank you.
See, basically, I told you that this Indian space reforms have recently come, and now we are providing all the data in a freely way. But if you look at the all the data sets which you are talking about, these services we are already providing to Map My India. So the all these the thematic services which NRC has created for the entire country are provided in the form of WMS services, OGC WMS services. Okay, so it's an Open Geospatial Consortium. And so we are providing all these services to the this thing. And one important thing I just forgot to tell you, that NHAI has recently signed an MOU with NRSC to develop and monitor green cover index along the road. So this we are making use of satellite data to see that how much greenery means the vegetation is there, because this is one of the most important component which NHAI was looking for, and this MOU was signed just 3 months back in order to capture the green cover index. So I would say that now, because of the space reforms, the data democracy is much more than before. That is one. The second thing is, the earlier, and even in Gati Shakti also, lot of data, ISRO data services has been integrated into this Gati Shakti project. So it's not that the data is not democratic. Earlier it was some because of the policies. Now, since policies has come, we are providing all these data in the form of services, and even anybody whomsoever, like if you really want to access, you can access all the WMS services which are ported on Bhuvan portal. Maybe you can visit to Bhuvan portal, and there is exhaustive data sets which are available, which can be directly consumed by anybody. Okay. Yeah. Any other question? Yeah.
Yes, sir. I'm talking about Bhuvan portal only.
Yes.
So what we wanted was to have a shape file for the road actually. Okay.
Okay. Okay.
And it doesn't work. I've tried multiple times. From last 2 months, I am trying, but it doesn't
No,
work.
you want to download the shape
I
file,
want
or you
to
want to
I
create?
want to download the shape file. The link is there.
Okay.
Okay. I
Okay.
can see the Bhuvan map. I can see
Okay.
the roads on Bhuvan map.
Okay.
But if I want to download the shape file, okay, because what happens for these some of the new roads which NHAI is developing, Google Map doesn't have that
Ah, yeah.
because there is no traffic on that road.
Correct. Correct.
Okay,
Correct. Correct.
but we want to plot that, but
Okay.
Bhuvan shape file I'm not able to download.
See, first of all, we are not providing the shape file directly. That is one. The whatever the road network which we have, we are providing in the form of services. Now, if some agency, they really want to have the shape file for them, they can directly send letter to Director NRSC for sharing the shape file, because we don't share shape file. We only provide the data in the form of services, because the services can be used for visualization purpose. Okay, so that is the reason you may not be able to this thing, but roads you can directly see on the Bhuvan, right? Okay, you what you can do, you can just send my email ID. You can take from Dr. Pradeep Kumar, and we will look into, right? Yeah. Any other question? One last question, please. Yeah. One last question.
Hi, Dr. Sun. Just a brief question. Is Cartosat 3 data publicly available as yet?
See, Cartosat 3 data, there are some issues with the Cartosat, banding issues are there, but we have tried to rectify that. Some of the areas are already available in Cartosat 3, which we are providing, but not very frequently. We generally prefer to provide the Cartosat 2 data rather than Cartosat 3, because Cartosat 3 is 0.23 centimeter.
Yeah, yeah,
Of,
I mean that's and the visibility is much. I mean,
yeah,
the
yeah,
resolution much better. Thank you.
right. Thank you so much. Thank you. Now I invite third speaker, Shri Satyakam Sahu, Regional Director, the Associate South Asia Private Limited. Sir, please. Dr. Jita.
Shri Satikam Sahu is serving as Regional Director in Lee Associates South Asia Private Limited. He began working for the firm from 2004 after having rich industry experience in GIS and IT sector. He is currently leading the RAMS and IT discipline within the transportation planning vertical, one of the core strategic business units in Lee India portfolio. He is instrumental in the growth of RAMS and related IT disciplines since 1999, working with various states in India such as Gujarat, Odisha, Assam, Madhya Pradesh, Rajasthan, etc. And also working with funding agencies such as World Bank, ADB, and AIIB. I welcome you, sir, for the presentation.
Thank you so much, madam. Would like somebody to help with the PPT. Just copy it here, I guess. directly. बोलने का ना ऐसा duplicate आ नहीं रहा दिक्कत है दिक्कत छोड़ो अपना लैपटॉप ले आओ नहीं जो और ऑप्शन है केबल चेंज कर उसकी केबल एक मिनट ये डुप्लीकेट होने का नहीं आ रहा है पीपीटी का एंगल and for specifically maintenance and rehabilitation of roads in where Lee Associates South Asia Private Limited has been associated with last for last 30 years in the country. the entire scenario goes back to the development of or new creation of roads in the country. I would like to set the context on basically the amount of network that is getting added each year. It is getting added each year at the rate of 6% and per annum. In last 11 years, I think the total network of highways, national highways in the country has almost doubled. If you can see in the figure, uh, 76.8 thousand kilometer it was in 2011, which has risen to 146,000 kilometer as the last statistics available in 2021 22. Similarly, total road network, surface road network of the country has risen at approximately 3.4 percentage annually to about 6,360,000 kilometer in last 8 years, for which this statistics is present in the economic survey of India. Huge amount of the roads are getting built. Next challenge is going to be how to maintain those roads, protecting the investments, which is you are designing a roads for 10 years to 20 years, depending on the various category of the roads, from the rural highways to the national highways. And there are specific design criteria, IRC 37, which you are creating for an enormous amount of time with enormous money. So how to preserve those assets is going to be a big challenge in the times to come. My next slide goes how much money the country is investing on creation of these assets. If you see, annually, the only the Ministry of Road Transport and Highways is increasing at the rate of 16% at the constant prices. And with the current prices, it is much more than that. So if you see, the current budget which is allotted in this year is 278,000 crores in this, which is an up from 26, merely about 26,000 crore in about 10 years back. So enormous money and enormous assets is getting built only in the road sector. Leave aside the states. States also channelizing money to create their own assets. So main issue is how to maintain those roads so that your base layers, which needs to be protected against the ingress of the challenges of climate, challenges of rain, challenges of drainage, and several other things other than traffic and many things. So in this setting, the NSV has got a very important role to play. There are three things basically that requires apart from NSV. First is to effectively manage the road assets, you need a centralized database, and with a web GIS tool and reporting, which Sir from NRSA has just mentioned about it. It is not only the 2D data or only a data which is present in Excel or databases. It has to come to a visualization platform to be able to quickly decide where the deficiencies are, where the difficulties are, where I should channelize my money, and then where I have channelized my money and how it is going to giving me the return. So that's something which has to come from the data. Analytics plays a very important part, and you need to standardize the database. That is the number one. And number three, which NHI has focused, Munjal sir was telling, is to how to monitor the assets which are year and year. There are 5 year maintenance plan which are getting inbuilt into about 27,000 kilometer. I think this time honorable finance minister has declared that 27,000 kilometers of national highways is going to be under maintenance. So monitoring of asset performance is going to be the key to monitor how the value or the money which is getting invested on the road is actually getting into the asset valuation, whether the value of the asset is going down or whether it is going to be good or it is growing up. Because whenever you are putting in a capital outlay, it is actually you are putting on a asset creation. It should increase your assets. However, lack of maintenance and lack of all planning tools which will give you the important aspects of maintenance planning is not there. So therefore, you are not able to know how much assets you are actually losing every year because of the monitoring, because of all those important implications of the environment. Second is important is detailed and accurate information. In olden days, we were always emphasizing on visual data collection methods. I think now also there are several projects, even DPRs, they are following visual data collection methodology, not only for roads, but also bridges and other assets as well, because they are the most important part of the, because the road engineer or the structural engineer goes to the site and evaluates a structure or a part of the pavement. Nothing is going to supersede the visual data collection of the experienced people who are into it. However, with time, the data collection, criteria, or the data collection amount of data collection which is getting in India is enormously large. So therefore, the uh, advent of the automated tools, in addition to the visual capability, because visual inspection is more biased, because you do not know unless you have a trained manpower and you keep repeating them on the test sections, you will not be able to verify whether they are actually the data which is collecting, they are correct or not. You can only verify about 10% of it or 20% of it because of the time concern or because of the money concern. You cannot verify the 100% of data. So there, the NSVs and the automated data collecting machines, not only NSV, there are FWDs, there are GPRs, there are leaders, there are several other things which can be plugged into NSVs, which have a big role to play here. Credibility of decisions is one thing. Sir mentioned about it. DG sir also mentioned about the credibility of data. Even if it is collected through NSV, they are not, going through a proper quality control process. There is always a chance of manual validation, even after you are collecting data from NSV. So unless you are verifying it manually, you cannot accept that data for that. So you have to have a real challenge now, even if it is collected through NSV, how we should accept the data for any analysis, which will give you the right kind of investments which you would require for the routine maintenance, both the preventive maintenance, the periodic renewals, as well as various overlays which you are planning in the life cycle. Need-based planning, which is very important. You have got a database now. NHI is creating a database. Number two, it is getting collected through NSVs. What about the analytics and decision making ability? Everybody in CRRA knows about SDM4, because there is no parallel software which is created and compete with SDM4 in prediction for life cycle of the payments. Most of the asset management systems in last 30 years have been only emphasizing on SDM4 because there is parallel to it. There is a need for parallel prediction tools, which sir mentioned about in some of the his queries. We as Lee have been doing all of this. Number one, the database. Number two, the detailed and accurate information, creating a software, all the software, GIS-based tools, the mobile-based tool to collect the data and verify data. We have all been involved in all this information. And then important is prioritizing these investments. For example, 278,000 crores that is allotted. How it is it going to be the sufficient for maintenance plan? Because only a very small part of that goes to maintenance. There is a revenue outlay and there is a capital outlay. The revenue outlay is very small. You will be surprised that it is hardly 2 to 3% of the overall budget. You are creating with 97% of your budget, but you are only giving 2 to 3% of that money to the maintenance aspects. So that comes the challenge of prioritizing it. So how do you prioritize it? Through SDM4, very simple. You can do it through economic methods like EIR and several other things. But there are several other aspects also that goes on into it. How to handle social parameters, how to handle the climate change parameters. Those things are to be built into the decision making tool, which we are doing in several of our assets. This is a very classic graph where you can scale, you can rate your payment condition into 0 to 100, 100 being the new payment, and then it deteriorates with time. What is most important is maintenance. If you keep putting small amount of money in maintenance, it protects your life of the payment. It protects the base layers from deteriorating that you should have, and it is very less cost, and it is at least 10 times less than the costly rehabilitations and reconstruction methods. So we have been doing several such projects, including everything which I told. The first PMS, where such system NSB was used in way back in 1993 and 95, that was iron. And then thereafter, several states we have done where we have undertaken this data collection. In with CRRI, we have done initiated it for Odisha and several other states, Assam, then Mizoram, then repeat data collection in Assam, then uh, Madhya Pradesh, Meghalaya, Himachal Pradesh, several of them have several challenges to face, and we have faced several challenges. And it is not only NSV. The data has to be very comprehensive traffic and the structure, which is not correct captured by NSV. You have to have the secondary data also, when and where the historical data of maintenance was kept. So all of this methodology has a manual method as well as semi-automated and automated. So all of these is very described in 82 IRC 82 2023, as Sir Munjal sir already stated. This is how the visual assessment we used to conduct. This has to replicate using the NSV 3D mechanism or 2D mechanism, which has to come up. And none of the NSVs in currently available is able to provide all of these distress measurements now. Most challenge is the severity. How severity is going to be assessed by the extent is fine. It is able to detect, it is able to calculate the area, but how the severity is to go on, because your treatment goes by severity, not by extent. So that these are the main things where so these are the leading manufacturers we have worked with. First four: Aran, Romdas, Hawkeye, and Pathfinder of USA. All of them are very state-of-art machines. We started and these are all the modules which are present and relevant standards which are it is being used. And we are doing this for several of these states. The first Aran, which was which came from Canada, data collection was done for 32,000 kilometer way back in 1993-95, and Lee was pioneer in bringing those technologies way back in there. It's much way ahead of the current technology. But then the GPS thing was missing there. Thereafter, the second generation, it had the GPS inbuilt into it, DGPS inbuilt into it, with real-time corrections, and several other parameters came in, and the processing ability also got increased. But however, they were all mostly 2D and visual inspection, even in through the high resolution images. Thereafter, Romdas, it came in with capability of LCMS and 3DA, and thereafter Pathrunner latest generation. We all have ventured into those NSVs, and they have carefully analyzed hundreds and hundreds, thousands of kilometers of data every day. So there are processing toolkits, however, and there are several outputs also for NHI, for more than for several states, for NSP data input into SDM4. My 3 slides, very important: observations and suggestions which we have noted for the NSB manufacturers and the agencies who are going to analyze this data for their decisions, is there are issues related to GPS accuracy and signal interference. You have to have multiple challenge frequencies, and in addition to GNSS, you have to have inertial navigation system also inbuilt into it, so that you lessen the accuracy of the accuracy when specifically going on hilly areas. There are issues in data synchronization. GPS doesn't synchronize data, doesn't synchronize well with the DMI data, because DMI data measures the finished surface of the length, whereas the GPS or DGPS data actually estimates based on the datum. Sir knows more about it. Both do not match. They're two different ball games. So how do you interpret them? Inconsistent resolution of imaging systems in very low light areas. Very difficult to identify the distresses of the many times the raveling are terminated as pothole as terminated as raveling. So much of inaccuracies exist even with 3D data. Roughness measurements of uneven pavements in the areas where you have bendy and it is in the hilly terrain, it is not showing inaccurate measurements. Crack detection limitations, payment limited payment distress capabilities identifying. That's very important. Standardization across manufacturer is missing completely. So that has to be a very important thing. If you want to scale up this data collection, you have to standardize this. Whether maintenance and calibration of equipment. My last slide, sir. Standardizing and quality of data collection, that has to be enforced. Common specification, operational tolerance has to be enforced by guidelines and codes. As sir stated in the morning, there has to be a proper, there is no codes currently available in IRC which talks about it. Way back in 2004, ministry came up with a note which said something about it, but not in toto. The regular maintenance and testing program must be established by OEM at regular interval, which is not happening currently. Common calibration framework ensuring quality data has to be developed as per the standard procedure certified agencies like CRRI and as per the IRC 82 and the prevailing practices which is not there. Standardization of data quality and processing, that's very important because data collection does, but then when you process the data, it is not able to generate the way you want to analyze the data for. That outputs has to be minimal with manual intervention. Robust equipment repair and support system in India. Currently, we own 3 equipments and we also work with several vendors in the market. We are unable to increase the NSB running days more than 200 days per year. It's very sad effort because these NSBs cost very much to us. And then you add onto the software licenses, spare parts, idling time, it goes a lot of. So wet leasing, as you have for aircrafts, Indigo does, you must be listening several newses. Indigo does wet leasing of aircraft. So therefore, because these are very specialized instruments. So if some vendors and OEM, they come together to provide these services, this is going to be increasing the downtime time and increase the productivity. And maintenance contracts are must. Thank you so much, sir. Thank you so much for the opportunity you have given to me.
Few questions from the audience.
थैंक यू सो वेरी मच सर बहुत दिनों बाद सुना आपको it has been wonderful only two observations first one you spoke about Aaron I fought for it sir at that time and that is the time when I fought for accelerated load testing facility to be in India and we didn't have a DG in ministry at that time there were ADG bridges ADGB roads if you recall Nanan Koshi Saab was bridges and at that time, we started on with the accelerated load testing facility. And I was told that I'm ahead of time. That is when I saw the Aaron picture and I learned that you have used it for 32,000 kilometers. It is really heartening. Because I thought it is dumped somewhere in PWD Jaipur, catching dust. But at least it was used for 32,000 kilometers because it was used on this Gurgaon expressway. I mean, this was considered to be the Jaipur highway, was the best highway at that time if you really recall. That is one part of it. So acha laga. We could I mean I could go back in time and visualize that once more. Second part of it is what you were talking about wet leasing. That is what we are now working on. That's the key. You should not be worried about it. The consultants should not be wasting their time on this. We are actually going into wet leasing now. And that's what we are going to do. We are actually tying up ourselves completely because we should also be answerable to someone. Unfortunately, today, what's happening is NSV is considered to be a sale. It is not a sale, it's a relationship. That's where we are faltering, most of us. And there is where the gap is. This gap can only be filled in when this relationship gets translated into wet leasing. And that's all I have to say. Thank you so much.
Thank you, Chadha sir. It has been pleasure. I think I share a lot of historical facts, and it always has been a very sentimental journey for me as well, because I have been in this particular business for last 22 years, and with CRI also Dr. Pradeep Saab was there in Odisha when we both started this journey of taking NSB to the state authorities. And now see, I think it is more number of data which is getting collected in states than in the national highways. So thank you so
We are
much.
running behind schedule. Please, you discuss if you are having any queries in the lunch hours, please. Now we will start the next presentation. Now I invite Professor Aditya Madurai, IIT Kanpur. Please complete within 10 minutes. इसमें present करेंगे? Yes, please. Sir, we can have the आप इसमें present इसमें issue होगा. चलिए.
Dr. Aditya Madhuri is an assistant professor in the Department of Civil Engineering at IIT Kanpur. His research interests are associated with the exploration of decision making framework and performance models for traffic safety and pavement management. He received his MS and PhD in Civil and Environmental Engineering from UC Berkeley in 2009 and 2013, respectively. He was also a postdoctoral scholar at UC Berkeley Safe Transportation Research and Education Center. We welcome you, sir, for the presentation.
Okay, perfect. Good afternoon, everybody. My name is Aditya Meduri, and this work was done in conjunction, was led by a master's student, Mr. Rahul, who's now at Cube Highways. And before I get into the work, I also wanted to thank three NSV operators who very graciously agreed to come together to collectively kind of pose this question of, are all class one profilers equivalent? And just kind of get a sense of what might be the source of variability. I think we've only scratched the surface here. And in addition to the CNSV operators, I also wanted to thank Cube Highways to kind of facilitate the data collection as well. So as the title suggests, the question being asked here is with respect to IRI measurements only, which is one of the components of NSVs. And the question is that we often, label these as class one, class two, class three, and class one is really sort of the highest standard in terms of certification that exists. And so the question being asked here is that, is that enough? Because if you pay close attention to where the class one certification comes in, it's more to do with the sampling intervals and the vertical resolution of the lasers, not so much the final output. So if you look at the IRI calculation procedure, you have the profile data collection. So while the profile of the road is continuous, what you're actually collecting through the laser profiler are discrete points, which are then interpolated and smoothened to get a profile, which is then over which you run a standardized vehicle referred to as a quarter car model, which then gives you a measure of the unevenness of the road. Uh, and while the instrumentation is kind of highly certified and tested and validated through ASTM and other guidelines, our sense of the literature and guidelines is that the data collection process, especially that happens in the field, has a lot of variability in terms of how the vehicle is operating, the time of day in which it's functioning, the experience of the driver, perhaps, and leaving aside the human factors in all of this, also it's not possible to maintain the same path each time you're going on the way on the road. And where exactly are you localizing your starting point of the data collection, etc. So followed by, and once you get the profile, then you have post processing through these filters that I mentioned. And to the end user, these are essentially black boxes and you don't really know how the smoothing, etc. is happening. And you'll see through the course of the presentation how that manifests in the final outcomes. So the questions being asked by the study is that there are two. One is with repeatability and the other is with reproducibility. So the question being asked is, if I take the NSV to a location and do two measurements, am I going to get the same value? And the second question being asked is, if I take two NSVs and do a measurement on the same location, will I get the same value? Because the way, if you want to scale up these, data collection procedures, then we're basically relying on multiple NSVs to go out and do IRI and other estimations. So if they're not equivalent, then you're also adding additional noise based on each manufacturer. And the two parameters of interest that I would like to put your attention to, which comes in, provisions and other use cases, is how many number of runs do you want to take to compute IRI. Standard practice for asset management is one, but there are other research efforts where you do 3 to 5 runs, and we'll see what the impact of that is. The other is what is the segment length at which you're analyzing IRI, and we'll see that that also plays a role. So the data collection was done for this effort on NH44 near Kurnool, which is currently being maintained by Cube. And we picked a 6 kilometer corridor which had some variability in IRI. And we had 3 NSV operators whose names shall remain anonymous. But all of them had class 1 profilers which were certified. And each NSV profiler ran over this corridor of 6 kilometers 15 times. So this is not standard practice, but it gives us a sense of, it allows us to at least question the concepts of repeatability and reproducibility. Right. So let me just kind of give you an overview of how the data look like. Again, as you'll see through the course, we can analyze IRI data that we're getting at different resolutions. Profilers also, NSV operators also kind of give different settings on which you can collect the data. So the finest resolution we could get is at 10 meters. And what you're seeing here is that across those 15 runs, there's a lot of variability here. Because at 10 meters, local distresses, local, anomalies kind of feature in a big way. Um, and now if I go from 10 meters to 100 meters, you see that the variability, which is the vertical sort of line that you're seeing, shrinks a lot. So the standard deviation reduces, but also the mean reduces, which means the question of what is an IRI even capturing is a function of the segment length that we're also looking at. Right, and these are individual runs. So to formalize the definition of repeatability, I'll show a little bit of maths, but I'll point in the direction of improvement when I show the plots. So we're combining standard deviation and mean to compute something that is referred to as coefficient of variation, which is a measure of variability relative to the mean of the segment. So it's the ratio of the sample standard deviation and the mean into 100. So it's a percentage, it's unitless. I'll explain what the plot looks like. So as you saw, each segment has some variability across the runs. So what this plot basically shows, the x-axis is the coefficient of variation, the y-axis is something to do with the percentage of segments that meet that threshold. So if you this dot that you see basically says that 90% of segments have coefficient of variation less than or equal to 6%. So smaller the coefficient of variation, the better it is. However, if I go down to and I impose a more stringent standard, only 5% of segments meet that criteria. Right. So ideally, whatever data collection procedure that you have should have a curve which goes towards the left. Okay, so we'll change the parameters at which we are computing IRI and see how the curve changes. So all you need to focus on is whether it's pushing towards the left or not. Right. So the previous graph that you saw was collecting IRI with just left wheel path, a single run. Now, if I combine the two wheel paths, you see that for the same data collection, the average of the two wheel paths has more repeatability. Right. So the direction of improvement again is to the left. That means more the number of wheel paths that you're collecting data from, kind of averaging out the uncertainty in some ways. Now, if I increase the number of runs, so instead of one run and two wheel paths, I do multiple runs and two wheel paths. So the green curve is still a single run, two wheel paths. Now, if I do multiple runs, so let's say if, since I had 15 runs, I can get groups of 3 runs in different ways. Run number 3, run number 5, run number 7, run number 1, run number 9, run number 10. So that leads to, so you get a bunch of different combinations. You take the average of the IRIs and you look at the variability across different permutation and combinations. So what you see again here is that as I increase the number of runs, the curve again shifts towards the left. So anybody who has used FHWA's in the US long-term payment performance program data, it's a research initiative which is publicly available data. They do 3 to 5 runs, which makes sense because the quality of the data, the noise kind of gets averaged out for a smaller segment length. So this is done for 100 meters. Right. So the more number of runs, better. More wheel paths, the better. The other way is okay, you're limited by one run. So now the question is, if I increase the segment length, we saw the earlier box plot variation earlier. So here the purple violet plot is that of 20-meter segments. Smaller the segment, fewer runs, a lot of variability. Now, if you increase the segment length, you lose granularity because you lose level of detail. But then the variable, so as a result, the mean comes down. So the way fluctuations are also smaller. There's more repeatability. So on the face of it, it's great. But then the question is also, what do you need the IRI for? Do you need it for just performance standards? Do you need to develop prediction models for short segments or for long segments? So the context of how you're using IRI matters. The other thing is that if you have smaller segments, it's easier to aggregate. But if you only have larger segments, you cannot go finer. So if you want to compare how does cracking and rutting at smaller segments compared to IRI at those segments, you need to have information about IRI of smaller segments as well. But that's noisy, which means you probably need to do more runs.
So now essentially then there is an 100 segment is somewhere there. Yeah. So essentially what we see is there's a trade-off. Either you have more segments, longer segments, or you have more runs to meet the same performance criteria. So I'll maybe skip this in the interest of time. What I want to focus then is, are different profilers working the same way? Uh, so NSVs are not always interchangeable. So now this is plots of 15 runs. If I take an average of 15 runs and more plot it at 10 meters, we have three devices. It's all noisy. You can't make out one from the other. I mean, not in a good way, not because they're overlapped, because it's all just noisy. Now, if I take 100-meter segments, it's less noisy, but even now, all the three devices are not really showing the same result. At 1 kilometer, 1 kilometer, 15 run average, two NSVs have similar plots, but the third one still doesn't. So now the question is, if you're going to certify and say you're meeting the performance standard, you can pick and choose your NSV and say I meet the standard or not. And this is not malfeasance. This is just things happening inside the black box. It needs certification. It is not just certification. It just needs standardization and most transparency. Right. So they're all class one profilers, by the way. And you can also see the variability here in the runs as well. But again, we're only looking at similarity. The other question is we don't know what the ground truth is really. Right. So in terms of results, all NSV measurements have uncertainty. Some of it is malfeasance in terms of data and perhaps, but there's also, I think, need to recognize where the errors may creep in at upstream as well. There's a trade-off between the segment lengths and number of runs. As a researcher, I would like smaller segment runs, very accurate. But depending on your use case, you may need to figure out what is the precision at which you want your IRI measurements to be. Again, you can go from more precise to more aggregation. You can't go from aggregation to more precise. So you may want to kind of have, if you have a long-term vision in mind, maybe one needs to kind of figure out both aspects. Uh, then NSVs shouldn't be considered interchangeable by default. There's greater transparency required for profile measurements as process in terms of how they process the profiles inside the NSVs. Certification should probably also be conducted in more field operations and not in very controlled environments because there's no marking on the road when you operate on the field. And perhaps driver training may also be required. One of the devices which was functioning very differently had an inexperienced NSV driver. Now we don't know if that was the reason or some other pre-processing, but those questions need to be asked and answered in some way. And policy implications. Now, this is if you want to then do prediction models, deterioration models, performance models. I can't make out if these are two different snapshots, delta IRI across 6 months. I can't make out whether the road has deteriorated or not. Uh, and that's not because of malfeasance, it's just noise. At 10 meters, of course. But even if I do 1 kilometer, I don't really know what's going on and it can't be explained by maintenance activities. And that's not a nice sign because you're collecting all so much data, you want to develop prediction models, you want to have more granularity. Even if you're talking about meeting performance standards, if there's uncertainty and let's say the threshold is 3 meter per kilometer and you're at 2.9, how sure are we that it is actually 2.9 and it was collected with it or not? And also, how are we segmenting, right? Are we going 0 to 1, 1 to 2, 2 to 3, 2 to 4? Or so what this plot is showing on the right is that if I take a 1 kilometer segment and then I slide it over, I might find a higher IRI value than if I just deterministically slide it by 1 kilometer, 1 kilometer, 1 kilometer, 1 kilometer. So I think there's a lot of work to be done, and it's great to have this audience. And I'd like to thank Dr. Pradeep Kumar and CRRI for setting the stage for this. And the other team members in this project who have blurred out just to kind of maintain the confidentiality. So thank you so much. Happy to take questions.
Are we? Can we use AI in this to determine some kind of edges in?
I mean, I mean, one can, I think, triangulate using multiple. I mean, one is sort of looking at a time series and looking at anomalies, perhaps, and maybe if you have cracking and other things to explain. So I think the thing with uncertainty is that some of it is explainable, some of it is not. So if we also use multiple distress indicators to gauge what might be going on, we might get more things. But we need more resolution. I think 3D profiles may help. It's something that needs to be looked at. But I think it needs some research, I think, to really figure out some of these things to parse out I think AI can process things once you have good data, but if the foundation is very weak, there's only so much, because what do you train it against? What do you know what the ground truth is? So without absence of good resolution at the beginning, I think all the other decision making frameworks that you have built upon it will always be a little messy. The other thing you could do is maybe have discretized. I mean, if you have more noise, you're not comfortable in predicting absolute IRI. Maybe group them into indicators, good, fair, poor, or something like that to start off with.
Thank you.
Okay, now we'll start the last presentation of this session.
Yeah, I just wanted to know what was the speed of all the three NSVs. Was this the driver error, or were you also having some variation of the speed of the NSV of the 15 cases you talked?
I mean, we were on the site, and apart from some isolate, there wasn't any major congestion as such. They were all driving in their prescribed ranges of, but it's a pretty wide range, 30 to 80, up to
Yeah,
100.
that's
So,
what my question was. Were you going at 30 to 50 or 50 to 80?
unfortunately, the data logging did not always include speed in it,
Yeah,
so we don't have that information. But again, that's something we need to control for if you do a longer study. Yeah,
yeah.
thank you.
Okay, please. No, please. Okay, last question, Mr. Asif. Last question.
Quick question.
This
I'm
matter
sure,
we will discuss in the lunch hour.
yeah, I'm sure you probably already did it, but were the three NSVs calibrated with the same equipment, same dipstick?
I think they were all independently calibrated on the site. They did bounce test and everything else on before coming to the site. Yeah, so to the extent that we know that, so again, it wasn't calibrated by us, but we kind of followed the practice of the NSVs who said that each of them were calibrated, and we'll take their word for it. Yeah, thank you.
Okay, now invite Dr. Pradeep, Chief Scientist, CSIR, CRI, and coordinator of this workshop.
Screen पे भेजो ना इसको. Hello, come. आ गया, ठीक. Thank you so much. Actually, I have requested Dr. Deepa not to introduce me. So, okay, because I am coming between the lunch time. So, I will try to finish my presentation, which is basically on network survey vehicle. And it is on the theme of the, today's workshop. And I want to cover a little bit, keeping in view the students which are also present here. Okay, what all NSV technologies are presently available, what are the challenges we are facing, and what is the need of the guidelines, and what is the future direction. Okay, so I will very quickly, I will give you some idea, and later on, if you want, we can discuss in details, because I will try to finish my presentation in within 10 minutes. Okay. So this is, we are talking about the road infrastructure today. So this is basically a road infrastructure life cycle, where we start from the planning, we go with the design, then we do the construction, and we operate it, and then we go with the maintenance. So here, if you see, to start from the planning, if you see, and the maintenance, first and the last, these are the two stages where network survey vehicle data is very important, or you can say the information is very important. NSV is not giving you everything. Okay, it is just giving you 10 parameters. Okay, and we need more information, like traffic information is required, excel load information is required. We need to know the cross details of the payment. Okay, so don't believe like if you have some data from NSV you can do wonders. Okay, so NSV can give you the road inventory data and payment condition data, which is very useful, which is very efficiently you can collect, and very accurately you can collect. So this is one thing. And this is, we are talking about the maintenance. So what are the three major stages of the maintenance? This slide is especially for the students. So we have first stage is, if you want to develop a payment maintenance management system. So first stage is the modern data collections. You need the information of your road network. Okay, like sir told from ISRO that 66 lakh kilometer of data, lakh kilometers of road network, which is the second largest road network in our country we have. Okay, so we need some modern data collection techniques, because we, so that we can collect the data very efficiently. Okay, very quickly and accurately. Otherwise, if you are just going with the manual methods or conventional method, you cannot collect, you cannot cover so much of the road length. So what are the technologies? Network survey vehicle is one, falling weight deflectometer is one, for AVCC for the traffic, okay, automatic vehicle counting cum classification, V in motion for the axle load pattern, and some ground penetrating radar now we are using to collect the crust details. So all these technologies are required. But today we are just discussing about the network survey vehicle system. And then the second thing is, when we have all this information, where to put this information? So we need a road information system. So now, in this modern era, we have a web GIS based system, so that it is accessible through your mobile phones also. Okay. And sir was talking about some mobile based technologies also, so that suppose you are in the field, you are seeing some pothole, the condition of the road, you can just click the image and you can upload the same information to this web GIS based already existing system of your country or on the state network. So all these technologies are very much available, very much affordable also. So and this is the we call it as a road information system. And then when you all data set is ready, don't say only network survey vehicle data. Okay, all data set is ready. Now we need to do some maintenance. Okay, we want what we want with this information or data, we want to do the maintenance. Okay, so if you are just collecting the data, okay, let us forget about the accuracy and other things. Okay, we know that what all is required if you want a accurate data. This is not for NSV. Any equipment in your life you are using, we get it calibrated from some standard laboratories. Okay, and if similar is the case here, why we are so much concerned about the, why we don't believe on the network survey vehicle data, I don't know. Okay, because this is not a single first equipment of the world. Okay, so many times since 50 years we are using the equipments, and each equipment we know it has to be calibrated, it has to be validated. So what is different in a network survey vehicle? So this is some a big question. Okay, the only thing is you need to maintain the calibration and validation of the network survey vehicle, and then you just believe it. Okay, and use it. Then once the data is ready, then you have to connect with some management tool. So what all management tools are available, as Mr. Satyakam Sahuji mentioned about the HDM4 model is there for the proper maintenance planning and budgeting. But we have now in between tool also, which has been recently developed by CRE, and I am very happy. Actually, this is based on our research in payment evaluation division, and it is a part of our national guidelines IRC 82 2023 in the form of PCI. So this is, I am not give much time on this. All uh, all parameters which is being collected by the network survey vehicle, you all know. I will skip these slides, and these are the technologies. The first technology we see in network survey vehicle is, it is the photogrammetry survey vehicle. That means here, uh, apart from other parameters like IRI, routing, texture, payment surface distresses, geometry, and GPS and right of way information we are collecting with camera, but here we are using the payment surface distresses with two cameras. This is, that means we are collecting the 2D information. So these cameras can give me the area of the defect, not the depth of the information. That means we are not collecting the severed information. So this is one technology which we are using from the last 10 years at CRI. Again, now the another technology which is very popular in India and abroad also, which we call in short LCMS system. Okay, laser crack measurement system. The beauty of this system is, apart from other parameters, this system can give you the depth information. If you want to know what is the width of the crack, what is the depth of the crack, okay, and what is the depth of the pothole, okay, that is possible. Okay, so all these things are there. Again, now there are some issues, because again we need some technology. Now we are talking about the AI/ML techniques. Okay, so AI/ML going will help you. Okay, to automatically giving the automatically quantifying these defects in terms of the area and the depth information. And the third technology what I am seeing in India, it is a lidar based system. Again, this is based on the 3D point cloud data with high accuracy and density data they are collecting, and apart from IRA, texture routing, geometry, and 360-degree right of way video, which you see in LCMS system. So these are the three technologies available, broadly available in India. One is the 2D system, and two systems we call it the 3D systems, where we get the JED information also. Uh, the things. And what are the challenges? This is the important slide. What all challenges we are facing if you are having a network survey vehicle system, okay, and you want to use this network survey vehicle. So this is actually based on the feedback from you. This slide you will not find anywhere actually. This is my experience, or you can say the CRE experience, and the feedback which we receive day to day basis. So some people says like some issues in data accuracy and precision are there. as mentioned by Dr. Aditya also, he has done some study. Okay, some issues are there, but we are going to standardize it very soon. And there are some issues related to traffic and weather conditions, some issues related to the terrains. Suppose you have a very high-end network survey vehicle, but the terrains are different. Okay, so there are some issues. Okay, then validations, validation. Some people ask me, sir, how to validate it? I want to validate my NSV, but I don't know the procedure. Where is the procedure written for validation? Okay. Similarly, for the calibration, I always ask them to just ask with the OEM of the manufacturer of the network survey vehicle. They can give you the solution. Similarly, there are some standardization issues related to data processing time and reporting. Some standards like NSV specification, data collection analysis, they are missing right now. And training and certification, there is no well identified agency apart from CRI where you can get the certification basically. So there is we are also giving the training, but we are not giving any certification. Okay, like in case of road safety audit. Okay, so we are giving a certificate. Okay, now you are a very the trained road safety auditor, certified by the ministry or CRI. But there is no agency in India which can give you a certificate that now you are a certified network survey vehicle data collecting the operator or some trained person like this. So these are some things. And now let us see about some guidelines. What guidelines broadly we are using related to the network survey vehicle. So IRA measurement is very popular. IRA measurement is very popular, and everybody is saying that I am collecting the IRA data as per ASTM standard E950. So what is and with class 1 category. So what is basically the class 1 category? So class 1 category is nothing but when your longitudinal sampling interval is less than equal to 25 millimeter or vertical resolution is less than equal to 0.1 millimeter. Okay, this is the technology basically we are talking about. That means you qualify for the class 1 category. But again, there is a catch. When you are collecting the data at 25 millimeter sampling interval. Okay, so that means you are making a actual profile of the roads. So it is a combination of various wavelengths, short wavelengths, medium wavelengths, long wavelengths. Okay, and not all wavelengths are going to affect your riding comfort. So what we do, we apply some low pass filters, we apply few high pass filters, and then we just filter out the actual wavelengths which are going to affect the riding quality, and then we develop the model which is known as IRI. Okay, we calculate the IRI. But I have seen in some cases, okay, though somebody is applying the low pass filter, somebody is applying differently, and the B agency is applying differently. So in that way, if you try to compare the results of IRI for the same road, then it will not match. So this is one reason I want to mention. So because of that only, now we are working on the standardization of the riding quality measurements. Other standards like now we have developed with the help of CRI, and I am the member of S6 committee of the IRC. So we have developed the guidelines for road asset management system. Mr. Neeraj Chadda is also member of that committee. So we have developed a guideline for road asset management system IRC 130-2020. So this code we can help you to just it can guide you about the data collection. Okay, the chapter number 5, you can read it. Okay, all who are all concerned about the data collection using network survey, they must read the chapter number 5 on data collection using network survey system. So this code is very much available. And now the other code I was mentioning, the maintenance management based on payment condition index IRC 82-2023. Okay, so it is the code of practice for maintenance of bituminous roads. The good part of this code is that now when you collect the data with network survey vehicle, and based on only 6 parameters as mentioned by Mr. Munjal also, now they are going to adopt this code in NHAI. Okay, this is very good news for me. So here, if you have IRE information, pothole information, rut depth information, cracking, raveling, patchwork without any severity level right now, to start with without any severity level, then you just put these values into this software, uh, the utility which is coming with this software, and you will come to know the score of your road. Suppose, and 0 is the failed condition and 100 is the excellent condition. Suppose you are getting score 60. Okay, So like in our board examinations, so the system will tell you what maintenance is required for this road. Suppose your score is 95, that means your road requires only routine maintenance. Okay. And suppose you are getting 15 score, that means your road requires reconstruction. So this is a wonderful thing we have done, and we have validated this tool also. It is just not we have developed some equations. We have, along with Professor V. Raghavanji, he has helped me actually for the validation of this code. And in my opinion, this is a very successful attempt by IRC and CRI. Now you can see, based on this code, we have just rated the entire state of Odisha in the year 2024, this year only. Okay, we have collected the NSV data, and then we have, just for the testing purpose, okay, first time in the country we have applied this code, the rating system, to the entire states, and you can see the numbers, various numbers you are seeing: 69.98, 58.36, 69, 75.79, and this and that. So based on this, now you have a preliminary maintenance plan for the entire state. Okay, so right, so you can just the system can tell you how many number of roads require routine maintenance and preventive maintenance or periodic maintenance or minor or major rehabilitation. So these are the some recommendation, the guidelines. Yeah, yeah, just last. So now the guidelines and recommendations we are trying to develop, where we are going to put the objectives, equipment specification, calibration and validation process, data collection protocols, and other quality data quality standards, data processing techniques, standard templates, and safety protocols. Everything we are going to include in these guidelines. These are some of the training requirements and other documentation requirements. So we are in the process, and these are some major studies which successfully CRA has done. They are the major studies I am saying on the state level we have conducted in the past. From the starting from the 2010, I mentioned 40,000 kilometer of data was collected using network survey vehicle. So like this one, the first system, this was the second system for the Golden Quadrilateral Road Network. Then this is for the entire Kerala state. Uh, and this is for the runway payments also we are done. Right now we are doing the study using network survey vehicle data we are utilizing for 10 airports of country. And similarly for the Odisha states, we are working them with them. This is the ORMs of Odisha Road Asset Management System. We are utilizing the data. So these are the some enhancing some recommendations here, enhancing data encryption and security for network survey vehicles. Again, this slide is based on the feedback I am receiving from you. Some people are just they want that the data must be encrypted actually. So all these things we are just considering all these parameters, and these are the future directions for NSV applications. Again, we don't limit the use of networks or a vehicle up to the maintenance of the road network. This is my opinion. We should just now the manufacturers and other people who are involved in network survey vehicle applications, they should think about the disaster response and management system, agricultural application, road safety audit. Okay, already some work is being done. Intelligent asset management, digital twin for real-time simulations and environmental monitoring. So these are some future directions we should think of. Not only we should limit our data or information for the maintenance part, we should work in this direction also. Thank you so much for your kind attention.
Question answers we will take in the lunch hour. We are already late.
We are actually little late. So now we invite you all for the lunch, right? A quick lunch, I must say. Yeah.
I would request chairman and all the speakers to please join the dais. Now I would request Chairman Sri Sunil Jain sir to present a souvenir and momentum to our first speaker, Dr. Amit Munjal. Our second speaker, Dr. Samir Serenso, please. Our third speaker, Sri Satyakam Sahu, sir, please. Our fourth speaker, Professor Aditya Meduri, please. Sir, please. Dr. Pradeep Kumar, Chief Scientist, sir, please. हाँ. Now, I would request the coordinator of the workshop, Dr. Pradeep Kumar, sir, to please present the memento to our chairman. Thank you, everyone, for joining the session. Now, you may please proceed for lunch.
Yeah, yeah. Yeah. So the lunch is arranged in the guest house for all our eminent speakers, distinguished delegates, chief scientists, HODs, and all CRRI colleagues may please proceed to the canteen VIP hall for the lunch. We'll reassemble here at 2:30 p.m. Thank you.
एक ही पीपीटी है। हाँ एक पीपीटी अभी आया था। अच्छा ये कौन सी कंपनी का है? कोएक्ट का। ठीक है पहली प्रेजेंटेशन होने की पहली हो ना। उसके बाद क्या है कि उसके बाद फिर वैसा फिर चार ही है ना पांच नहीं पांच Good afternoon, esteemed guests and participants. I am Dr. Akash Gupta, currently working as a scientist in Payment Evaluation Division of CRRI, and it is my privilege to conduct this technical session 2 as a moderator. Today's session is a vital component of this workshop, where our distinguished industry sponsors will share insights on the practical applications of network survey vehicle operations and advancements brought by the industry. So we have an excellent lineup of presenters today who will share their expertise and experiences. Now introducing our presenters and their companies. Our first presenter is Shri Rongali Rajshekhar, Managing Director of Coact Solutions Private Limited, Hyderabad. Next, we will have Ms. Rakhi Ravi, Business Development Manager at Khanna Designers and Consultants Private Limited, Gurugram. Following her, we will hear from Mr. Santosh Kumar, Project Manager for NSV at IRSM Private Limited, Hyderabad. Our fourth presenter is Shri Ashutosh Bhatnagar, Managing Partner of Blue Oceans Systems Infotech Private Limited, Mumbai. We have with us Dr. Pradeep Kumar, Chief Scientist, who will be chairing this session. Dr. Pradeep Kumar has a doctorate in civil engineering from Indian Institute of Technology, Roorkee. He is currently working as Chief Scientist and Professor, Academy of Scientific and Innovative Research at CSIR CRRI. The various projects undertaken by him are related to the road asset management, road maintenance management, airfield payment management system, and non-destructive techniques for payment evaluation. He is the one of the key persons for the successful implementation of modern payment evaluation technologies in India, mainly the first network survey vehicle for the automated road inventory. Some of his recent major contributions are Guidelines on Measuring Road Roughness and Norms, IRC SP 16, 2019, Guidelines for Road Asset Management System, IRC 130, 2020, Guidelines of Skid Resistance of Pavement Surfacing, Code of Practice for Maintenance of Bituminous Roads, IRC 82, 2023. So each presentation in this session will be for a duration of 15 minutes, and I kindly request all the presenters to adhere strictly to the timings to ensure a smooth flow of the session. At the end of all the presentations, we will have a discussion or question and answer session for the audience that might have for our sponsors. Now I request Dr. Pradeep Kumar to proceed with your opening remarks and guide us through this insightful session. Please, sir.
Okay. A very good afternoon to all of you, and thank you, Dr. Akash, for a nice introduction. In this session, we have five presenters. Just I want to tell you something about all these five presenters. If you see, there are one company that is the Coax Solutions Private Limited, and they are good in importing the technologies, okay, the different technologies for related to the payment condition monitoring, inventory, and other falling by deflectometer or traffic related studies. So they are good. And then we have some company like Blue Ocean. They are manufacturing the indigenous network survey vehicle system in this country. So again, it will be very interesting to listen them about how they are developing, what are the development stage of the indigenous network survey vehicle in India. And we have some form like uh, they are providing the services, okay, because if you see this workshop, we are talking about the NSC application, we are talking about the data collection, okay. So we have some companies, two three companies in this session where we are going to they are going to talk about the data collection. So this is a good opportunity for all of us, all the participants, okay. And with this I request all the presenters also that they to be very specific to the work what they are doing or the services they are providing, so that we have sufficient time for question answer session, okay. So with this I invite the first presenter, Mr. Rongoli Rajshekhar. He is the managing director of Coact Solutions Private Limited, Hyderabad. So you have 10 minutes, huh? Okay. 10 minutes, right? Okay.
Yes. So good afternoon, everybody. I think we have a nice lunch. Um, good evening, good afternoon, everybody, and respect to Chairperson Dr. Pradeep Kumar, Chief Scientist CRR. Thank you for giving me the opportunity. We work with Coax Solution Private Limited, works with a lot of technologies like payment evolutions, as well as ITMS, ATMS, and etc. Today I'm talking about the network server vehicle, which is completely deep learning based. Why we learn that we told is deep learning based is deep learning is based on mixing of AI and machine learning and innovation in sensing and AI solutions for infrastructure evaluations. So we have a 30 years commitment in the global market. In 1990, we started with LEDs, and 2000, yes, 2010, 2020, we work with line scan cameras, then area scan cameras, and DSDV technology. Then we come out with completely AI-based, deep learning-based solutions. In 2016, South Africa, we have installed first NSV integrated with Raptor, traffic speed deflectometer, which can give structural and functional parameters with traffic speed in 2016. Then after 30 years, we have launched a 0.5 mm sub-mm 3D sensor, 3D sensor from Payweight from Whaling Systems Corporation, developed by Dr. Kelvin Wang. The effect of the software is not even done by 2 or 5 people. It is 1,000 students research done by last 30 years from the Oklahoma University. So recently we have 3 years back we have supplied one of the unit to Madhya Pradesh, K8K, and we have used multiple traces like pixel level accuracy, diverse training data, deep neural networks. I'm not going to the deep like CNN networks, GANs, and everything. Parallel computing efficiency, non-cracking distresses, real-time processing. Now we come out with the latest with the real-time processing, the data and collecting the data, real-time analysis with good consistent accuracy, better than 95% all the time. And also 2 years back, we have supplied one of the pay key system to ERDC, Engineering Research Development Corporation. They have done 60 airports, automatic PCI classification number for all the airports. It is validated. And data collections, because in IRC clearly says, suppose if you don't have any local standards like ASTM or ASTRO standards, they are mentioned clearly in the website. You can use directly the ASTM or ASTRO standard, which is available in the global market. Like roughness, everybody using ASTM E950, E95022, as well as ASTRO R5754. I'm explaining what is the difference, how we do the calibrations, latest calibration on ProWell from FSWA. And also we use IRA ASME 1926. And also we have included IRC SP16 2019, which is CRR has put a lot of efforts to get it in the guidelines for the national and state highways. Rutting, we use ASTRO R87 and 80 as the guidelines from the rutting measurements. And cracking, we have used two cracking international standards. One is ASTO R8517, which is group cracking, which is done 4 years back with our system. It is already there. And also recently NTRO, which is done by IS 333, draft has submitted to TRB for the approval for the crack detection. And faulting, we have the standards we have to do for a lot of bridges and rigid payments for the faulting measurements as for ASTO standards R57 and 14. On microtester, we use 5 ASTO bands, MPD and MTD, mean profile depth and mean texture depth, which is now we are facing a major challenges because most of the correlations are coming from texture to skid resistance. Now we recently 3 years back we have developed a 0.1 mm accuracy laser, which can measure below the 0.5 and 50 mm micro texture. Then we can measure the skid resistance number with the 0.1 mm laser with this one. So we have condition payment recessors. We use GPU high processor like RTX 3090. Earlier we used TA1080 GPU card. The advantage of GPU card is we can do 1 lakh algorithms simultaneously with high speed. We have detecting automatic crackings like crack of payment like length, width, depth, as well as the percentage of density, area, and severity levels, as well as potholes, area, depth, raveling, and depressions, edge breaks, and bleeding. As for the earlier play associate SAR has told that we need only 6 parameters. We can do roughness, rutting, raveling, texture, as well as edge breaks. Automatically, the 6 parameters with 95% accuracy. So now we have launched real-time data processing. While collecting the data, we can see all the real-time parameters like 3D intensity data as well as crack detection, pothole, like road inventory and everything with real-time data collection as well as real-time data processing. And also real-time multi-distress identification. While collecting the data, we can do the crack as well as pothole, patches, and markings, as well as some joint faulting and everything. So this is some of the images collected from 2023 with our system with 8,000 points with 0.5 submitter accuracy, payment marking detection, some of the images which we collected. Payment joint detection for the rigid payments, we automatically detects all the joint faulting for the bridges for the rigid payments. And expansion joint detections, it detects automatically. This is some of the images which can see raw images in the results. And payment groove detection is automatic for the rigid payments. This is manual detection, some of the images you can see. Now the faulting detection, we can see wherever once the data is collected, we can see the longitudinal and transfer direction wherever you move the cursor automatically. And detection multiple distress and generic patterns. We have a detection of 95% accuracy with the cracks, seal cracks, potholes, patches, corner breaks, and divided slab, joint faulting, as well as markings for the rigid beds, joints, expansion joints, and grooves, as well as manholes. So this is our US system, which is there. We have using DZPS, which is mounted on both the sensors. Every 3D sensor is having two accelerometers of high precision accelerometers, which can take the body movement, as well as we have two rovers, which is we apply chorus real-time corrections for the accurate submitter accuracy for the DZPS. And also we use Aplanix integrated with DZPS, which we can get cross slope gradient, as well as horizontal curvature, vertical curvature, as well as percentage of rise and falls. Everything will be calculate. See one of the small video I'm playing. So this is our US system which can mounted in Isuzu vehicle. So this is our software which can we do the crack as per 5 ASTO bands within the wheel path zone 1, zone 3, zone 4 and zone 5. We can remove the line markings according to the ASTO 5 bands for the crack detection. So we have all the processing for roughness and writing. The final output will be seen. You can see the real-time text on the transverse profile, transverse cracking, alligator cracking, and longitudinal cracking, reflector cracks. It detects automatically with 95% with the crack depth, crack width, and density as well as severity. And now we have recently launched real-time processing sample. While collecting the data, simultaneously we can run the ADS software, automatic distance analysis software, automatic processing for all the parameters. So while we collecting the 100 kilometers, we can process simultaneously both. Every 100 meters or 50 meters rutting, we can see the real-time profiler And also we can see the real-time cracks and everything will be processed without road inventory. We are tied up with Road Athena for the road inventory automation. Almost we have completed 70%. We are working on that for automation for the road inventory. And this is some of the Indian road conditions. We have collections of data. We are training to the AI for the other parameters like showing, bleeding, and some other parameter like depressions. 3 we are working on that. So we need to try give some images for training. We are got some 500,000 images. Maybe another 2 months. That one also we are making automation completely. And this is fault detection. And all the 3D images will be geotagged. Wherever we after processing, we get all the tracks and everything on the top with the Chineses as well as the geotagging with the GPS coordinates. And this is some of the group tracking for the calculations. And we do the block calculation recently. FSW and US, overall the manufacturers of 3D sensors, they have launched one software called ERD format with Proven with the block calibrations of 1/4 half inch and 1 inch. And we have calibrated all the blocks with the NABL calibrated locally. And we do the base plate as well as for the international standards, we follow block calibrations. This. So earlier what happens, each manufacturer is having the laser calibration like 25, 50, 80 blocks. So suppose we do the bounce test, suppose we got a 0.5. So we can put it 1 mm and we can process this one. Now the Sprovel software, ERD software is given a real time. So every data collection should be very accurate for the IRI rating. Basically, if we have control the 4 parameters like IRI rating, raveling, then we will not think of cracks. Then automatically the patch and potholes will not be there. If you will fill the maintenance of the cracks, then definitely will not get patches or potholes next level. So we have got this calibration as for the ERD format FSWA. We do with the 4 block test. And also we do the bounce test. Recently, 6 months back, FSW has launched an online this one so that we do the bounce test. Before collecting any data, we have to do the bounce test for the IRI to get it within the limits. Once that file is uploaded in the Provel software, it will give for the 3D sensors, it gives Z ratio, which you have to enter in the software. If the limits are not there, it will give fail. So every data collection operator should be trained on the field how to do the bounce test. It should be passed. Also, we have to do the straight edge before collecting the data. So that every day if you do the practice as for the SOP, whatever the vehicle, it will not matter. You will get the same values within the limits. This is the calibration, and also we do the road geometry calibration using the 180, 360 degrees with the GANs. And we use IMU calibration for the IMU sensors for the curvature and gradients. And now we have introduced road inventory cameras of 9K HDR, dynamic HDR camera with 8640 and 4000 pixels. Even 114-degree camera is right of view, which can be next generation of 2024. And it gives more realistic than higher than quality than 360 Ladybug camera. So this is a view of total 114-degree camera, single camera can be used for the right of way. And we use the asset inventory calibration using the grid calibration as well as geotag calibration for all the asset inventory. This is our software is inbuilt asset inventory. We don't depend on other third-party softwares. And also we have launched through ERDC, Engineering Research Development Corporation US. We have developed automatic airport PCA calculations as well as our ADA automatic distance analyzer has capacity of PCA calculation automatically as for the IRC 82, also as for ASTM D6443. Because we have developed our own software from last 25 years, we have very easy to any corrections or make templates very easily because. And this is a stretched virtual one of the runways. We have made it asphalt and rigid payments with the PCI number displayed automatically. So this is a PCI calculation. And also just see we have a pay 8K 3D sensor. We have challenges for the maintenance part of the 3D sensors. So we have got factory trained because all the 3D sensors are integrated with different manufacturers of lasers, cameras and everything. So our 3D sensors are, laser sensors are calibrated locally in India where the supplier of laser sensor is available, manufacturer supplier is available in India. So we do the laser calibration here and also camera calibration intensity, everything will be adjusted by ourselves based on the very easy to maintain and very easy to give local support instead of depending on the factory. And also we have WIS, which is having an inbuilt accelerometer and IMU. And also we have integrated with structural and functional evolution parameters, introducing with reflectometers, which is integrated. And conclusions, we have ultra high resolution powerful. We are working with coexist capabilities and repeatability, and we are working in super resolutions. And we are also working with all cloud 5G cloud based, so that the software will be running on the top on the cloud base. So once your data is collected while collecting the data itself, we can process the data and we can upload it to the cloud. It's a very data file is very small, so that we, instead of waiting for 48 hours, we can collect the data so that we can process in the on site. We can send the MDB file. So after 1-2 days, we can we can copy the data and we can send it to the centralized. So thank you.
So, any question from the audience?
Excellent presentation, sir. Just wanted to know, when you do the IRI calculation using the 3D profile, are you using selective lasers to compute the IRI? Are you doing the overall average, some weighted average of all the longitudinal profiles that you get, or some mix and match?
Yeah, actually we have used the average IRA also, sir, for the left and right IRA, because what we use, we have a 8,000 points, because we got 0.5, because we called 4,000 points into 0.5, 8,000 points into 0.5. So we cover 4 meters width, even 3.6 meters we get the within the limits. We do the block calibration like 0.001 inch, so that it can be.
So basically, you get the left and the right wheel path from the 3D profile, and then basically track
Yeah,
that.
we get more points.
Both
Instead of
points.
point, we are getting complete profile of longitudinal profile as well as transverse profile.
But for the longitudinal profile, you're just slicing the 3D profile to get two wheel paths.
Yes.
Perfect.
We get
Thank you.
more number of points. We are not depending on one point.
Sure.
Because our 3D sensor itself can give the IRI, because you are using accelerometer with the high resolution, so that it takes the body movement and you get the laser height, so that we can get it exact laser. And we do the bounce test, because most of the things we have seen in the field, most of the operators don't do the bounce test. They don't do the rating, just they start the vehicle and just go it. Until unless you are not confident on the bounce test, this one you will not get the accurate. If you do both, any system, any NSV, it will give same result. That is my difference.
Okay. Thank you.
Sir, thank you for the presentation. Sir, regarding the distress data, live distress data, you showed we are able to extract the live distress data. Is it, I mean, since we have an experience with many LCMS systems where it needs a additional processing. After data collection, it takes much time. Let us say for 100 kilometer, it takes 1 day for to process the data to get the
Yeah, that's why
other distress data.
that's why we are telling that deep learning based, because normal workstations we collect that data of 1 kilometer, as example 1 GB. We have to use 2 GB. Then we have processing speed will be very slow. Means it will not process one algorithm at a time. But because we are using GPU RTX 309 with our own algorithms, which is machine learning and AI based, so that it processes very fast. We use a lot of algorithms. We get trained with almost 10 lakhs to 20 lakhs kilometer images, trained with the cracks like raveling and patches and everything.
In addition to just continuation to what Sir has mentioned, the data will be collected, roughness data will be collected at, let us say, less than 25 interval. As per the IRC SP16, so you have to remove the some certain wavelengths, let us say from 0.5 to 50 meter.
Okay.
Beyond that, whatever the wavelengths, that needs to be extracted. Can you explain the process? I mean, how it is being
Yeah,
calculated?
because in our automatic distance analyzer, last time Dr. Pradeep sir also told we have a low pass, high pass filters, so that we can apply that to low pass, high pass filters. We can get it only the IRI value accurately. We have the filters inbuilt software. We can apply it and we'll get it. Everything will be clear.
Okay.
We have the low pass, high pass filters in the processing toolkit. It can be processed.
One last query, like you have mentioned 95% accuracy. How you come up with that percentage? Like,
Yes, because we have proved in the US. Also, we have an Indian system. We have taken manually with 10 kilometers. We have done it manually. It is coming same accuracy.
Thank you. Okay, thank you very much. Okay.
Hello, hello, hello. Excellent presentation by Rajshekhar. I have very simple. I am not expert in network survey vehicle, but I have used the network survey data in 2001, like Romdas data acquisition system. So my question is that, for example, in Romdas at that time, they have the trigger, like for example, Calvert and other longitudinal, like bridges and other kind of thing. For example, if you need the user like RI value, IRI value, remove the like cross drainage works. For example, the somebody wants, like for example, most of the like bridges and other cross drainage works, they have the different phenomena, like not a flexible payment, maybe that is a composite payment, maybe different kind of the phenomena. Is it possible to exclude the bridges and other culverts portion?
Yeah, recently 3 months back we have included bridge deck evolution with the load as well as the IRI that we can share you the papers. And we have already completed both the
Means while going the vehicle, it will give the triggering that this is starting point of the bridge, this is the ending point of the
that event marking we can do
Let me
always.
interrupt actually, because this is a very good discussion part also. So we never recommend to exclude anything. What you do, you just collect the data, but we have a event marking system in each network survey vehicle. Okay,
That
if you are seeing that some object is there or some event you want to exclude later on, so better is you just process the data at a minimum level, like 10-meter interval, you process it. Okay, then later on, when you know that in this 10-meter interval, you don't want it because there is some construction work is going on. Because of that, riding quality level is high or some other problem is there. Then at that stage, you can exclude it, but not at the time of data collection. You should not never exclude anything. You just collect it.
My last question, like during particularly AML, very good for the processing and the image processing, but a lot of tools are available. Like you only look once, like you immediately can get the data and cloud computing and machine learning. But in the case of rainy season, you see like most of the coastal corridors, coastal India. So the rainy season, is it possible similar kind of accuracy during the rainy season?
No, rainy season, no lasers will be wet surface, nobody works. So that's
Wet
the
surface you will not recommend to
No.
collect any data.
Wet surface will not be.
Any guidelines, for example, the rainfall intensity is less than this, or rainfall intensity, for example, sometimes drizzling is there. So like any SOPs are there to collect the data?
This laser technology will not work on wet surface condition. The point laser is also not.
Wet surface will not.
It will absorb. The wet surface will absorb the laser. It will not come back, reflection. So you will not get anything. It is not reliable also. Thank you very much, Rajshekhar ji, for a nice presentation and for your company. So now I think the mood is set. Actually, now the people are asking the relevant questions and related to the data accuracy, है ना? And some constraints they face during the network survey vehicle system. So now I am just inviting the next speaker, Miss Raki Ravi. She is a business development manager, Khanna Designers and Consultant Private Limited, Gurgaon. Right. You have, Taki, you have 10 minutes, okay, so that we can have a good discussion afterwards, right?
Good afternoon, everyone. Myself Raki from Kanna Designers and Consultants Private Limited. Firstly, I would like to extend my heartfelt thanks to CRRI for giving us this opportunity to present our company. Now, talking about us, KDC is a premier consulting organization and a well-established company in transportation engineering committed to achieving excellence in providing comprehensive engineering solutions that meet the unique needs of our clients. We offer a comprehensive range of engineering consultancy services around multiple sectors. Our sectors are like road asset management, highways, bridges, structures and buildings, water, environment, railways and metros, building information modeling, etc. And under these sectors, we provide services like payment strength evaluation, structural health evaluation, field survey, traffic studies, DPR, detailed design, proof checking, safety audit, etc. Now coming to road asset management. It is a systematic approach for maintaining and improving the road infrastructure. It involves planning, organization, and controlling resources and activities to ensure that the roads are safe, efficient, and non-accident prone. By managing the road assets effectively, organizations can ensure that the roads remain in a good condition and which leads to minimize the disruptions. Now, the software used in our network survey vehicle is ROMDAS with LCMS2. Our vehicle is mounted on a force traveler van for pavement evaluation, road condition assessment, and road inventory management. It provides 3D profiling and automatic defect detection. LCMS2 meets the latest requirements which are laid down by NHAI, NHIDCL, MORTH, and all the state PWDs, etc. And our NSV is being used in the pilot project with NHAI, and the data have been captured and presented in the templates as decided by NHAI, meeting all the requirements as per the NHAI guidelines. Now, these are the specifications of our network survey vehicle. First of all, the camera. It is equipped with a high resolution 360-degree digital camera, which enhances data collection speed and accuracy at every 5-meter interval. Next, it has a GPS receiver system with a base station to provide differential correction and accurate location data. There is an inertial navigation system to calculate the road geometry, such as radius of curvature and crossfold. Next, as discussed before, the software used in our network survey vehicle is ROMDAS that can view spatial data to plan the surveys. LCMS2, laser crack measurement system, it is used for detecting the surface defects like cracking, roughness, rutting, etc. High resolution distance measuring instrument, HRDMI. It is a distance measuring instrument which works on the basis of tire rotation and it provides accuracy of less than 1 mm. This slide is about the laser-based measurement and automatic quantification of pavement surface distresses. That it shows the type, extent, and the severity of the pavement surface distress. Um, Type and severity means longitudinal, transverse, alligator, multiple sealed cracks, etc. Rut depth, width, and cross-sectional area for each wheel path. Macro texture, pothole detection and measurement, raveling, bleeding, shoving, concrete joint, patching, pick-out detection, rumble strip, edge drop-off and curb detection, pavement marking, and in the picture it is shown the cracks, which you can see is the cracks. Next is about laser crack measurement system. It operates at 28,000 hertz, which acquires full 4-meter width profiles of a highway lane at normal traffic speed. It captures both in the daylight as well as in the night time. It creates access to .mdb file for raw data as well as JPG images so that it shows the quantity and the severity of the defects of the road. Optional roughness or geometry upgrades very high accuracy data, making it perfect for analysis of major highways. Automatic detection of severe pavement defects, lane marking detection. Now, these are few things which we had to keep in our mind while handling the network survey vehicle. First is the road condition. The system should not be in a, system cannot be used in an extremely bad road. And as discussed before, the payment server should not be wet while using the laser sensors. And for operating this, a trained trainer is required, and the vehicle should only be driven by a trained driver. Now, this is a small video which of our network survey vehicle. Please have a look. Now, recently we have conducted an NSP demonstration here at CRRI for training programs on payment evaluation techniques and their applications for maintenance and rehabilitation on September 12th, 2024. Just few photos from there. These are the recent surveys we have done during using the network survey vehicle. And as I have said before, our NSV is used in some of the pilot projects with NHAI, and the data have been collected and captured and presented in the templates as decided by NHAI, meeting all its requirements. Our fleet is complete by owning all the road asset management equipments of payment testing and structural health monitoring instruments. These are, I'm just showing the pictures like our in-house equipments, network survey vehicle, mobile bridge inspection unit, falling weight deflectometer, bridge health monitoring system, retro reflectometer, both vertical and horizontal, automatic traffic counter classifier. Thank you.
Now, any questions from the audience, please?
Thank you.
Actually, you have just mentioned about the 360-degree camera. Okay. So 360-degree camera, that means you are getting pictures in all directions, right? So when you are moving in the longitudinal direction, okay, and after every 5 meter you are getting one frame. You mentioned here, है ना? So my question is, and then all frames are measurable also. We can measure. Like if I want to measure the carriageway width or the shoulder width, everything is there. So my question here is, what is the measurable range in left and right direction? Because you are capturing the video in every direction. So suppose I want to measure right of way information, some information, right of way. So what is the range of that?
Well, the resolution certainly decreases with the distance, but we get very good data up to 25 to 30 meters. Beyond that, I will say it is not very good quality data. So up to 25 to 30 meters, yes, we have done that and we have found it out. And one more important thing which I would like to point out here is, uh, which is very important actually, our GPS is sitting on the vehicle, correct? So when you are doing the inventory mapping, what is happening? You are clicking it when you are in the vehicle, whereas the inventory is 10 meters or 15 meters away. Practically, what you're doing is uprooting the inventory from there and bringing it on where the vehicle is, because you're giving the GPS coordinates of the vehicle. not of the inventory. You get my point, sir? In this system, which they are using, there is a special software. Now, this software, in post processing, you can go and you can then calculate the distance also, how far that inventory is, okay, and then give the coordinates of that. Second important point, she was talking about frame width of 5 meters. It is possible that within one frame width, there are two inventories. One is at 10 meters, the other one is at, say, behind it at 14 meters or 15 meters, right? But they are within the same frame. Usually, what people do is both the inventories will be in the, they will give the same coordinates and bring it over to the highway. Here we can give separate coordinates to both the inventories, and that is how it goes. So the important thing, Manjal Sahab, for you would be, just sorry for that, is that when you are doing this, now you are collecting the NSV data. It is important when you're doing the inventorization, right? It is important that you get the right GPS coordinates of the inventory, not of the vehicle. Right now, what we are doing is we are giving it of the vehicle. Inventory is not on the highway. Inventory is on the right of way. That's my humble submission.
Yeah, just a minute. Actually, what I was mentioning in my presentation also, we want to utilize primarily the NSV data for the maintenance of the road infrastructure. Okay. But now this is the time we should utilize this data for other purposes also. Like we are collecting the, now we have 360-degree camera. Okay. That means we are able to capture the all directions. Okay. With some range. Even the top vertically also you are able to see, so that you are just passing through some underpass, you can just see inside that also. So this is something, a very interesting feature. But the limitations I am seeing with these systems are, so this is a message for the OEMs also, like Neeraj Chadda ji is representing some international firm and some other companies are also present here. The message is we should now work on the processing part. Okay, we want, like Venu Muruganji is sitting here, so he's working in road safety. Okay, so suppose if you can give the solution, like automatically after capturing the video data, automatically you can tell me the size of the signboards, size of the signboard, their quality, or their location with exact GPS coordinates and the chainage information automatically. Yeah. 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 So all these things are will be very useful. So not only we just concentrate on the maintenance part, but we can utilize the data, because sometimes what I feel, we are collecting so much information on our highways or the roads actually, but we are just utilizing 20% of that data. So, and the problem here is because we don't have the proper analysis tools available for the different applications. As I mentioned, various different field shifts.
Sign,
Yeah.
signboard, how to in terms of one is location and that thing it may give maybe the whether it is an informatory sign or a regulatory sign, cautionary, it may give, I suppose. And secondly, in marking, what about the solid marking and broken marking and the chevron marking? Those things, does it give? But does it get decoded as a what type of marking it is?
We have actually started something here. So we are any ERP software is always dependent on the pool of data. So it's going to follow that flow.
So it has that you are not decoding and giving.
That we have reached around 85%, but that's normal. That's normal. In the laboratory, it comes to 95. But when you go to the field, it comes down to 80. And we are different.
Yeah.
And because we reach to the top 95 plus, we don't do nothing.
Okay. But it gives you something, but does not.
So here, earlier what happens, we learn from CRM, NSC from last 15 years. Whenever you do any road inventory calibration, you take one reference point of DCPS. What happens when you take one reference point of geometry device? It is a geometry device installed inside the vehicle. From the local reference point, we'll give XYZ. From DCPS, we'll give XYZ. From all the cameras, we'll give XYZ. So that while collecting the point itself, we do the geogrid calibration. Once the data is collected, again, we don't want to give any outside values to the assets because the reference point is same for all the parameters. So that once the data is collected, wherever it leaves that asset, You say it in several times. Because again, we not use this technical take any radar points, for example, non-reference point. You take one non-reference point, then access will be more. So, but I don't know, like how many points are required for the ground reference. I have one point for the OEMs here present. This processing time, I don't know if it's possible or not. Can we reduce it? Because we have given 10 working days in our this new project, and that also is being questioned everywhere in the top management in NHI that it is very high. We want to report as soon as the data, the survey is complete, or maybe 2 days. In 2 days, we want this final report. So I don't know, is it possible or not?
So you see, the point herein is that how many parameters are you looking at? During the panel discussion, this is one point which I'll be raising. So, because if you're looking at certain number of parameters, we have developed a system which gives you real time. Real time. And believe me, when I said real time is real. There are certain parameters you can get real time, but the other parameters when you're talking about crack depth, crack width, portal size, average depth, maximum depth, all these parameters will require processing. Till now, we have not reached to that level where we can give it real time.
Neeraj, what I feel, there is a question like how we can increase the efficiency of data processing. But in my opinion, it is possible. If you are able to increase the capacity of the processing hardware, okay, like GPU is the main processing device which can increase the efficiency in data processing, or you can put number of processing stations like somebody was talking about that in 1 kilometer some GB is there, or 1.5 GBs or 100 kilometers, so much GBs. Then so what? If you are dependent on only one system, then it is a problem. If you can put 10 systems, then what is the problem? So I don't know exactly why you don't want to, but using one system, if you want to process 500 GB data, then it will be a problem for you. Definitely. It will take the required time. Yeah, then why not, like in CRI also, we have put 8 stations for data processing. We have a road asset management laboratory. We have recently collected the data for 23,000 lane kilometers, right? So we are decoding in some way. Okay. So in that way, we have 8 stations for that, so that we can reduce the time. So this is how we try to reduce the time for data processing.
Sir, couple of things I would like to understand. What type of processing or what assets processing do you require? Do you require the inventory to be processed? Because in most of the roads, we do not have inventory. So NSV has a good source where you have to process the inventory first. And then there are several distresses, and there are some sensor-based data as well. As rightly said by Chadhaji, sensor-based data collection can give you in real time. But however, the inventory asset inventorization, but it, sir, it is not well tested as of now. As per my experience goes, it is not well tested. Yeah, but it has to be mainstream, sir. It has to be mainstream. It is still at a project stage. But at project base you could look for, but when you are looking for an entire asset inventorization and then processing, you need to have the entire systems in place. As Pradeep Kumar Saab said, that you have to have a proper lab where all of these data collection processing units are there. You have to have a robust software and the hardware which will have those efficiencies. You have to have a good interpreter who could interpret the inventorization and the validation also. So it's not one which matters, it the complete unit which matters.
The other way you can keep this one?
Absolutely, sir. Not everybody can emulate that. You have to have experienced, like CRRI does, like we have been doing. There are very few people who knows and understand this entire gamut. So initially it will take a challenge, but then I'm sure with time, when you have all these, coordinates in place, you have the systems, you have the people, you have the software in place, and you have the right methodology and experience in place. I'm sure it can be done with time, graduate with time, not immediately.
So now the next speaker is Mr. Santosh Kumar. He is project manager, IRSM Hyderabad. संतोष रेडी या तो आपके पास 5 मिनट है अभी देन
कौन सा सर ये इसमें वायरस है इसमें वायरस है
ज़्यादा टाइम लगाएं डिस्कशन में तो दैट इज बेस्ट
yes sir I will try to reduce and sir कौन सा yeah this one So it's my privilege here to be presenting allied personalities and meeting with them and having a discussion in the lunchtime also. So now it's my time to tell about the experiences of NSV at IRSM. So yeah. So yeah, we are some having a branches at Hyderabad and Chennai, and we are working from both the locations, and we are giving services for all of the India and even other countries as well. So coming to us, we are IRSM, Indian Road Survey and Management Private Limited, is a joint venture of NTRO, National Technology, means National Transport Research Organization. So it is well known as Australian Road Research Board, which is 65 years experienced organization working for researching the roads and giving a means more number of manuals, etc., in the Aust roads, etc., etc. So from the Moorish beginning from 2009, IRSM is working in India. So maybe the one of the oldest NSV user in India, maybe probably after CRRA. So yeah, we are very happy to say that we are in 15th year now, 15th year working now. So majorly we are focusing in functional evolution and structural evolution, and we have a fleet of 4 NSV and 4 FWD, and even we are also working in axle load and like traffic service, etc., etc. So we are means ultimately our major focus is to give a complete solution in means maybe like making a payment management assistant or asset management system. And we are like ISO 9001 2015 means QMS certificate, and also the one of the first means of the organization having like ISO certified in the safety, also road safety management system. So coming to our experience, yeah, we are means since we are having the 15 years experience, we have worked around 5 lakh kilometers, means altogether like NSVFWD. Even we also works for international projects. So now we are seeing the map. So this map which talks about how much area, how much lane kilometers we have covered, and the prestigious projects what we have covered is like states which we are covered is mentioned here, like Andhra Pradesh 67 kilometers, Telangana, Tamil Nadu, and Odisha. So I'm very thankful for Odisha, particularly to CRRA. So because we got the opportunity and we successfully completed with the most guidance and support from the CRRA here. So and as usual in a year we used to handle like 30 plus projects, NHA projects particularly. So thanks for that. And yeah, now we have to see something bigger. So because like we are very much talking about like NSV or something FWD or like functional evolution, structural evolution, all those things. But what happens if all are mixed? If all are mixed, it's a combination of network survey vehicle and falling weight deflectometer. It's nothing but IPAVE, so intelligent pavement assessment vehicle. So this is a complete solution which give a information which covers network survey vehicle information and also falling weight deflectometer information. So surface and subsurface information will be togetherly checked, togetherly assessed with a single equipment. So it's a IPAV, and which is like used in means morely used in like our Australia NTRO. So means now you are seeing like what cameras means how like how it's like fixed everything. So particularly the lasers beneath the vehicle, which focus the deflection, and it creates the deflection bow. And it also provides like all the NSV equipment, means whatever the NSV equipment provides, the data will be provided. And also it can be provides like if it is clubbed with like a reflectometer, so we can get the data of reflectometer. If it is the module is added like a GPR, we can get the like a data of GPR, etc. So this is what the future. And if it's a single solution, means like we know the what happens if we are working with FWD, we have to stop for every like point, and what happens we don't know, like particularly in the part of safety. So we may hit with a vehicle, so because all vehicles currently moving in 60 plus kmph. So this is the better solution for the future in India. So now the part is about NSV. So why we are using NSV, and we want payment management system to be established in a perfect way. So in that way, so what are the important aspects we have to cover? So in that way, so if you're saying everyone talking about accuracy, reliability, yeah, it's fine, good. So but it is the first priority, first step which we have to focus, but there are a lot of milestones which we have to focus also. So it's about compatibility of all the equipments in India or in the market, so which to be integrated to the software what we are using. So what the tool we are using, it should be incorporated, because we are not using the single NSV or single equipment. We are using different equipment. So at the end, but all the end user is NHA or some particular authority. So this is the second step. And third one is technology and like equipment upgrade. So we are seeing currently like the market how it growing. So every year we are getting different technologies, different equipments, different modules. So how we have to think about the future, maybe after 10 years or after 15 years, the data we are, means particularly what is payment management system, how we are going to get the duration model. So we have to think about like how we are going to use all the 5 years data or 10 years data. So that we have to think. And like what happens if it is we are not able to use the robust data analytics in the model. So what happens? So that we have to think. So how we are integrating the data analytics. So this is a thought provoking, that's what means as an individual NSV user, in the way of NSV user, I just want to showcase to you. And the challenges for using, means for making all these steps success. So the common challenges in NSV, so just we are going to say data collection and calibration and module or equipment, and the data model what you are using, and results and the format, and analysis and reporting what we are talking about. So now coming to the data collection. So what is requirement in data collection? So what we require is a experienced driver and experienced engineer, and maybe like patrolling or safety vehicle to be used while doing data collection. If we are not using, what could be the effect? So the driving pattern is one of the biggest challenge we have to see. So if driving pattern what affected, what happens? Now just we went to gone through a small like test, like a comparison. If we are using a non-skilled driver or a general driver, and we are using a professional driver and the engineer who are very much aware about the NSV. So if just going with same path, if you're using, if you are using the NSV, if you are running the NSV, so what could be the output? Now it's in front of you. So the outliers is the one of the biggest topic which we are not at all touching. So that we have to think, because analytics is, means data getting is easy, but thinking about the using of data is very tough. So that we have to think. And next challenging topic is about calibration. Yeah, we are means calibrating vehicles, because it's each and every NSV, its guidelines provides a different kind of different kind of calibration techniques and processes. So each and every surveyor who are using the NSV must go with the all the calibration process on daily basis or monthly basis or quarterly basis or yearly basis. But how we are going to trust that? How you are going to trust that? So if I'm saying NSV user, I'm going, I've done the data calibration, is it fine? Because if same case, if you are going with any other equipment, definitely you are getting a laboratory certificate or something. So now there is a situation where we require something that kind of thing. So it's a thought provoking, means we, means as a authorities, they have to think about this area. And also of course in earlier morning also a lot of people talking about this. It's about repeatability checks. So how if it is means our NSV's repeatability or not, everything is we can see, and whether it's we can compare with the craftsman equipment, or how the results are performing. Means in this particular area, I would like to tell even like even our sir told. So in that means we are also the part in that survey. So we are very happy to be in the part of that vehicle. So and they given a good comments in that area also. I'm very happy for that. And coming to the modules in NSV, so this is also one important topic which we have to talk, because NSV is manufacturing. NSV is manufactured with a different kind of modules which we all knows. Like it may be cameras, it may be gypsy track, it may be anything. But these modules are like it may be a lima blazers, or it may be a bachelor cameras, or it may be like paymatric LCMS2 or something. So we are getting different equipments and it's getting assembled. It may be a Ramdas, or it may be Hakai, or it may be XYZ. But ultimately the input cameras or rotopulsar, DM, everything is same. So whether we are getting a proper accreditation for all these modules, what we are using. So that we have to think. So for suppose if in India we are having that kind of accreditation for the modules, then we are very much sure, yeah, what the NSVs we are using is strong, perfect. So that we have to think. um, Maybe authorities have to think about this area also. And now the part is data model. So this is very important subject, because ultimately NSV data whatever we are getting, it's just dumping into one server. So yeah, just 3 slides more, sir. Thank you very much. And yeah, so data model, particularly whether we are means the data model what we are using is able to read the uneditable data of NSV. Is it happening? So then the manipulations of whatever we are thinking, which can be eradicated. So like for suppose if you're using like ERD files, example I'm saying. So ERD files are extracted by the NSV. So it can be directly imported in Profile. It can be imported in any external softwares by ASTM or Rasto also. So then we can check it. Even it can be uploaded in HTM4 also. So inputs means actually if we are talking about how fastly we have to get the data from the NSV, that should be the fresh and live. Then we should think about how we are getting the data, whether we are getting the raw data or we should be a cooked data, something like in this format, in that format. If we are getting a raw data directly, so for suppose if we are getting a NSV data which is 5 meter interval or 1 meter interval, so directly import the data and upload it in RAM's portal instead of doing something formats or making all these things. Because if you are getting this data, this is the input. No one can change that. If you have the doubt, you can cross check with the ERD files. Then there is no problem at all. And interval, if you want to compare the data with some IRA to alert or IRA to texture or IRA to visual condition or anything, so you should be thinking about whether uniform interval is cross-checked or not. We cannot cross-check that 10-meter data with 1 kilometer data, our visual condition is in 500 meters and roughness is in 100 meters. We are comparing with both the things and we are saying it can be rejected. It cannot be. It cannot be. So input should consist of all required information in a single format. Why can't we do that? So because we are having like 5 meter interval data for suppose, so it can be directly generated. It can be exported from the NSV, then get it and export it. So it can be extracted in the next minute of the NSV survey. So but the next point will come in the results of format. So if we are having a proper guidelines in making this, like data collection and reporting, if you are having a proper guidelines like SOP or something, or even any like IRC code has been released, of course we are talking about this, so it's a good input. But just if it is having that, then it will be a good thing for us. And populating correlations between different parameters, whether we can do or means anything is found before rejecting that. If it is there, then it will be like lively. And if init format should be attributes, if it is there, then it will be good for the comparison. So just we would like to go for small comparisons for you. So if we are comparing with IRA and RET, so what happens? Now generally we are comparing IRA and rating and we are just trying to correlate that. So what happens if you are comparing that? So that could be the situation. The R square will be it will be very less. We cannot compare currently. It's based on our data what we checked in a random basis. Uh, so that is our observation here. And some more correlations generally we did, for suppose we taken some 3 lakhs 4 lakhs data points, and we check we gone with a comparison. So what we understood, like BT's IRA range will be in this level, and CC If it is in concrete, the range will be in that level. So generally, means our IRI limits are also talking about like good condition for BT should be in the limit of 2400. That, yeah, it's fine. But what about CC? How it is? How it could be matched? Because both are not same. So there should be different limits for both the payments. In the same way, it should be different conditions, because temperature is always a very major factor applying on concrete. So concave and convex shapes will be affecting that. So that also we have to think when we are making the IRI limits, how it will be correlating and all. And next thing is analysis. Yeah, it's completed. Final. So this is the final one. So sorry. So analysis and report. So yeah, means ultimately we are looking for the ground level reality, what we are getting from the ground. That should be the representing thing. So for suppose if some IRA is good and maybe visual condition is bad, so why it is good and why it is, means IRA is bad, that we have to research or we have to find out. It should not be like a counter, means some fingertips. It should not match something like that, and it should not be just like overlooked out. And the ability of model to analyze the outliers, why outliers are coming, so that our model should be having the like privilege to analyze the outliers, and how we are synchronizing the results, whether with a proper GPS, what is the accuracy, and how our model is categorizing the data, and how our model is performing the quality checks. These are all the important factors while making the analysis and report. So it's always just don't run behind the time. Better we have to think about the quality, and at the end, it's a conclusion. It's all about thought provoking process. Thank you very much.
Actually, Santosh, thank you for a very good presentation. But you should actually show your last four slides in at the first actually. आपने किया जो सबको पता है उस पे you have spent more time. But the things you want to actually convey, you have shown some slide on BC and CC. But sorry, I am not convinced with that slide. I don't know how you can compare the some BC riding quality value with some
No,
CC
no, sir.
riding quality values. I
Actually,
cannot.
like I would like to show
Because
that
both
it is not the like a B. Oh, it's not.
actually
Uh,
my just only concern is because network survey vehicle, whatever technology you are using, it is a very good tool for and very important tool for all of you. So don't try to confuse people and don't try to be confused with anything. Okay, we should promote this technology. Okay, so I could not get you why
no,
you
no,
are
means
saying that
what
IRA for BC is different and IRA for CC is different. What do you want to say?
Yeah, means actually, if you're seeing the limits of means IRI in IRC
Because I have
82.
written the full code IRC SP16 with my hand. Okay, I have put my 25 years of experience to writing that code actually. So I
Yes,
have
sir.
very good. We know that if you are using the riding quality on cement concrete road. Okay,
Means actually
okay.
starting limit you given the difference, sir, like 1800 and 2000.
That
But
we have given 2000 mm per kilometer for CC road and 1800 mm per kilometer for BC road.
yes, sir.
That is the standard says. So how it is connected with your IRA measurement with NSV? Measurement is something different.
It is not measurement. What I shown is not the measurement. Actually, it is number of values are contributing in this area. Maybe
I don't know that. Actually, please we will discuss later on.
yeah, yeah,
Maybe. Yeah. Another thing, very interesting thing he has mentioned in his presentation about the some equipment, the big equipment, which is a combination of NSV and FWD and GPR. So that is very interesting, and maybe in future we would like to see that equipment in India. But presently, this equipment is missing. So because we have a short of time, so we'll just I very quickly just inviting the Blue Oceans, Mr. Ashutosh, for his presentation, please. Because I know that because you all have come from the other part of the country, and we need to conclude the session within that time frame. So because of that only there is a some time restriction is there. So thank you very much.
yeah, thanks.
ಇದನ್ನ ಯಾರು screen? Hi, good afternoon. So thank you to Dr. Pradeep Kumar and CRI for giving us a chance to present here. And thank you for having us here. Blue Ocean Systems is a company which has been in business of IT for last 15 years. And over the last 5 years or so, we have invested a lot of time and effort in developing an equivalent of laser crack measurement system. So what I would like to do today is I would like to introduce to you an indigenously made crack detection system. Yeah. Hmm? Sorry, sir. While we are waiting for all these technological problems to get sorted, uh, what I'd like to tell you is that we have developed an indigenously made crack detection and measurement system, which has its own lasers, and its own camera systems. All of the programming, designing, development, research has been done by us locally in India. So what I'd like to show you is what it can do. Uh, problem? Huh? Is it on those two? PDF, the PDF still there, is it? The third parameter there is what kind of algorithms have been written. Am I using what has been my choice of language? Am I using Python? Am I using C++? Am I using something else? Typically, Python will be 60 to 70 times slower than C++. But programming in C++ is that much more harder because in Python, everybody's working on Python. So you have lots of libraries, you have lots of stuff available. For CPP, it is not like that. So let's hope this time things move smoothly. Uh, so we are a company called Blue Ocean Systems. We have made so far to the best of our knowledge, first indigenously manufactured laser crack detection and measurement system. So our system does the functions which you expect of LCMS. However, this has been made entirely by us. We have got all the components which are used in that. We have put them together. We have made our own design for the geometry. We had our own design for optics. So all the measurements, when it should be placed, what resolution will get. So based on all of that, we have designed a system. And I'm happy to introduce to you today in this room, first indigenously manufactured, designed, researched, developed, and manufactured system here in India. It does all the pavement profiling. It gives you a 4.1 meter width and 5,200 points per profile. It is capable to take data at 1 millimeter distance on the longitudinal direction. The point-to-point distance on the transverse direction is slightly better than 0.1, slightly better than 1 mm. So we are talking about 0.8 mm roughly per on the transverse side. And the accuracy of this system based on geometry that we have made on in the Z direction is better than 0.1 mm. This is design accuracy, and we have checked this with our own systems. Since there are no calibration systems available in India, we had to design our own calibration systems based on what other people are doing worldwide and all that. So we have done all of this ourselves. And why we started doing this is because we realized that there is a big requirement in India for network survey vehicles, and but the cost of ownership and the maintenance and other things, the processing, all those are big problems with that. So we felt that if somebody takes ownership of that whole system, everything from the GPS, the inertial navigation system, the cameras, photogrammetry cameras, lasers, everything, it will be a system like no other that is existing in the market. So our system, very happy to, I'll show you some videos after this. I'm very happy to say that for data collection, things now work with literally 1 or 2 clicks. With 1 or 2 clicks, you can start your work, end your work, extract data out from there. Same data automatically can be posted into your processing software. There, I will show you some videos today where you will see that the processing is actually 1 click. Uh, what has to be done manually after that is some things like topography, some parameters which the software cannot determine, or it is too expensive in terms of processing time for me to spend on it, because it is so much easier for a person to press a button called F1 and indicate the terrain is hilly, or it is rolling, or it is plain, rather than me analyzing thousands of frames and trying to identify and tell you the terrain is plain. It makes no sense. So we have made those kind of trade-offs in our software. But you will see today that I will show some of that to you, that you can see that this is all automatic. The other problem which was discussed today was the problem that the position of assets from the automated processing software is the position of the vehicle and not of the asset. So that is another problem that has been solved, and I'll show that as part of the video. That the processing, after processing, the lat long of the asset is the lat long of the asset, not the vehicle. So there is a technique called georeferencing. We have used that. We have applied that. We have coded that whole thing for our system, because one of the problems that we were facing, that everybody I think faces, is that there is not a lot of software libraries available to do this kind of processing for vehicle-based photogrammetry systems. There is a lot of stuff available for systems which are based on drones. Yeah, drones, you put a GCP, you can calculate, it's standard, you can just load up into your system and you'll get outputs. But for vehicle-based systems, because you are not seeing vertically down, you are seeing like this in a perspective. So that changes everything that you see, and you need to adjust for all of that. You need to adjust for spherical aberration, you need to adjust for chromatical aberration, you need to adjust for lenses, you need to address how your camera, how there is a tunneling effect in the camera on the sides. So all those things had to be addressed, and based on that, we have uh, we have spent a lot of time to do that, and I'll show some results out of that. So basically, we designed the whole geometry of all the components, found out what laser wavelengths will work best for us. We wrote all the software, integrated all the data of IMU, DGPS, profiler, machine vision cameras, and so our goal was to create a truly indigenous system which works without problems for you. And there are other big advantages of this also, because if the system is working on its own, a lot of problems that we face in field. We are doing survey, suddenly GPS will not work, but you would not know GPS data has not been collected till the time you start loading the data into your software in the office and see, oops, I missed the DGPS data. Or maybe you might have other problem. Your camera system did not work for a few shots, and now your camera's images are misaligned with your payment images. So all these problems happen, and then later on, what everybody does, as we've all seen and had experience to survey, is then you have to make compromises when you're providing the reports, make assumptions, guesses, best case scenarios, and all those have to come into play. So we have made this system, and I think since it's a fully local design, we can provide a lot of advantages to our customers, meaning that you don't have to wait for repairs. We do the repairs. You don't have to wait for spare parts. We keep the spare parts. You don't have to wait for any problems. Released today, NHA released some new requirement. We can do it quickly because this is our main business. This is where our bread butter is. So we are committed to this, and I think all of this has been. I'm very happy to say that we have a fairly reasonable and a decent working system that should be a significant improvement on in a lot of parameters. It may not beat LCMS in many places. LCMS has 8-9 years of experience, maybe 10-15 years of experience over us. But definitely, we have the advantage of writing a system from scratch with new technology. So I think there would be a trade-off there. We have surveyed totally about 30,000 kilometers to date, and of which data has been submitted and reported. So this is what basically a laser crack inspections crack measurement system looks like. You have a laser which is making a straight line on the ground on a surface. Then you have cameras which are taking using trigonometry and triangulation algorithms. We calculate the position of each point on this whole profile. So at one time, laser makes one 4-meter long line on the ground, and that line, depending on what plane it is in and what is the intensity and various of those things, the software then determines what is the profile, what is the height of every point in the profile. And when you combine 1000 points per meter and 5000 points like this for 4 meters, you get a 5000 point by 1000 point profile, which is among the highest profiles which can be made in the market. And all of this is being done at, so system is designed to run at a speed of around up to 100 kilometers per hour. If we go with the higher end cameras, we can also touch 160, 170 kilometers per hour without sacrificing the resolution. So those systems are available. Again, if that is something that we need to do, it can be done. So we have those systems available today. So what we did, we went one step ahead, and we made a platform out of it. So now we have a platform. We have the basic code and everything ready, and we can apply this to multiple other problem statements that can be seen. So tomorrow, you want to have a separate report just for say edge break. Yeah, we can identify all the edge breaks in the system automatically. You want to have a separate report just for expansion joints? Yes, we can do that. You want to do 10 centimeters before and after expansion joints? Yes, can be done, because that is the capability that this platform is creating. This what we see these applications and these platform being applied further to problems in other linear assets meaning railways, pipelines, cables. In fact, we have already started a pilot for inspecting cables for somebody. So, but okay, I'll come later. So inside the C3D system, there is a line projection laser. There is a light reflection system which captures the light which is reflected. There is a image cap that reflected light gets converted into an image, and then there is a data processing software, and then there is a software to reconstruct the 3D profile into a actual representation of the surface. So what have we done so far? The software, we have a completely automated or a very automated system for detection and identification of inventory. Lat long of each asset is determined algorithmically. The system also does automated detection of rigid and flexible pavement distresses like cracks, potholes, patching, raveling, edge break, and multiple other things. Rutting and roughness is also captured and measured. Roughness is not done by this system. In our system, we have a separate IRI, two IRI sensors which are placed in the wheel path. We believe that gives a better and a more accurate and repeatable result. So we are using that. The system also provides you geometry parameters in HTM4 format like crossfall, camber, rise, fall, etc., etc. And on the reporting side, it's a one-click processing and one-click report generation. What have we done so far? 30,000, more than 30,000 kilometers surveyed in the last 12 months. The best we could do was about 415 kilometers of data capture in one day. We have so far been able to process 350 kilometers of processed captured data in one day. We are at a speed of around 360 kilometers per day data processing on the average. Sometimes the sections might be worse and data might be worse. So we might, instead of 360, we could end up at 320, 330. But we could also go higher than that. But on the average is there. We expect to have a performance improvement on this over the next 6 months or so when we release a new version which has more which is faster processing algorithms. And in terms of inventory processing, we are doing about I think we do about 200 kilometers per hour. And this is 100% compliant to NHA and MOTS requirements at the moment. We have done all the integration, data collection at high speed. So laser vision system to collect all of this, asset inventory. So yeah, on the inventory side, we have about more than 150 assets that we are collecting, identifying, and recording. We have done our own in our own analysis of comparison of preparation of accuracy. What we have found is we have very low false positives, but we have some false negatives. And between false positive and false negative, we have about 96, 97% for the assets which occur commonly. So things like signboards, gantry boards, street lights, and such things. And in terms of other less commonly available assets, the accuracy is in low 90s or maybe high 80s. Uh, and the software also not only identifies all of these, but also classifies them. Thank you. But also classifies them in their in the category, whether it is severe, less severe, more severe. And yeah, I'll not do this. I just wanted to mention one more thing. Somebody mentioned that we need to have we need to look at new pricing models. So that is another thing that we are bringing to the table. Other than that, local repairs, maintenance, higher uptime, spares. So this is what. So since I've run out of time, I will not go into details of the geometry and all those. I will skip all of this. I want to show two things. I want to show some software images and one video. Yeah, 1.5 2 minutes. Yeah. So this is how our starting system looks like. From here, you can switch on, switch off every system, and the status of the system while the survey is going on also is reflected on the screen. So this is the screen you will see. You will see inside the NSP. It shows all your cameras. It shows your lasers. It shows your GPS, IMU, and there is a master switch. You switch on the master, everything will get turned on automatically. And also, you will be able to see the status of any equipment while you're doing the survey. So if you start seeing some errors or something, you will get all of that. You load this. These are some screenshots of process data. So this is the software in which you see after the data has been processed. This you can see the elevation data, you can see the reflectance data, that is your 2D data, and you can see overlaid fault detection and all that. You will on the right hand side, you can choose which parameter you want to see at that time. You can see, so like here we are looking at bleeding and cracking, bleeding and raveling. You can see in each band, raveling, skid resistance, all those parameters are calculated. Some of them have been calibrated, some of them are still being calibrated. So like this, you can see potholes. It tells you number of potholes. You can see here somewhere in the image, there are 2 potholes. You can see them in the elevation data also, and you can see them identified by the software. And it says what is their area, what is the total width, length, all those parameters, and individual dimensions also available. So I will skip a lot of this stuff and I'll just show one video. So this is the video of the inventory getting processed in real time. So we don't generate this video. This has been generated only so that we can show this to you. So while the vehicle is driving, the software is processing all of this. It is identifying on the left side, right side, multiple signboards. What the signboard is, if you pay attention, you can see here it's a gantry board. There is a gantry board. There is a road furniture, something. So within 30 meters or so, it is identifying, recording. And the most interesting thing about this is the lat long is of the asset. It is not of the vehicle. If you can see the different lat longs in different assets. And for assets which continue for a long distance, it takes the starting point of the asset, keeps on recording it till the time the asset changes, and then it gives you the midpoint, starting and end point of the asset in lat long. This is not a requirement at the moment, but we are doing this already. Yeah. So this is, I think this is a 30-kilometer road which got processed in about 5 minutes. Other than this, I would just also like to show you one small. So, uh, एक चीज और दिखाना था. Yes. Yeah, so I was saying one-click processing, and this is what I mean. Sure, sir. Yeah, so this data is getting loaded now, and as it is getting loaded now, this is one-click processing. This is the only button you. I'm sorry. Yeah. Okay, so basically, I don't know what's wrong, but basically it's a one-click process. You just hit process, everything is processed at the back end. Then after that, you come back to the software and see if there are any error. But it's not error thing, it's AI doing this. It's not 90% something for us. Okay, we don't leave a feature unless we are at least 85, 88% like this.
So thank you for this nice presentation. So the floor is open for the audience. Yes, please. Hi, Mr. Hello. 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 Hello.
I'd like to call my colleague Nishya if he's around.
Hello. Yeah. Hi, Mr. Ashutosh.
Hi.
Hi.
How are
Nice
you?
presentation. Just wanted to better understand. Could you give us some idea of the accuracy of the 3D reconstruction that you get, because it's a combination of camera versus camera plus laser? And how does that compare to the vertical resolution that typically one expects from laser-based detection?
Yeah. So I think you've asked two, three different questions. I'll parse them separately. So first is you've asked me for resolution on X and Y. How does it compare? So that if the camera is calibrated properly, we are getting centimeter level accuracy up to a distance of 10 meters. 10 to 20 meters, we are getting around sub-meter, maybe around 40, 50 centimeter accuracy. Beyond 20 meters, it is iffy. It is probably a meter or so. And in terms of Z direction, if we are using the photogrammetry cameras and they have been calibrated, after calibration, accuracy of the first 10 meters again is plus minus 5, 8 centimeters. You want to measure a distance. You will, in the first 10 meters from the camera lens, you will get about 5 to 8, maybe 10, less than 10 centimeter accuracy in terms of height if you'll take actual height and compare it. After it has been calibrated with proper GPS and total station calibration system. In terms of laser, so when you're looking at the surface profile, we are measuring that using our own calibration system. So in our tests, we have got a accuracy of, I mean, if we are claiming less than 1 millimeter, we are getting less than 1 millimeter. If you're claiming less than 0.1 mm, we are getting around that much. So we've been a little bit conservative in that. We are getting better than 0.08, but we are claiming less than 1. 0.1. So
regarding this inventory system, right, which you showed the video.
Right, sir.
So you are having any edge processing in the vehicle?
Any?
Edge processing in the vehicle?
No, this processing is being done in the office. We are not doing this in the vehicle. We don't see any advantage of doing it in the vehicle. What is the use of knowing what are the lat longs of street furniture in the
So it
system?
cannot be real time, right? You have to first record the video, then you have to
Yeah,
upload
yeah,
the
yeah,
video to the
yeah,
cloud, then
yeah, yeah, yeah.
download it, then process
Yeah,
it, and then
you can put it there in the system in the vehicle. You can put it, but then your PC becomes that much more expensive. Right now I can make the vehicle more economical by using a normal rugged PC. But if you tell me that I want to do the processing in real time in the system, then you are looking at buying a rugged system. Normal with the without 4090 a PC system is around 5 lakhs. You want to go for rugged version of that, you're going to talk about 12, 15 lakhs without any significant advantage. So but if you want, it can be done. It's not a problem. You can do it in real time in the system. The real time processing for distresses can be done in the vehicle. IRI is already being done. So I can't show the video, but if you had seen the video, the IRI processing is being done in the real time, right? IRI and what else? Routing. IRI, routing, all those things are being done in real time. You don't require a GPU for that.
Are you also doing the rut depth on the go in the real time? Are you calculating the rut depth?
If you want it, we can give it, but we are not doing it. We don't
No,
see any
no,
advantage.
on the real time basis.
Yeah,
You
yeah.
okay?
See, I
So
mean, if I'm doing it in my system in the office,
yeah.
all I need to do is take that software and put it in my vehicle.
So
So there's no,
basic identification you are doing for the distresses on the pavement, you are doing in the real time. But when you're talking of the calculations on the area and the depth, you're doing it in the office.
yeah.
And what do
That's
you
right.
do for the upload and the download times? Well, I mean, have you faced any challenges in
Yeah.
terms of
So
uploading and downloading the data? I mean,
right.
it's a huge data.
Yes, yes,
Yeah.
yes. Yeah, so we have just offered to one of our customers a custom built 5G data upload system which can upload 1 terabyte in about 4 hours
Yeah. So
over
one
5G.
terabyte in 4 hours. And what's the kind of
So
data for per
assuming
lane kilometer? If I am asking data for per lane kilometer
yeah,
for an LCMS system, what would be how many terabytes that would be?
again, LCMS system has parameters for you to reduce or increase the resolution. If we are going at a resolution of, let us say, 5 mm on the longitudinal direction and about 1.2 mm, 2 mm on the transport direction, and you have data coming out from cameras, photogrammetric cameras or regular cameras, ROW cameras, all of that put together should be in the range of 1.5 to 2.5 GB per lane kilometer.
Per lane kilometer.
Per lane kilometer. So if I'm talking about 1 terabyte, I'm talking about 400 kilometers that can be loaded. And anyway, systems do 400 kilometers. If I can load 400 kilometers while the survey is going on, by the end of the day, you could be sitting in NHI office tomorrow and processing today's data. You could actually start the data processing before you leave for home. And morning when you come, you have like 200 kilometers processed. Yeah, sure.
Time is very short. So the time is very short. So we will discuss afterwards. So thanks to all the presenters. And as we conclude this technical session two, we move towards our memento distribution ceremony to honor the contribution of our industry sponsors. I request our chairman of this session, Dr. Pradeep Kumar, to join me at the podium. Your help in presenting the mementos to our esteemed speakers will be much appreciated for their contribution. So first, I would like to invite Shri Rangali Rajshekhar, Managing Director of Coact Solutions Private Limited, Hyderabad, to receive the memento. Please. Sir. Next, please welcome Ms. Rakhi Ravi, Business Development Manager from Khanna Designers and Consultants Private Limited, Gurugram. Now calling Mr. Santosh Kumar, Project Manager for NSV from IRSM Private Limited, Hyderabad. Please welcome Shri Ashutosh Bhatnagar, Managing Partner of Blue Ocean Systems Infotech Private Limited, Mumbai. I would also like to invite any representative from Roadworks Engineers and Consultants Private Limited, Hyderabad, to collect the memento. Now, with the mementos presented, we wrap up technical session 2. I extend a heartfelt thank to Dr. Pradeep Kumar, our speakers, industry sponsors, and all participants for their engaging contributions. The insights shared today are invaluable and will undoubtedly contribute to future advancements in our field. Thank you for your participation, and I look forward to continuing our discussions in the subsequent panel discussion session of the workshop. Thank you all. Thank you.
Good evening, all. I request all the panelists to please occupy your seats on the stage, please. Good evening, ladies and gentlemen. It's my great pleasure to welcome you all to the today's panel discussion with esteemed panelists to discuss on evolving role of network server vehicle in road infrastructure and asset management. I'm Dr. Sampath Kumar, senior scientist at CRRI. I have honoring of moderating this session with an esteemed panel of experts who can bring a wealth of knowledge and diverse perspectives on the network server vehicle applications. Before we dive into the discussion, allow me to introduce our distinct panelists. We have with us first Sri LP Padiji, Chief General Manager at NHAI. Sri Padiji has over 33 years of experience in the implementation of major highway projects across various models, and he has been instrumental in bringing foreign investments to India's highway development. His expertise in asset recycling and national highway development project is widely recognized. Thanks for honoring. We also have with us Professor Praveen Agarwal, professor at NIT Kurukshetra, specializing in transportation engineering with extensive research and consultancy in the field. Professor Agarwal has contributed immensely to the transportation projects and has supervised multiple PhD and MTech dissertations. We have with us Dr. Pradeep Kumar, Chief Scientist at CSIR CRRI, known for pioneering work in implementing the modern payment evaluation technologies in India, particularly NSV for automated road inventory and payment monitoring. We have with us Mr. Tony Matthews, lead for road safety and asset management at TRL India. He has over 25 years of international experience. Mr. Matthews is a driving force behind data driven solutions for road safety and asset management across Asia and Africa. We have with us Sri Neeraj Cheddaji, Technical Director at Complete Instrumentation Solutions Private Limited. With a career spanning over 35 years, Mr. Chedda has introduced groundbreaking technologies in the payment and structural testing to India. He also introduced the NSV systems in India. He was also instrumental in setting up the accelerated payment testing facility at CRRI. We have with us Mr. Kasturi Srinivas, Director at Bentley Systems India Private Limited, an expert in building information modeling and digital twins. His extensive experience in digital delivery of infrastructure projects has made him a key player in integrating the technology with the transportation. Thank you all the panelists for joining us today. Today's discussion, we will try to explore the challenges, advancements, and the future of NSV technology in India, with particular emphasis on the data collection challenges and integration of some advanced technologies like AI and digital twins. So, thank you. Thank you, everyone. I would like to start my first question with Sripadi. I would like to take some NHI perspective. We have listening to a lot of uh, presentations, lot of discussions. Sir, we know that NHA is extensively collecting the data on various national highways and expressways. We also have a dedicated RAM cell. Once for all, we would like to know what are the challenges you have been facing for the collection of the data using NSV as well as the analysis.
Thank you. First of all, I must congratulate CRRI for the apt subject. This is very, very important and timely requirement. The NSV, the, the, the timing is, I cannot say is more emphasized because this requirement or importance of the NSV and other digital tools for intervention as well as monitoring and enforcing the maintenance requirements is now become very, very essential. As you know, after the turn of millennium, we have embarked into construction of highways in a long, big way. So about 50 plus 55,000 kilometers of high quality highways, 4 or more lane has been already constructed and more in anyway. And our ambition is to go and construct about more than 1 lakh kilometer of high quality standard world class highway network in the country. So while you are progressing in the construction front, the requirement of asset maintenance and management is very, very important. What we cannot actually ignore. Now the requirement of maintenance of the phase one and phase two projects is also coming to. The point is nowadays, as you know, NHI is also gone into a app called NHI One app, which is available in public. So it is in public domain. Anybody now can go to any site, go to the location and click, take a photo or video and can upload on that site. So that then it becomes, it is visible to everybody. So now the situation is not there that once there is a photo, one or two photos or cracks or things or everything are rating, you cannot, but you can chip on it. So this is what the scenario and who believe. And the aspiration of the public for a good quality road, more so when they are paying the toll, is also cannot take away their right for that kind of scenario. So looking into these aspects, how you enforce the maintenance? The construction has been done in many modes. One is called public funded, initially the government public funded, where the government money has been poured in and constructed highways and maintenance being done by the NHL or the agencies. Then we gone for BOT tool model, where the construction, maintenance, operation, they all for a particular concession period is responsibility of the concessionaire. Similarly, we gone for annuity model. Most annuity and BOT is no difference other than the revenue part. So as far as today our discussion is focusing on operation maintenance, all the BOT models, be it be a BOT toll, HAM or annuity, the maintenance standards or specifications are already given. And the specifications and the intervention period required and what kind of intervention to be done, they are all given in the respective schedule of the concessionaire. But we will check. For example, There is a provision in Schedule K of beauty project saying that in 100-meter stretch, the cracks more than 5 mm should not be more than 20% clear. Who will calculate? Can human eye check these things? No, it's not. Similarly, rutting as 20 mm or less rutting should be specified percentage of the total area. How it can be? Even if you see humanly, by physical verification, the contractor will consult, the contractor or concessionaire will definitely will contest that. So now the requirement of unambiguous data acquisition is become paramount. So that means the data, the raw data, there should not be any file. Every stakeholder has to accept that the data and veracity of data should not be questioned. The question may come into the intervention or interpretation. That has a different. One can do the work in one particular fashion, other can do other particular fashion, but the so far the data what you call the raw data that was ambiguous because there is a rougher meter, 12 rougher meter. Everybody knows this can be easily manipulated. You will come with some data, the system will come with some other data, then becomes day one go for manipulation or kind of distribution. NHI has actually introduced when you come for the TOT Model 1 in 2017, we consciously chosen that when you're going for asset monetization of 30 years, the O&M is particularly very, very important. At one go, we are asking for the upfront money for the total project revenue is being passed to the concessionaire. At the same time, the requirement, the importance of O&M is also very, very, I mean, you cannot ignore that. So taking that into concept in 2017, we have gone for TOT bundles. There we have introduced the NSB and extensively around 600 kilometers we have awarded in the first bundle in the first half of the 2018. There we have made it very clear. The data must be unambiguous. The raw data should not be questioned. The intervention level, how to determine the data, and what should be the interpretation, what are the codal provisions, how to interpret them, and what should be the remedial action to be taken. Those were also been first time in 2018 introduced in TOT. But that was only confined to the TOT kind of things. It's not coming to the BOT and other kind of. So now in NHI, at least I can say with thing, we have introduced in 2019-20 also, we introduced the NSB, how to go for, I mean, even if there is no provision in the concession agreement, NHI ourselves taken the onus of going for NSB and paying for the expenditure of the NSB part. Because the concessionaire cannot question, if you ask him to do, he will say there is no contract, I will not do it. But if you do ourselves, you cannot say no. The data, the only thing is data should not be questioned. The data should be very clear. So, in that sense, a asset management cell has been created. It's called Road Asset Management System. RAMS has been introduced, and we are doing it today from 2021 onwards. So, 2021 onwards, if you may correct me, but it has been done very regularly. And as a matter of policy, we have started that NSB has to be done twice in a year. Now, we are not. That's been done. Then the question of challenges come, how it has come. We have a data lake. Data lake is our digital platform whereby you can upload the data. Login is given to right from the concessionaire contractor, our authority engineers, our PIUs, PBs, and every stakeholder has a login for the data. So the NSB data which were coming, those were actually being uploaded by the once it is done by a NSB player. We have encountered a lot of NSB consulting firms. They are doing the data. The data collection is done, and there is not much complaint on data collection. But what is happening? Once the data is ready, the data has to be put up in a particular format, particular template, and particular abstraction. There comes the challenge. What happens? The agency which is doing the NSB, they only know the what you call the output. how to do the software of the output is generally it is a patented property of the. If my authority engineer or my staff or NHA officers who are there, they are not having that kind of knowledge to understand how to interpret the data and how to get them into a particular template in our system. So then when there are players, concessionaire have his own motive. I'm not blaming that with every concession like that, but certain concessionaires or certain contractors has a tendency to delay the intervention. So in that particular way, if there is a scope for what you call adjusting the data in a particular way, then NHA officer or the authority engineer is fully aware of what is happening. The data used to come, but what is happening if I'm going a road, I'm feeling manually feeling that there is a jet. But if I go and collect if I go to particular location and check the NSP data, I am getting 2000, 2200, 2400, that very below the benchmark roughness that's given. So that has raised certain points. Then we have introduced one consultancy firm sitting at headquarters and we vet the data, get the requisite clarifications, then he will validate it, then we'll put into this data lake system so that the engineer and the NHI officers as well as the concessionaires can have the data access which is validated. Unfortunately, that was also not did not give the desired result because in many cases what happened, the data which is coming willfully or because of ignorance, the data filling are not correctly done. When our consultant here asks for some queries, and he obviously cannot follow because there are so many kilometers, 50,000 kilometers in the country, then the data validation normally, gets delayed because there is a query, he will give some half clarification, so another set of query will go, he will give another clarification. Then by the time everything is validated and uploaded in data lake, the next cycle is off. In certain happened, it is lost the purpose itself. Now what you have done, we have taken a very bold kind of decision. We have now centralized everything. We have gone for the revamping of the NSP in a way where maximum 10 days. The data must be whatever you are collecting today within 40 hours. It has to come to our central unit. There, the agency's personality person and our people will sit, they validate the data, and within 10 days, on 11th day, this has to be placed on. Like, then we are going a step forward. Every project in NHI has a unique code. There has the data of the project. So once the data is uploaded there, five attributes right now because NSP gives lot than the attributes. Five important attributes: photos, raveling, rutting, cracks, and roughness. These are the five attributes we are now trying to see because these five attributes, if you are able to enforce in the contract, 95% of the project his user experience will be there will be sea change in that. So now we have started the activity. 1 lakh kilometer we are trying to do with a 1 lakh lane kilometer by December, and whole of the country's operation maintenance will be done through this three-dimensional. What you have seen, many people have shown. I think by now everybody knows what is three-dimensional kind of thing. Those data not only will be captured, this data will be placed in such a way that the particular contract agreement, what are the covenants given there, that will be that will be compared with the benchmarks figures here, and automatically the what you call notices will be issued to the contractor. So everything will be digitized. Then there is a particular date by which he has to complete. If doesn't complete, then another notice will be created whereby the work will be done on risk and cost of the contractor, and NHI will go ahead with final list of the contractors, get the job done, and we will penalize them for that. So there were challenges, and we are trying, we are major experience, and we are trying to do by way of very clear SOPs, going for this data interpretation and using the digital platform to the maximum extent and leveraging our data lake system whereby data survival. Thank you.
Thank you, sir. Thank you for highlighting the limitations, and I'm sure that revamped NSP program will address a lot of these limitations. Now I'd like to bring a little bit of international perspective to this NSV. Mr. Tony Matthew, this question is for you. You have experience of working in a lot of international projects. I would like to know how the data collection process in India is comparable with the international practices, and what do you think the gaps are?
Okay, thanks. So many issues or many points we discussed here today in terms of collecting data using NSV, processing it, using it for determining maintenance plans, routine and periodical, etc. That all aligns with international. It's all, whether it's Australia or I worked as a highways engineer, a payment engineer with national highways in the UK for around 5 years. So it's all aligned. They don't do anything different from what we are doing here or what we are trying to do here. But what is different is the quality and reliability of the data, the processes, and the outcomes. This and the one of the major factor is institutional capacity to deliver. Say, for example, TRL has implemented highways agency payment management system for UK. So all UK national highways are managed through a system. Yeah, UK is around the size of UP in terms of geographical size. UP, close to 250 people full time from national highway staff, contractors, and consultants are using the system for data collection, data analysis, developing plans, schemes, etc. So the institutional capacity is really huge, whether it's local authority, whether it's national highways. So in terms of specificity of data collection, which we discussed today, NSV, what they have there is they have a standard. They have a standard which gets updated every year for data collection, data presentation, data formats, etc. So that standards gets updated every year based on the emerging technologies, etc. Then they have not anybody can take an NSV and go out and do a survey. They have accredited in UK. TRL does the calibration of a data collection equipment, and once it is calibrated, certified, then they can go out and collect the data. As I said, TRL is a UK size of UP, so we probably would need around at least 15 to 20 such agencies who can calibrate, you can standardize this data collection equipment and say green signal, okay, you can go now. That capacity needs to be built in the country for to get consistent standard and quality data outputs. That is one. Then this institutional capacity as well. So more or less similar process. And again, when I look at these presentations today here by everybody, we focus too much on, okay, I need to get that position of science correct to a particular millimeter, GIS, location accuracy, etc. They don't do that. They keep it very simple. Their focus is on, I need to provide reliable and good road network for the people. That is their mission. So though they try to achieve that mission, they try to keep their process, their technology all a bit simpler, but they focus on institutional capability. They don't focus on too much on technological, they're not proud of like, we use a lot of technology to, they are proud of, okay, our network is smooth and is reliable. Our journey time is very reliable, etc. So yeah, that is the difference. Yeah.
Thank you, Raj. This all brings to a point where the importance of standardizing the process of data collection, I guess. Now I'll move to the next panelist, Professor Praveen Agarwal. Sir, we have a large network of road. We have, as someone said in the morning, we have got 65 lakh kilometers of road, but most of it, maybe 95% of it is rural roads. Maybe, and this is the most ignored part as well. NSV being a very costly equipment, how feasible is using an NSV for the rural roads, or do we have any need for developing a low cost network survey vehicle for rural roads? What are your thoughts on it?
Uh, we are talking of
road network of India, which is approximately 60 to 65 lakhs kilometers, mostly with rural road segment. Then we talk about the cost of the NSV. I talked to the industry person. He told me that the cost of doing NSV survey per kilometer is of the 1,000 to 1,500 rupees per kilometer per lane. So if we talk of 1,000 to 1,500 rupees per kilometer per lane, it means this costs me something around 1,200 crores, 1,000 crores of rupees to collect NSV data for the entire road network of India. Entire road network means 65 lakhs kilometers of road. 1,000 crores. This is with today's market cost. When we are talking of 60 lakhs of kilometers of road to be surveyed, I think industry will be able to do it at 1/4 or 1/3 of the cost. One thing. Second thing, uh, collecting data is not sufficient. Basically, that data should be available in the public domain for its utilization. I'm not very sure whether NHI, whatever data NHI is collecting, that is in public domain. May I request Dr. Padhe sir to highlight whether the data which we are collecting for NHI it is on public domain? Can I access it through internet?
No, the data it will be in TVs. It's very difficult to have that much kind of space because we are having our own thing. But only thing, whatever the outcome we're coming, we are notifying to the contractor. This is, I mean, very difficult. If you, even if I put the data, I will tell you one thing. When we go for a TOT bundle one, I have to give 9 TB data to the bidders in through, hard disks. So that kind of data is for analysis for fine. But if anybody comes from research institute comes for the data requirement, we are open to follow.
Sir, recently one of student was doing research uh, on the prioritization of road on the basis of distresses. The study was primarily on the village roads. We were not in a position to collect the data physically. So the data, we are at number 2 in the road length. The data he used was using the Federal Highway Administration site. It is a LTPPP site, long-term pavement performance site. The data is available on their site. If US can maintain their data on the public site and I can access US data, I don't know why I cannot access my own data. Number one. Number two, not only the distress data, I do require data related to weather, data related to traffic, data related to pavement composition, even maintenance history, subgrade characteristics, and of course payment distresses along with the GPS and the time at which the data was collected. All these data, not in the video form, but in the text form, percentage form, कितना क्रैक है, कितना रटिंग है, कितना IRI है, साइट्स पे रखा जा सकता है सिस्टमेटिक मैनर में। और मेरे को लगता नहीं है कि उसके लिए कोई बहुत ज़्यादा एक सोच की ज़रूरत है। Number second question was raised to whether it can be done for Indian village roads. Yes, it can be done. I said it's a cost of 1,000 crores of rupees only. हो सकता है 1,000 करोड़ एक बड़ी फिगर दिखे जस्ट टू अप्रेज द हाउस। हमारा आधार कार्ड जो बना था उसकी कितनी कॉस्ट लगी होगी, कितना प्रोजेक्ट कॉस्ट रही होगी? एनीबडी एनी गेस? आधार कार्ड मिशन जो गवर्नमेंट ऑफ इंडिया ने चलाया था उस पे हाउ मच वी हैव स्पेंड? We have spent around 45,000 crores. Clean Ganga project, how much we are having budget for Clean Ganga project? Around 20,000 crores. If we are having a project of 20,000 crore for Clean Ganga, if we are having a project for 40,000 crore for Aadhaar card, cannot we have 1,000 crore for road inventory of the Indian road network? One thing. Second thing, if we do not have this much budget at a stretch, but we can have normally after 5 years, 10 years, 8 years, we do require maintenance of the roads. Make it mandatory that prior to the maintenance and after the maintenance, NSV survey need to be carried out on each and every road. Right now, we are having approximately bare minimum maintenance cost of village road is also of the tune of 20 lakhs, 15 lakhs to 20 lakhs. And the cost of NSV is just 3,000 rupees prior to the maintenance, after the maintenance, which is less than even 0.2%, 0.3% of the project cost. So if the you can say system, or if the government looks like this, it can be a part of project to have NSE survey prior to the maintenance, after the maintenance. It will not only serve the purpose of collecting the data of the road network. In addition to that, we'll be able to justify the maintenance of the concerned road as well. I think I answered.
Yes, yes, sir.
Fine.
Thank you.
Thank you.
I
Thank you.
think you have covered my question. I would move to next panelist, Mr. Neeraj. You have been in industry for quite some time now. You have seen the improvements of NSV over the period of times. Could you highlight some of the benchmark improvements which you could see has changed the pattern of data collection? And also, please highlight we have seen some panelists presenting the integration of FWD with the NSV. Please throw some light on us to the audience about it.
Well, thank you so very much. I'll try to restrict myself because if I start speaking on the changes which have taken place over a period of time, I would be needing around 4 to 5 hours. Well, briefly, I will take off from where Dr. Agarwal left. Very simple thing. One cap does not fit all. You don't use the same tablet for different bimaris, you know. You can't use the same brush to paint the whole canvas. इसका मतलब क्या है? This NSP which you are using on national highways cannot be used for rural road networks. That's the very first question. It's not a matter of money. See, sir, we are having around 65 lakh kilometers. What are we talking about in national highways? 1 lakh 45 to 1 lakh 50,000 center line kilometers. Okay, if we even multiply it by 4, because there are 2 lane, 4 lane, and 6 lanes. So let me take it as 4. We are talking of what? 580,000 lane kilometers overall, right? We are covering 200 kilometers per day with one NSV. And we take 10 days or 8 days to analyze that 200-kilometer data. So we have to look at the magnanimity of the problem. Rural roads, are we interested in rutting? Are we interested in cracks? Are we interested in traveling? Are we interested in the other parameters which we are interested in the national highways? No. What I want in rural roads is simple equipment, network survey vehicles. अग्रवाल साहब आपने कहा मैंने डेवलप की है आपके पास भेजूंगा आप चलाइएगा उसको. The cost of running that vehicle is 300 rupees per kilometer. You are having 5.5 kilometer width, only 300 rupees to 350 rupees per kilometer. And what is more important there in it? What are we looking at when we are talking of rural roads? First, rutting देख लेते हैं. Rutting is okay, important for me. Potholes is important for me. Road condition, that means pictorial information is important for me. Roughness in terms of bumpiness in the road is important for me. Correct? And the crossfall is important for me. I can tell you, sir, all these parameters you will get in real time. Real time. All what you have to do is move the vehicle, give it to the driver. Let him move the vehicle. You don't need an engineer there. He will move the vehicle from one chainage to another chainage and collect the data. You can see it on real time on your screen, sitting in the office. What is the condition of the road? And then it will be on Google Maps. So if it is red, you can go there, click on the camera, you'll get the picture of the road. Where's the pothole? Click, you'll get the picture of the pothole.
Why is it important in rural roads? Now I'll explain that, sir. All the rural roads in Europe, throughout Europe, are being checked through this methodology only. Every 2 months, they do this. For example, if there's some deficiency, a pothole or rutting, whatsoever it is, and they give a contract or ask the contractor, or if it is in liability period, right? Then he has to maintain it. He goes there, he does it. Or if it is outside the liability period, you give a contract to someone to do, say, repair that road. अब क्या हुआ? A person down the line, shakes hand with the contractor, signs on the bill. It comes to your table. It has 4 signatures on below that, so you automatically sign on it, believing that they have done it correctly. Now, all what you have to do is ask the driver to go on that stretch of road, and you can see for yourself in real time कि क्या उसने repair भी किया है कि नहीं किया. All the roads sir, in Europe are being done this way right now. All the roads. वो उनका maintenance procedure है. It's a maintenance procedure. We are having 55 lakh kilometers. In this, sir, you can do it. NSV, this NSV which we use on the national highways, no, because you will be doing 200. And first of all, you can't run it there because हो सकता है paved roads नहीं हो sir. Lasers will not work on paved roads, right? So we have to find a solution, an appropriate solution for rural roads, for national highways and state highways, and also for urban roads. Urban roads को अलग कर दीजिएगा. So I would put it in 3 categories: national highways, expressways, and state highways. What we have currently, what we are doing, we should adopt that. Then you are coming to urban roads, which is around 1.5 to 1.7 million kilometers. There you have got another, we have another technology for that, wherein you can use a single camera rather than having 2 separate laser cameras. And that single camera will also provide a lot of information to you in real time. Third aspect is rural road, which is the key for us, which is key for economy also. National highways and expressways are certainly, but let us not forget that these are the arteries of our nation. Our economy is being run on these roads. If if, for example, when do we have a heart attack? When our arteries get clogged. If our roads get clogged, the economy will go to dumps. That is the reason when NHAI was constituted way back in 95, Paris, 96. है ना वहां पर पीछे कालमदी कुंज में I used to go there. Bhandari Saab was happened to be the first chairman at that time. And at that time, I personally worked with him. And that time the contractors were supposed to set up a lab. So list of 42 equipment was made. These equipment were kept in a lab, used for that project, and then left with the PWDs. Now, so coming back to the objective is that we have to have different kind of technologies for different applications. ये बहुत क्लियर है मेरे दिमाग में. हम एक टेक्नोलॉजी को यूज नहीं कर सकते, हम एक ब्रश से पूरे कैनवास को पेंट नहीं कर सकते हैं. सिंपल थिंग्स सिंपल, कीप देम सिंपल. हमें चाहिए ही नहीं इतना कुछ डेटा. आई डोंट नीड सो मच ऑफ डेटा फॉर माय रूरल रोड्स. आई जस्ट वांट to make it simple so that it is achievable and realistic also for me. So I have to be smart. Smart means specific, measurable, achievable, realistic, tangible. That is what smart means for me, right? Now, coming to the second aspect of it, so you talked about the new technology.
Quickly,
I saw someone making a presentation on ARB system, IPAVE system. I will say that is what India requires today. Why? Because we also manufacture falling wedge deflectometers. Maybe there are 100 of those today in the market, which I would have supplied. Or we also do network survey vehicles. I think so. There are ROMDAS vehicles everywhere, and they are being used everywhere. But what is important for me to understand today is if there are superficial defects, does it imply that the strength of the road is poor? No, not really, not necessarily. Or if the road surface is good and there are no defects, does it imply that my pavement condition is good? No, it can be weak. It can be vice versa. Please appreciate that. So it is very important to have a cumulative product like IPAVE,
right? Wherein we have got what is called as a traffic speed deflectometer. So you're measuring, you are finding out the strength of the road on the move. So you are not like following a deflectometer, you have to stop every now and then you meet with accidents. Here you are moving the complete comprehensive unit, which has got network survey, laser track measurement system, upgraded version, traffic speed deflectometer, and to top it all, 3D GPR in front of it. That's what I want. We want that this kind of a technology should come into India. No boreholes are to be made. Nothing is to be done because with the GPR, I am finding out the thickness of the layers of different payment layers. I am finding out the strength using my traffic speed deflectometer, and then I am also using NSV. Now, my question is answered. If I have got defects on the road, but at the same time I find that the strength of my road is good, right? That is important for me. That is where I need to go to. I have to take the corrective actions at the right time. I have to go into a proactive approach rather than a reactive approach. अभी हम क्या कर रहे हैं? What we are doing currently? We are behaving like earthquake scientists. Sorry, मैं भी वही हूँ, unfortunately. But that's what we are doing. Earthquake के आने के बाद, we write beautiful papers. But after the earthquake, the distresses have developed. Now we are taking action on it. We need to take action on it even before the distresses develop. That's the right approach to do it. And this can only be achieved, I personally feel, from a little experience traveling all over the world. And even recently, I was for a month in Europe and I looked at this ARP system. ARP system helps you to actually get the realistic picture of the condition of the road, be it the superficial condition, be it the distresses, be it the strength of the road. I think so. That is the technology one India has to adopt with the kind of network we have here. Total network in India is more than that of the Europe. Or even the rural roads, if you're talking about spans at lakh, 65 lakh, 6.5 million, you have to move forward with more aggressively, with right approach, and with simplistic tools, I would rather say. National highways, state highways, apart, rural roads on a different platform, right medicine for the right problem. That's how I look at it. And any questions, I'm open to answer those.
Thank you. Thank you for your very comprehensive answer. Before we take the questions from the audience, we'll have one last question to Mr. Kasturi Srinivas. Sir, you are an expert in the area of building information modeling and digital twins. What do you think? Can we integrate the data from NSV with the digital twins or the building information modeling so that we can have more informed decisions for the payment maintenance?
Yeah. I'll come back to the real time aspect a little later. Let me cover our experience so far. Around 7 to 8 years back, we implemented what we call a Odisha Road Asset Management System. In fact, thankfully, I know CRI has actually collected the data from the network serving vehicles, and we kind of use that to build what we call RIS, PMS, RMMS, many kind of systems we actually developed it. And similarly, we did a similar exercise again for industry for AP area RDC as well. Of course, we have international experience from other highway agencies, namely UK highway agency, etc. I think what we more focused after having deployed the systems, we focus more on the operational aspects. Like for example, to make it more realistic, because we talk about real time, should be realistic. So we started focusing on inspections, defect management, repair management, work orders, making sure that the defects are identified, been tracked well, executed well. All those have been now been tracked very well in our system, and of course network events and things like that. Those some things which we have added as a technology company. We added in our stack of our solutions. There are two aspects I want to explain. Um, we focused on come back to bridge modeling. Okay, what we've done is that we have now launched a bridge monitoring project solution primarily. What it does is that you basically run a drone-based surveying, and using photogrammetry basically generates a 3D models out of that.
And then once you construct a 3D model and you can put in an AR or a VR viewer, and you can do remote inspections, and that's something which is really getting popular. And there are many Indian companies working in Bangalore and Chennai actually doing for projects outside, looking at remote inspections actually. Of course, as an extension of that, what we did is that we can, because we have an open platform, we're able to host all these 3D models, which is kind of a reality model, and superimpose with the 3D models, which are actually coming from the CAD information, etc. What what we have now enriching that with the other sensor informations, which is basically installed on the deck slab or a pier, like strain gauges, other sensor information. Now, what we are able to manage the real time information coming from sensors, looking at real time alerts, and taking the relevant mechanism. That's something which we are really working upon. This is an extension of our road asset management work we are doing it. Recently, the last one is that we've delved more into AI and computer vision aspects. We actually through we acquired a company an year back where they're mostly working upon, like for example, we're using dash cams, being deployed on simple cars like Uber or Ola. Some drivers we have a selection of them, where we actually can take the feedback from that particular dash cams, and we have the ability to, with photogrammetry techniques, to identify the issues on the road network. So we are doing a real time exercise which is being deployed in the years. We've done a lot of tests with several devotees actually been using this technology. I think the most important aspect is that it's very dead cheap, very easy to do, very fast. You put in the data, and next day you have the results in place. We produce the data in an open format. That could be a GIS layer or a typical database layer and things like that. I think the advantage is what we found was that we are able to instantly give you a GIS layer of all the cracks on the road network. In fact, categorize the retroreflectivity of the paint markings, including signage, etc. So there are some very good results we have compared with the with manual reflectometer test. Very good results we have been identified with the technology we have done. And then same technology being used for looking the mistakes in the guardrail damages and things like that, paint quality, things like that. So again, the beauty here is that you're able to process data very quickly and look at what you want to focus upon. Like sir just now said that you need not look at every aspect. Right? Look for a specific thing, then you can mask it out and focus on those areas specifically. That's where the AI and that's what we're working upon. Yeah.
Thank you. I think it's a very good solution for the rural roads as we are talking to, because we might not be targeting the very high accuracy data, but rather we want the more data at the low cost. Thank you. Thank you, all the panelists. We would like to take some questions from the audience now. If you have any questions, please get them. Jyoti.
Thank you, sir. Just I want to share my experience regarding the PMGSY and low volume roads.
Please ask only the questions. Don't make any observations because we are running short of time.
Just I want to share my experience regarding PMGSY road data collection, sir. Because in Japan, we have seen earlier they used NSVs, now they are converting into smartphone based. Last 1 year, they collect almost 40 lakhs kilometers, almost with a smartphone. Because every smartphone will be having a 3-axis accelerometer, tilt sensor, as well as DGPS, we can connect it, as well as we have video collection also. So it's very high accuracy. Recently, we have seen in Europe also some of the councils have started with smartphone. So because we have getting everything with a smartphone, like class 2 IRI and basic parameters like MCI, maintenance condition index, as well as PCR, payment condition rating. Also, we have seen NRDA 4 years back, they have invested a lot of money for with along with the SIDAC
which is developed GIS-based SIDAC, GeoSADC, which is no data is available. The intention is we collect a lot of data, which is World Bank has given to a lot of states earlier last 5 years, like 5,000 kilometers, which is run in MPRDA, like Tamil Nadu DRDA and APRDA, because there is no data, so everything is blank. If you see the GeoSADC, everything is black, no data are available. And also World Bank and Indian government has made a road maintenance manual, which is like NHA templates. So everybody, like in India, we have a 26 states and we have 7,800 engineering colleges. Out of 6 lakhs are students. So that every state, if you give one Android phone and travel with all their local PMG7 roads, 65 lakhs kilometers can be collected. Gentleman promise I'm doing it within 1 month with 70 to 100 rupees per line kilometer. We can collect 65 lakhs kilometer directly uploaded, because already Japanese are developed bump recorder, which is 40 lakhs kilometer, is open source. With 100 rupees to 50 rupees per line kilometer, we can do 65 lakhs kilometer data within 1 month, having a Android phone which is validated the data in the acceptance. Thank you.
Any more questions, please?
Yeah, this is a question to Dr. Agarwal and actually an observation also along with that. So I represent Road Athena. Road Athena is into AI software for roads. So we extensively work for road networks. We started our work actually 2 years back on rural road networks and on AI implementation for that. Sir, what would you feel if a backpack NSV, what we call a backpack NSV, is given at a rate of 5 lakh of rupees only and installed on various I mean cars, which are government cars, and that device, if and the data is processed, as Mr. Neeraj is saying, less than 300 rupees per lane kilometer, then is it a good idea for the government and the agencies to actually go ahead and mark the data? Now, what I am also looking at is a complete GIS layering which comes automatically with that. I mean, there is no need for a separate system which gives you a complete, you need to see the problem here is all our data of roads is actually fragmented. NHAI is working differently, NREDA is working differently, all state government agencies are working differently. There is no.
Absolutely right. You are absolutely right. In fact, there is no coordination among different agencies. Number one. Number two, the only concern regarding the rural roads, the major road segment of the Indian road network, is to have a data. We do not have any data except national highways. So, in order to prioritize my maintenance activities, I require data. And by any means, if I can have distress data, I can have inventory data, of course, with geotech data. So that will serve the purpose.
So,
I'll tell you something very interesting, sir. Around 4, 5 years ago, the top management of one of the leading, I don't want to name them, Japanese automobile manufacturers, they came over to our office to have a meeting with me, and they said that we want to work with you to capture all this information. And interestingly, what came out was what they have done is they have already equipped their cars with sensors,
yes.
right? So they have 3D accelerometer there capturing the bumpiness. They put the camera there for taking capturing the images. Now they make the car buyer sign an agreement or a MOU that I have put it for your safety. If you have objection, I'll take it out, but it is for free. So, well, if anything is coming for free, no one refuses that. But in turn, what they are getting is at your cost, they are getting all the data which they can through a GPS, through 3D accelerometer, and this. So, this is, I'm going to tell you, is going to be the next thing in. All the cars will be equipped. This information will go to a pool, and this information will then be readily available.
So BMW is already doing that in the US. They are doing to all the premium customers. And in fact, now Mahindra and Mahindra in India would certainly is going to deploy this technology, vision based.
Honda has been doing it for 7 years. I
Thank
never
you.
wanted to name.
Okay.
Yeah, thank you. Do you have any more questions, please? Okay. If you don't have any questions, I would like to close by asking one general question to all of you. I think with the deliberations from the NS, we understood that the solution for most of the limitations we have is that we need to have a standardized data collection process. So maybe it comes in a form of IRC guidelines or something. So I would like to ask from all of you that what should be the components if we think of preparing some guidelines, what should be the components of that guidelines? If you can highlight maybe from the point of NHI where you are already collecting the data, or any of you, what should be the major components that needs to be addressed or highlighted in this guidelines?
I think there is one specific SP 127 is there, a rating of highways, which also gives you how to use the NSV and other things. The point is, we have to now understand what is the requirement. What do you want ultimately with the data collection? One is in a micro level, you go for enforcement of the maintenance covenants. At macro level, to prioritize the road maintenance and how to spend the money judiciously. There are two things. But looking way forward, ultimately we have to go for a performance based outcome contract, like we are going maintenance kind of thing. There, one single parameter has to be, the outcome should be a single, maximum two parameters, which should decide the condition of the road based on the O&M and the payments and everything should be linked. So that probably could be the payment condition index, ASTM based payment condition index. So taking that into account, what are the attributes, what are the parameters required for arriving at the payment condition index? Those details has to be captured in a very lucid way without going into so many other things. Then we have to also come up with the formulation how to quickly calculate the PCI without having much subjectivity involved in it. And it should be, I mean, we also probably have to go how to use the AI selectively. Because there is nothing so far in any of the course how to use selective AI. Probably that may also be introduced in a way so that at the end of the day, what are the data I am getting within a month or 15 days, I should get a picture of the whole project, picture of the complete payment at least, then a payment condition index to be defined. That should be the benchmark. We should aim for a document, if at all we are planning to come up with it.
I think I have left for this discussion. So I thought I should also speak, but I was silent because I want to listen all of you, right? So this is a very interesting panel session. Just I want to share with you what I feel as per our experience. We all are concerned about the maintenance of the road network. Okay, what is maintenance? I'm not going to teach you about the maintenance, but if you see, we collect the data. Uh, some people only collect the IRI data. Okay, riding quality is important for them. And some people, if you see, they are just concentrating upon the distresses. Okay, even they are not collecting the IRI data, what I am seeing in the market. Okay, and some people are collecting only the NSV data. That means they are collecting IRI data, routing data, and distresses data. Do you believe that with this approach, you are able to give a robust maintenance plan for your road network? The answer is no. So my request to all of you is that, as indicated by NHI also, that when you are doing something, okay, you should be very clear in your mind. Don't try to confuse or be confused. Like suppose you, if it should be clear to you if you have only distress data in your hand, and then you are not going to land anywhere. Or if you are only IRA data in hand, you cannot give the overlay on the existing road network. Okay, so that means like we have one recent code IRC 822023. In that, if you have IRA data and distress data, again, don't be confused. This, with the combination of these six important parameters, okay, most dominating parameters on our Indian road network, you can rate your road network from 0 to 100 scale. That can give you some idea for the routine maintenance, preventive maintenance, and up to certain level periodic maintenance. But if there is a demand of minor rehabilitation, major rehabilitation, or reconstruction, in that case, falling weight deflectometer data or Bankel main beam deflectometer data is a must. That means you need to evaluate your road network structurally also. So sometimes people ask me, sir, I have developed something very big. I am just collecting the rating the roads with based on the distances, and now I am giving the developing the maintenance and rehabilitation requirements. So this approach is not correct. So my suggestion is to kindly just look into the application part also. And as per this discussion, what we found that there is a strong need for the certification during data collection. Okay, that is must. And the second thing is that the requirement of the guidelines, okay, for the NSV data collection. And that we have already framed out the number of parameters which are required, like the templates. And I think there is a right time to sit along with the NHAI, because NHAI is working in a big way, and we certainly need advice from the NHAI for formalizing these guidelines. And another thing, interesting thing, would like to say that CRI, when we started collecting the roughness data, the first roughness measuring device, that is the fifth wheel bump indicator, was developed by CRI in late 1980s. Okay, and since then, CRI is the main calibrating agency for calibration of all response type road roughness measuring devices. And in the last 6 months, we have also calibrated 4 NSVs. Okay, not calibrated, we have validated also. That means now people are also coming to us. They are actually requesting CRI, seeing the strength and the capability of CRI. So we have recently calibrated one indigenous NSV, and before that we have calibrated one NSV which was from the Japan also. So the results are very interesting. Here I cannot just share the results, but I am not disappointed in any way. So this is what all I want to just share with all of you. Thank you so much.
Just his point on standards. Okay, there's a dire need for standards. Dr. Pradeep has suggested, has mentioned the problems actually. If you leave it to the industry to come back with, okay, you please do this way, it may not happen. So NHAI, Ministry, IRC should drive that standards, that what form, what format, what kind of data needs to be collected on different levels of the network. We can't solutionize in one sitting, like, okay, what is your solution? Say, I can tell you, rich countries, for example, Australia and England, they don't collect structural data in rural roads. Local authorities doesn't collect structural data. Only national highways collects structural data. So because maintenance is a science, right? So maintenance treatments respond to whether your pavement has structurally failed or functionally failed. So they have similar figure. National highways here is around 2% of the total road network, but carrying 70-80% of the traffic. So that probably needs higher level of attention and micro level quality monitoring in terms of data collection process, etc. And probably some state highways as well. But then what happened in UK, for example, UK national highways require data collection agencies to refer to certain standards for data collection and also local authorities. But very recently, they have taken out standard references for local authorities to collect data. Instead, like Road Athena AI is here. There are Road Metrics AI, again and invented by Indian people. They have adopted that. Like they only need surface distress. So these new AI based data collectors would be able to provide that, and they're trying it to develop not to leave behind the AI revolution. But road maintenance is a science, and in major road network, you have to go for standards, structural data, condition functional data, etc. And that has to come from the government. Government has to drive that.
Just a second. I just want to add one part to it. That is, I was discussing with the rural road network people here about the structural strength. You see, when these, as in the morning session, it was pointed out that initially we were talking about 200 vehicles passing by. Today we have 1,500 vehicles using the same road. We have to look at the volumes. In India, if you're looking at wo- population at 1.4 billion people, that means that is for to feed these people. That is the kind of the amount of load or agricultural produce which is to be carried from villages on to the different parts of the country. So that is one big impact which has come. And for that very reason, I most probably when what I got from the rural road authorities was that structural data has gained a lot of importance. Had it been in other countries, you see where there's which are sparsely populated, things are entirely different. We are looking at an entirely different spectrum here. That is the reason I think so. They have now introduced doing strength evaluation also of rural roads. Thanks.
Thank you. Thank you very much. Uh, as we come to close this insightful panel discussion, I would like to extend my heartfelt thanks to our distinguished panelists for sharing their valuable expertise and perspectives today. The conversation around NSV challenges and applications has been both enlightening and engaging. We have touched on critical issues such as data collection problems uh, across the different types of roads, and also the pressing need of guidelines and the integration of advanced technologies like AI and digital twins. This discussion will no doubt contribute significantly to the future development of road infrastructure management in India. At this point, I would like to invite Director CRRI to present a memento as a token of appreciation for our esteemed panelists. Sir, please welcome. First, Shri LP Padiji, Chief General Manager, NHAI. A round of applause. Next, I would like to invite Professor Praveen Agarwal, Professor, NIT Kurukshetra. Dr. Pradeep Kumar, Chief Scientist, CSIR CRRI. Mr. Tony Matthews, TRL India. Mr. Neeraj Chedda, Technical Director, Complete Instrumentation Solutions. Last but not the least, Mr. Kasturi Srinivas, Director, Bentley Systems India Private Limited. Uh, please join for a group photograph, please. Please come in the. Thank you all once again for your time and invaluable contributions. I request you to all join for the concluding session.
ठीक है, एक आपका नेक्स्ट मंथ और है ना रैम्स का भाव इसमें भी 3-4 मतलब हमारे यहाँ पे से बिल्डिंग हो रही है हमारी ये टीम आपके यहाँ गई लास्ट वीक होके उन्होंने 2-3 इसका 90 आ रहा है 96 आ रहा है
ठीक है सर, एक मिनट दीदी, मेरे को क्या मेरे को बुलाओगे?
हाँ
मुझे क्या करूँगा?
तो आपकी कंक्लूडिंग रिमार्क्स है ना
कुछ भी वक्त देना क्या, किसी ने कुछ बना के दिया नहीं मॉडरेटर ने?
भूल गए होंगे कुछ राइट अप करो स्टार्ट नहीं तो सब चले जाएंगे सब लोग सामान वामान खा लिया
हाँ, hold the please sit down for the concluding remark by Director CRI.
Good evening, everyone, esteemed dignitaries, invitees, colleagues, and friends. I am Dr. Vidhi Vyas, Scientist, Payment Evaluation Division. I thank you all for your active participation today. Before we conclude, I would like to invite Honorable Director CRRI for his concluding remarks.
बिठा तो लो
I request Shri Sunil Jain sir and Pradeep sir to please join the dais.
कर देता हूँ सर, क्लोजिंग रिमार्क्स देंगे, ठीक है? या yeah, good evening to all of you. Thank you very much. Just I am giving you the briefing of the one day workshop what we have done today. We have inaugural function, chief guest Shri D. Sarangi ji, and guest of honor Professor Praveen Kumar from IIT Roorkee, and we have listened both the dignitaries, and we have also noted the directions which they have given related to the health monitoring of the road infrastructure. And then we have a technical session one, where we were having 5 presenters from Mr. Dr. Amit Munjal from NHI, Dr. Sameer Saran from ISRO, and Shri Satyakam Sahu, Regional Director from Lee Associates, and Professor Aditya Meduri, IIT Kanpur, and myself. We have just given the some points we have highlighted related to the NSV data collection practices and the ongoing projects. And then we were having 4 presentations by the industry sponsors, Mr. from Messrs. Coact Solutions, then Rakhi Ravi, Santosh Kumar, and Ashutosh Bhatnagar, and the followed by the panel discussions, where Shri L.P. Padiji, CGM NHI, Professor Praveen Agarwal, INIT Kurukshetra, myself, Engineer Tony Matthews, TL India, and Shri Neeraj Chadda, Technical Director, Complete Instrumentation Solutions, Gurgaon, and Shri Kasturi Srinivasan, Business Development Director, Medley System has participated. If we just see what we all discussed throughout the day, so just I have noted down few things. The major concern about the data collection using network survey technologies, as I have mentioned earlier also. So one part we have discussed about the technologies, okay, and the second part was the challenges we were facing, and the third part was the development of the guidelines, and the fourth part was the future directions. So what we have discussed, the one concern for all was the data integrity. What I have just noted down or summarized, the data integrity was very important, and we have few suggestions. Like I have mentioned that the data encryption can solve this problem. in some way, so that when you are, or the real time data transfer, okay, in some way in future, like when you are collecting the data, and if you are data transferring the data from NSV to the server in a encrypted format, okay. So in one way, this problem we can address in future. And the second point we have discussed about the some kind of analysis, like suppose we want to increase the speed of the data analysis. There were some issues with by some vendors, the people who are involved in data processing, they are able to collect the data, but there is some issues like the time is more. So I believe that in future we will have more advanced hardware facilities and AI based solutions in some way, which are lacking right now. So this problem will be gradually solved in future. And there is a need of standard guidelines. We have already start working, and Mr. Munjal from NHI is very close contact with CRI, and we have decided to actually to discuss time to time, so that very soon there will be some guidelines on data collection techniques, like what should be the template of data collection. First we will start with the some kind of basic NSV specifications, okay, what should be the minimum requirements, or what minimum standards they should follow. Then we will go come to the some certification, training certification is also required, the person who is collecting the data, the minimum qualifications, and then all these things we are going to incorporate. Then template will come, and then analysis tools actually. And as per my suggestion right now, if you all agree that we should not just give the data collection templates or the data parameters, actually we should at least give some analysis also. Like suppose you are collecting the 6 parameters, you should give the PCI values also as per the standard guidelines. So all these things we are going to incorporate. Just a minute. And the other thing is the institutional capacity. This point was also discussed. This is a strong need to develop this capacity. Training certification I have also mentioned. And one very important point mentioned by Professor Praveen Agarwal from NIT, that the data availability in public domain, that is the NSV survey, we are conducting. So much data information is available, but some students are lacking, they are not able to use that information, which is the national information, that we should also think in this direction. So these are some points. And one more point was given by Mr. Neeraj Chadda, that like network survey vehicle, if you are using high-end network survey vehicles, it is suitable, most suitable for national highways or expressways. You cannot use these vehicles on rural roads. For that purpose, you need a different solutions. What people are doing, they are using the same NSV on the rural roads, and then they are saying they are not satisfied with the data. Okay, so this is the one thing. So many things actually. This is a very successful workshop, I feel, and I'm really really happy. And other things were like real-time data assessment techniques need to be developed. Somebody was asking about this, and some AI-based maintenance solutions we have all discussed. So these were all, maybe few points I have left. I will again recall it, and then I will make a summary. And definitely we are going to make a good report on this, the outcome of this workshop, so that we can connect with the stakeholders, maybe some industry people. Again, we will discuss with NHEI, PWDs, and ministry, so that a good guidelines will come out of this. With this, I thank you all for joining this workshop, and thank you very much. Thank you.
Thank you, sir. Now I invite Chief Scientist and Head PED, Sunil Jain sir, for his remarks.
Dr. Pradeep already sum up all the points which has emerged from the conference. In fact, I have noted down some points. The workshop achieved its objective, what we have discussed, and what is emerged from the workshop. The various points are sharing knowledge and best practices in NSV applications. We have understand so many things about the NSV, what type of data should we have to collect, where that data is applicable, whether the NSV data is applicable for the national highways or rural roads. Basically, there is a need in the country to develop low cost data measurement techniques In fact, in CRI, long back, we have done a in-house project in which we are trying to develop a vehicle or an e-rickshaw type vehicle from where we can collect data from the rural road at very low cost. So that is the need for the day because the 90% road network is the rural road. As Kadhai ji is saying ki that we are having only 1,45,240 kilometers of the national highway. And NSV technique really very costly and it costs too much. So there is a need to develop low cost data measuring techniques. And this workshop is very good for making a collaboration between the experts, industry, and stakeholders. So, like that, when we will collaborate, and even academicians and NHI also are required to develop the guidelines so that a generic guidelines can be developed for this country. Collaboration and knowledge sharing and effective implementation is possible only through all when we collaborate with each other. With this, I conclude my remark and thanks to our speakers, panelists, and moderator for their valuable contributions. I also appreciate the active participation and engaging questions from the audience. Very good questions has emerged, and our panelists have given their best solutions and answers of all the solutions. I further acknowledge the support from our sponsors because आप जानते हैं कि जब तक स्पॉन्सर्स नहीं होंगे इस तरह की जो ऑर्गेनाइजेशन और वर्कशॉप्स हैं वो करना बहुत मुश्किल है। तो हमारे जो 6 इसके अंदर जो स्पॉन्सर्स हैं मैं उनको बहुत-बहुत धन्यवाद देता हूँ और बल्कि ऑडियंस से कहता हूँ कि ताली बजाकर उनका स्वागत करें। थैंक्स फॉर अटेंडिंग दिस वर्कशॉप। गुड लक एंड जय हिंद।
Thank you, sir. I now request Honorable Director CRRI for delivering the concluding remarks.
Good evening, everyone. So I know it has been a very fruitful deliberation, and I don't want to really prolong the valedictory session. We have deliberated enough entire day. The workshop started out of one of the workshop. So that was the workshop on FWD, and I think Dr. Pradeep Kumar got motivated. He was really charged, and that time he asked, I said, "You tell me a date and fix it because this is basically the mandate of CRI. I'm very happy for the generous sponsorship participation across the organization and both Dr. Pradeep Kumar and Sri Sunil Jain, they have highlighted the various discussions. And definitely, I believe that we need to develop a document. Uh, the new committees are formed. So, in the next coming tenure of the committee, we try to develop a document which we can do. CRI in association with all people, those who are a part of the workshop, we can take your input and develop a document which can be submitted to Indian Road Congress for the appropriate committee to take a call on it. It is very essential because today, the workshop has participation by people, those who are handling, those who are using NSP. But in field or in different locations, maybe people do not have access to all the kind of knowledge. So we try to develop a guideline which is very simplified. And during inaugural, in fact, DGRD, Mr. Dharmanand Sadangi, he said he is very keen to look towards the workshop recommendation. So we try to develop a brief report of the workshop, the entire deliberations, key recommendations, which is submitted to Ministry and IRC for the follow. Other than industry, I'm very happy that we have participation from NHI, which is a great user of the NSP data. There were concerns about the data handling, but I believe in India now, at least AI, ML, and data handling is something which is not very difficult, but we need to put trust on that, how to clean data, how to process data, or whatever the data handling issues are there, how they are to be addressed. One point which was raised, making some of the data being shared in an open platform, we can definitely look towards it. But then I said that there has to be a mechanism.
You cannot just distribute the data to everybody. So it is to be said only to people, those who are going to use it in a systematic, structured way. So through, I mean, there could be mechanism like Indo Highway Capacity Manual is one. Now the document is available. So we say that once the document has been completely utilized, completely published, so after that, it's not a bad idea to share the data. So we'll deliberate internally what could be the mechanism of data sharing, and then definitely like if there is a mechanism of acknowledgement, acknowledging the CRI inputs, the data sharing should be possible. So internally we try to figure it out, and in fact for development of the document we will also require your inputs. So when you develop, we prepare the draft, we will need contributions from organizations which have been part of this workshop. So I urge that you please share the documentation available with you, the templates, the SOPs which you are following. So we are not just completing with this one workshop, but the effort can lead towards development of the draft guidelines that can be submitted to IRC for the purpose of consideration and approval. So once again, with that note, I'm very thankful to all of you. Throughout the day, you have actively participated, and still there is lot of energy. Like no one looks exhausted. That's the best part. Still, I can see people smiling. So that's the basic success of the workshop. And thanks to the entire PD division, the organizing team, those who have put all the best efforts to put up a good show. So thank you very much, and all the best to you. Thank you.
Now, thank you, sir. Now I request Director sir to please present the mementos to the moderators. Dr. Neelam J. Gupta, Senior Principal Scientist, Payment Evaluation Division. Dr. Deepa S., Scientist, Payment Evaluation Division. Dr. Akash Gupta, Scientist, Payment Evaluation Division. Dr. Sambat Kumar, Senior Scientist, Payment Evaluation Division.
Dr. Vidhi Vyas. So we request Dr. Pradeep to present a memento to our director, sir.
I hope you found the discussions insightful and engaging. Thank you everyone for your presence and participation and wish you a great day ahead. Thank you.